morning, everyone. Our chief guest has arrived and we heartily welcome him. I request everyone to kindly take your seats and keep your mobiles either switched off or in airplane mode. Honorable Chief Guest of today's workshop, Director General DGMS, Shri Ujjwal Ta. Guest of Honor, Deputy Director General, Northwest Zone, Udaipur, Shri R.T. Mandekar. Chairman and Managing Director, Hindustan Copper Limited, Shri Sanjeev Kumar Singh. Director Operations with Additional Charge Director Mines, Hindustan Copper Limited, Dr. Sanjeev Kumar Sinha. Professor Debashish Dev, IIT Kharagpur. Honorable dignitaries from Directorate General of Mining Services, Dr. I. Satyanarayana, Director Ajmer Region 1, Shri K. Ravindra, Director Ajmer Region 2, Directors DGMS, Shri Umesh Madhukar Rao Savarkar, Shri Vinod Rajak, Shri Praful Ranjan Thakur, Shri Tom Matthew and Shri Sanjay Kumar Gimedi. Deputy Directors DGMS, Shri Nagendra Ram Shri Ram, Shri Vishal Goyal, Shri Tejavat Naresh, Shri Tangalapalli Hari Prasad, Shri Upender Rapolu, and Shri Rajneesh Kumar Seegar. Honorable dignitaries from Hindustan Copper Limited Corporate Office, Executive Director Shri Umesh Singh, from Unit KCC, Executive Director and Unit Head KCC, Shri Ghanshyam Das Gupta Sir. Executives from KCC, MCP and ICC units, eminent speakers from prestigious organizations, coordinators, delegates, ladies and gentlemen, I wish you all a very good morning. Myself, Dr. Deepika Khurana, gynecologist and AGM Medical and Health Services, Khetri Copper Complex Hospital, feel proudly privileged to welcome you all to inauguration ceremony of this national level workshop on rock mass classifications and support design for improving stability of working in metal mines. Today, we gather not only to share knowledge, but also to strengthen the foundations of safe and sustainable mining practices in India. We are honored to have with us distinguished guests and dignitaries whom we would like to be escorted to stage. First of all, I request Executive Director and Unit Head, Khetri Copper Complex, HCL, Shri G.D. Gupta Sir, to kindly escort Director General DGMS, Shri Ujjwal Ta Sir, to stage. Welcome, sir. Next, I request General Manager Mines and Mines Agent from KCC Unit of HCL, Shri P.D. Bohra Sir, to kindly escort Deputy Director General, Northwest Zone, Shri R.T. Mandekar Sir, to stage. Okay, we welcome our Chairman cum Managing Director, Hindustan Copper Limited, along with him. Please, sir. Now I request Shri Binayak Sahu, AGM Mines from KCC Unit of HCL, to kindly escort Professor Debashish Dev from IIT Kharagpur to stage. I request Shri Tarun Kumar Dehlawat, AVP Mines, MS Shri Cement, to kindly escort I. Satyanarayana, Director Ajmer Region to stage. Welcome, sir. Now I request Shri Bhupesh Paliwal, if he is available. So I call upon Shri Savarmal Meena, HOD Messrs ASI Industries, to kindly escort our Director Mining and Operations, Dr. Sanjeev Kumar Singh, to stage. Welcome, sir. Thank you all. Now, as a mark of respect and tradition, our dignitaries will now be felicitated with safa, shawl and flower pot. This gesture reflects our deep gratitude for their presence and contribution to mining fraternity. I request Ms. Khushi and Ms. Renu to please bring the shawl and safa. I first request Chairman and Managing Director, Hindustan Copper Limited, Shri Sanjeev Kumar Singh, to kindly welcome Director General DGMS, Shri Ujjwal Ta, by adorning him with shawl and safa and presenting a flower pot. Thank you, sir. Now I request Director Operations and Additional Charge Director Mining, Hindustan Copper Limited, Dr. Sanjeev Kumar Sinha, to kindly honor Deputy Director General Shri R.T. Mandekar, sir, by adorning him with shawl and safa and presenting a flower pot. Thank you, sir. May I now request Director DGMS, Ajmer Region 2, Shri K. Ravinder, sir, to kindly welcome Chairman cum Managing Director, Hindustan Copper Limited, by adorning him with shawl and safa and presenting a flower pot. Thank you, sir. I now request Director Ajmer Region 1, Dr. I. Satyanarayana, to kindly welcome Professor Debashish Dev from IIT Kharagpur by adorning him with shawl and safa and presenting a flower pot. Thank you, sir. I now request Shri Nirbhaya Sancheti, Director Messrs SMS Limited, to kindly welcome Director Operations in Mining, Messrs Hindustan Copper Limited, Dr. Sanjeev Kumar Sinha, by adorning him with shawl and safa and presenting a flower pot. Thank you, sir. I now request Executive Director and Unit Head KCC, Shri Ghanshyam Das Gupta sir, to kindly welcome Dr. I. Satyanarayana, Director Ajmer Region 1, by adorning him with shawl and safa and presenting a flower pot. Thank you, sir. To symbolize the dispelling of darkness and the illumination of knowledge, may I invite our dignitaries to kindly come forward for ceremonial lighting of the lamp. And I would request Shri Vinayak Sahu and Executive Director KCC to kindly help and escort our dignitaries to light the lamp. We would also like to pay homage to Goddess Saraswati.
Ya kundendu tushara dhavala, ya shubhra vastrabruta, ya veena varadanda vanditakara, ya shveta padmasana, या ब्रह्माच्युत शंकर प्रभृतिभिः देवै सदा वन्दिता, सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा। शुक्लां ब्रह्म विचारसार परमां आद्यां जगद्व्यापिनीं वीणा पुस्तकधारिणीमभयदां जाड्यान्धकारापहा। हस्ते स्फाटिकमालिकां विदधतीं पद्मासने।
May Goddess Saraswati shower her blessings on each and every soul present here. Moving further, for beginning of workshop, may I invite Director Operations and Mining, Messrs Hindustan Copper Limited, Dr. Sanjeev Kumar Sinha to deliver the welcome address. Dr. Sanjeev Kumar Sinha.
A very good morning to all of you. Suprabhat. Honorable Sri Ujjwal Tahaji, Director General DGMS. Honorable Sri R.T. Mandekar ji, Deputy Director General DGMS. Our Professor and Guru from IIT Kharagpur, Professor Dev. Our beloved CMD, Hindustan Copper Limited, Sri Sanjeev Kumar Singh ji, Sri Satyanarayan ji, Director Mine Safety, DGMS. It is both an honor and privilege to address the esteemed gathering today on seminar on rock mass classification and support design for improving stability in underground metal mining operation. At a time when underground mining in India is witnessing renowned momentum driven by the demand of critical minerals, technological advancement, and need for sustainable extraction, this topic stands at the very heart of safe and efficient mining practices. As the Director Operation of Hindustan Copper Limited, an organization whose legacy is deeply rooted in underground mining in metal, I consider this interaction an opportunity to reflect our experience, share our learning, and call for a collaborative approach to strengthen the science and practice of rock engineering. Today's India's mineral wealth is yet a large portion of our base metal and critical mineral reserve lie deep underground. As the global economy shifts towards renewable energy and our requirement of electrification, green infrastructure, and strategic minerals grows, underground mining will play an important role in securing mineral self-reliance, reducing dependency on import, optimizing land use, minimizing surface environment footprint, enhancing resource recovery from deeper level. As with greater depth comes more complexity. One of the biggest challenges we face in underground metal mining, especially in copper, lead, zinc, nickel, gold, and other hard rock environment, is rock mass stability. The deeper we mine, the greater the influence of stresses, geological discontinuity, water problem, and ground pressure phenomena. This brings us to today's theme, how to properly classify rock masses and design suitable support system that can enhance stability, productivity, and worker safety. A robust classification system not only informs support design, but also assists in selecting best mining method, estimating stand-up time, predicting ground behavior, planning excavation sequences, identifying risk-prone zone, and optimizing production schedule. We have in Indian geology, several challenges, which include highly variable rock masses, deepening mine, presence of weathered formation, multilithological sequences, rock burst and squeezing condition at depth, old legacy working, water-bearing fractures, and sudden inflow, constraint on large-scale mechanization in older mines. These demand we go beyond textbook application of classification system and adopt site-specific engineering judgment combined with real-time ground monitoring. Rock mass classification such as RMR, Q system, geological strength index have become essential tools that allow engineer to quantify rock quality in a structural manner. They help us to convert complex geological reality into practical energy engineering guideline. We must design in such a way that our underground support system, which include rock bolting, steel sets and arches, props, cogs, mesh straps, backfilling, etc., are designed in the best way. In our Malachkhand copper mines, we have started filling of stope through a state-of-art technology through a paste fill plant of 3 million ton capacity. We are also going for another 3 million ton capacity in that place. With our expansion plan of 12 million ton by 2030, our challenges are more, whereas opportunity is also there. Through such seminar, we will discuss all these issues during this long day discussion. No classification or support design can succeed without a trained personnel. Hence, we require in capacity building our people who are working on different geotechnical interpretation. We require engineer who has practical skill in support installation, who can introduce modern monitoring tools, strengthen the competency of mine foremen and supervisor. We need people who can conduct refresher courses and external training sessions. Encourage our cross-functional learning between geology and mining team. We must acknowledge that rock engineering is highly site-specific. Therefore, collaboration is essential. I urge academic institutions like IIT Kharagpur, research organization, mining companies like Hindustan Copper, Hindustan Zinc, MOIL, who are based in underground mining, equipment manufacturer, and government agency, and our MDO and our partner, business partner in mining to come together and develop India-specific guideline, empirical chart, and best practices that reflect our unique geological condition. We need more research in deep mining stress, rock burst prediction model, time-dependent deformation in hard rock mining, support performance in varying ground conditions, monitoring technology, and long-term stability of backfilled stopes. Dear all, in underground mining is not merely an engineering discipline. It is an art refined by science, experience, and human wisdom. As we go deeper, the challenges will grow, but so will the opportunity. With robust rock mass classification, intelligent support design, and advanced geotechnical practices, we can create underground environment that are safe, stable, productive, and sustainable. Everyone entering in the mine must come out safely. This seminar is a step forward towards future. I hope that the discussion today will spark new insight, strengthen professional network, and lead to innovation that will benefit not only individual mines, but the entire mining sector of India. On behalf of Hindustan Copper Limited, Director General of Mine Safety, IIT Kharagpur, I once again welcome you all. आप सभी का बहुत बहुत अभिनंदन और बहुत बहुत स्वागत. Let us work together to ensure that our underground mines are not just places of production, but are places of safety, reliability, and engineering excellence. With time, we will improve further and increase our safety standard. Thank you. Once again, welcome you all. Jai Hind.
Thank you, sir. Your address reminds us of the responsibility we carry towards the safe and sustainable mining practices and need of the hour, that is modernization. Let's now welcome Director DGMS, Shri K. Ravender sir, to address the audience. I now invite Honorable Professor Debashish Dev first from Department of Mining Engineering, IIT Kharagpur, who has authored and co-authored several books, primarily in the field of geomechanics and rock mechanics, and is recipient of prestigious National Geoscience Award, to kindly share his insights with audience. Professor Debashish Dev.
Very good morning, and on behalf of IIT Kharagpur, I welcome you all. The Honorable Sri Ujjalta, the Director General DGMS, Sri Mandekar Saab, Sri Sanjeev Singh Ji, CMD SCL, Dr. I. Satyanarayana, DMS, Ajmer Region, and Dr. Sanjeev Sinha, Director Operation ACL, the dignitaries on the dais, and there are several dignitaries and the delegates in the audience. So I welcome you again. Let me give you a brief background why we are here and how we are here. As you know, a few months back, a MOU was signed between DGMS and IIT Kharagpur to perform several tasks. This one is one of them. In that meeting, when it was being signed at Dhanbad, so I told Mr. Ta that I would like to conduct a workshop like this, where we want to bring the people from industry, from DGMS, from academia. Because my 25 years of experience in India and about 5 years of experience in US, what I realize is that many of the basic things which we are doing in mining, especially in the terms of rock mass classification, just one side, is kind of half done. We are not fully integrated the system, number one. And number two is there are many other new methods has already evolved and is being used all over the world, like GSI, Geological Strength Index. Those who does numerical modeling, and we are now doing it to solve many problems. Their GSI is a now integral part. But if we go to mine and ask that whether you are collecting that data or generating that data, it is absolutely not there. So when we go and do some work, so we do ourselves that one. But if you see the genesis of this kind of classification system, this is made for the practical geologist and the mining engineer or the mine planner who are in the mine. It's for them, it is being developed. So that's why when I told this thing to him, so the positive number one, how we are here, he immediately said that this is a very good idea and where you want to do it. So I am very much involved with Hindustan Copper. So I said maybe in Khetri. Then he said, okay, then I am going to call Mandekar Sahab and you get contact with him. So that's positive number one. Then I immediately call Mr. G.D. Gupta. कि सर ऐसा ऐसा बात हो गया हमारे साथ विद द डीजी साहब का साथ. देन ये बोला सर कितना लोग होंगे. दिस इज फर्स्ट क्वेश्चन, whether he can do it in Khetri. Then when I said it will cross 50, that time I never knew it will be such a big gathering. Then he said, नहीं Khetri में तो नहीं हो पाएगा, but it can be possible in Jaipur. Okay, that's positive number 2. Then I called Mandekar sir कि ऐसा करना है, and he was there also, and he said कि this is we are going to do, and not only for the industry people, even for our own people. They also need to know that there are some new systems are available and how to implement them. And he told me that I'm going to involve Satyanarayana and you get in touch with him. And as you know, Satyanarayana is from IIT Kharagpur, he did MTech and under me only. So it was very much helpful to me. So from Mandekar Sahab, I got positive number 3. And as all of you know, I Satyanarayana, his big smile, I think nobody can miss that. So then we started working on that, and definitely with the blessings of DG, DDG, and then the wholehearted support from Hindustan Copper. So we are here today, and I am very honored to stand before all of you. You are stalwarts in your own field, what you do, and how you are extracting mineral in a very difficult situation also. Speaking to you on these topics will be honor to me. And if at the end of this workshop today, if you feel that, yes, I have learned some new thing, so I would consider my job done. And then we will go ahead and how to further implement that, give more training so that this can be really implemented in the field in the coming near future. So thank you very much. I will come to speak to you on these topics after this inaugural session. Thank you.
Thank you, Professor, for your scholarly perspective and enriching us with your expertise. First of all, I apologize for missing out on our Director, DGMS, Dr. I. Satyanarayana. But sir, you are most welcome to deliver your address to the audience, please. Dr. I. Satyanarayana.
Respected Sri Ujjwal Das Sahab, Director General DGMS, one of the legends of 125-year-old organization serving the nation and as well as protecting miners since 1902. We are proud of him. And under his dynamic leadership, many new initiatives and developments are taking place in DGMS. One of such initiatives is the MOU signed between DGMS and IIT Kharagpur. For what purpose? To provide training, to do safety research, and to disseminate the up-to-date knowledge, like Professor Saab said, to all stakeholders. This is a very good beginning. This is a different dimension of the DGMS. Now, under his leadership, lot of awareness camps and workshops are being conducted to dissipate knowledge to all the stakeholders. Thank you, sir. Next, coming to our Honorable Sri Mandekar Sahab, another legendary personality who always and continuously motivates us, guides us, and mentors us. And this man behind this workshop and implementation of DG Sir's idea was him only. He told us to conduct a workshop in Jaipur, and he directly speak to Sri Sanjeev Kumar Singh sir to organize a workshop, and with his guidance, we are organizing this workshop in Jaipur. Respected Sri Sanjeev Kumar Singh, CMD, Messrs HCL, a truly down-to-earth personality, I will say, because when we approached him with a proposal to provide platform for organization of this workshop, he readily accepted this proposal, and that too in short notice. Thank you, sir. Next, coming to the Professor Deb Saab, he is my guru. Actually, I learnt a lot in rack mechanics under him. And a very simple and directly approachable, what to say, very high thinking, simple living and high thinking. So he is an eminent personality and has vast experience in rack mechanics and geomechanics. You will definitely benefit from him. Thank you, sir. Next, coming to Dr. Sanjeev Kumar Sinha, one of the dynamic directors. Thank you, sir. And all the seniors, colleagues, scientists from NRM, SIMFAR, professors from IITs, NITs, and other educational institutions, all delegates from mines, underground and open cast, press and media, ladies and gentlemen, good morning to one and all, and a warm welcome to this workshop. First of all, why this workshop? Why we are organizing this workshop? Already Dev Sara told, this workshop, you can learn a lot of things, and DGMS as a part of this, providing through seminars and workshop or continued our support for implementing the safety and ensuring the overall stability of the mine workings. If you see, mines are going deeper and deeper day by day. For example, I will tell you in Sukinda belt of Orissa state, all the open cast mine reserves are depleted, and mining companies are now going for deeper, that too through underground. So, this necessitates the importance of this workshop, because determining the rock mass classification and application of the numerical modeling, GSI and Q system is a critical factor in determining the life, safety and productivity of any metal mine. So stability of the mine workings plays a critical role in design of the ground support system, as well as the slope or stope or support design. These are the very important factors, and like Dev said, they are worldwide, they are using it, but coming to our India, the knowledge on this system is very poor. So we thought that this workshop could give you a positive, and you could learn from this workshop. So what is the purpose of this workshop? What we can learn from this workshop? What should be the outcome of this workshop? Basically, all of you aware that most of the mines have the complex geological conditions are going deeper by deeper. So this, there are currently no uniform standards. Even today, there are no generalized guidelines per application in the mines, so that we can generate data and we can do statistical analysis, and from that we can at least develop some guidelines or some criteria for Indian mining sector. So this, I sincerely hope that the deliberations and discussions held in this workshop definitely pave way for the development of the generalized guidelines for applying in metal mining sector, open cast as well as underground across the country. So I sincerely request all the participants to listen very attentively, so that you can, at the end, you can participate in the discussions. So coming to the workshop schedule, this schedule, we have a lot of discussions with Hindustan Zinc and Copper. We invited them our office, and we discussed and continuous discussion with the Professor Dev Sahab. Actually, we got a lot of response, huge response from the mines across the country. But we only shortlisted 11 papers for the souvenir, and out of the 11 papers, due to time constraint, only 8 papers will be presented in this workshop, and others who did not get the opportunity, they can participate and they can give their views during the panel discussions. So I request all of you them, please attentively listen because it is very important. Your participation and your views are very much important, because all of you are belong to different mines and different areas. You come here on different mining perspectives, different geological structures, and mine area is different, and some mines are shallow depth, some mines are deeper depth. So that with your contribution, we can develop a good guidelines, so that we can circulate to you. So thank you, one and all. Jai Hind, Jai Suraksha.
Thank you, Dr. I. Satyanarayana, sir, for your guiding words that set the direction for today's workshop. I now invite Deputy Director General, Northwest Zone DGMS, Shri R.T. Mandekar, sir, to enlighten the audience with his address. Shri R.T. Mandekar, sir.
सबको मेरा नमस्कार। आज के कार्यक्रम के मुख्य अतिथि आदरणीय श्री उज्ज्वलता साहब, डायरेक्टर जनरल माइन सेफ्टी, श्री संजीव सिंह साहब, चेयरमैन कम मैनेजिंग डायरेक्टर हिंदुस्तान कॉपर लिमिटेड, श्री सिन्हा साहब, संजीव सिन्हा साहब, डायरेक्टर ऑपरेशंस हिंदुस्तान कॉपर, प्रोफेसर देव साहब, प्रोफेसर IIT Kharagpur, I. Satyanarayana, our colleague in DGMS, dignitary of the dais, Sri Murari Saab from Hindustan Zinc, Sri Ghanshyam Das Gupta, Executive Director, Hindustan Copper, Sri Ajay Kumar Naithani, HOD, Engineering Geology Department, National Institute of Rock Mechanics, Dr. Manoj Bagade Saab, Chief Scientist, CSRI Simphar, all other speakers, Sri Ayan Giri, Head Technical Services, Hindustan Zinc, Shri Srinivas Rao Sahab, Dr. Shri Srinivas Rao, और अन्य सभी जो मेटलिफेरस माइंस कंपनीज के से यहाँ जो पार्टिसिपेंट उपस्थित है, सबको मेरा एक बार पुनः नमस्कार. Now the contest of this workshop has already set by Professor Dev Sahab and हमारा Satyanarayana Sahab. So the need for organizing this workshop was already explained to you. See, one thing I want to make very clear, and we should understand this also. Slowly what is happening, the mining engineers, although mining is said to be science and art, पुराने किताब में लिखा हुआ है, mining is art and science. So slowly what happened, there is a drift towards art more rather than on science. So we are slightly drifted towards art. So science has taken back step every day. So with the new things happening in the mining industry, mines are going deeper, whether it is a metalliferous underground mines or metalliferous open cast mines. Things further will worsen, further deep we have to go for many minerals, and minerals are required, you know, everybody, for development of the country. So minerals we need to extract and from the deeper depths, high depths. So stress is increasing, rock stability issue will come. And it is already there, it will further increase. पहले का ज़माना गया कि when I joined Coal India and I was posted in a mine where depulering with caving was going on. Depulering with caving, many mining engineers will understand. So उधर क्या होता है caving में कि when you go to the face near go face, cracking sound सुनाई देगा कर 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 कि spalling होगा, इधर से एक गिरेगा, इधर से एक गिरेगा. तो हम नए engineers we used to get frightened कि नहीं वापस निकालो. लोडर का जमाना था उस टाइम, टब लोडिंग करते थे. So many workers at the face, group of 10 people were loading the coal into the basket and then carrying. So we get frightened कि किधर से गिरेगा, कहाँ से आवाज आ रहा है, गोप में आवाज आ रहा है. लेकिन उस टाइम पे के सरदार लोग, माइनिंग सरदार, ओवरमैन, पुराने ओल्ड लोग 50 years, 55 years, वो बोलते साहब आप जाओ यहाँ से, हम लोग देख लेंगे. हम है ना, ये छानी नहीं गिरेगी. छानी मीन्स रूफ, नीचे से रूफ नहीं गिरेगी. तो भगवान कृष्ण जैसा उनका रूप रहता था. तो लेकिन हम लोग ये आर्ट पे बिलीव कर रहे. बेसिकली वी आर बिलीविंग दैट देयर इज अ साइंस बिहाइंड इट. रॉक स्ट्रेंथ जो है, देयर आर मेनी फैक्टर्स. रॉक को समझना है, अंडरस्टैंडिंग द रॉक, एनालाइजिंग इट एंड प्रोवाइडिंग ए साइंटिफिक मेथड टू स्टेबलाइज इट. इतना ही है ना. So there is so many technology methods available. Slowly कि यहाँ पर ये है तो एक खूंटा लगा दो, एक प्रॉप लगा दो. यहाँ थोड़ा बड़ा है तो चौक लगा दो, और ज़्यादा कुछ होगा तो एक गर्डर डाल दो. ये टेक्नोलॉजी पे हमने काम किया बहुत सालों तक. बट थिंग्स चेंज. हम लोग को थोड़ा प्रोफेशनल होना पड़ेगा, प्रोफेशनल अप्रोच चाहिए. माइनिंग इंजीनियर हो, 4 साल की डिग्री किए हो, प्रोफेशनली अप्रोच डील करिए चीज़ों को. ओपन कास्ट के स्लोप्स को भी प्रोफेशनली डील करिए, अंडरग्राउंड को भी प्रोफेशनली डील करिए. थोड़ा साइंस लाइए, थोड़ा सिस्टम लाइए, थोड़ा डिजाइन करिए. देयर आर सो मेनी. दैट्स व्हाट द उद्देश्य. दैट वाज द लॉजिक बिहाइंड ऑर्गेनाइजिंग. सो वी नीड टू increase our awareness, our knowledge, and implement the same in the minds. So need scientific approach. So इसीलिए DGMS में देव साहब इस प्रोग्राम के जनक बोलिए, सूत्रधार बोलिए, जो भी बोलिए, his idea, it's the brainchild of Dr. Professor Dev. और हमारे डीजी साहब का सपोर्ट, और हमारा डीजी साहब ने बोल दिया तो हम लोगों ने इसको संजीव कुमार सिंह साहब के मदद से इसको करने का हम लोग कोशिश कर रहे हैं. हम डीजीएमएस एक इंस्ट्रूमेंट के तौर पर आपके सामने कोशिश कर रहे हैं कि थोड़ा नॉलेज को स्प्रेड किया जाए. दिस इज वन ऑफ द वर्कशॉप इन द सीरीज ऑफ वर्कशॉप दैट इज बीइंग हेल्ड under the aegis of Director General of Mine Safety. Last week there was one workshop on blasting at Ranchi, one more workshop on women employment and empowerment in mining in Ranchi. There before also one workshop we have organized at Udaipur regarding occupational health, and many such workshops we are trying to organize with the help of industry and you all, so that we can disseminate, the knowledge, and we need to become more knowledge oriented, more scientific mining. और ताकि जो हमारे ऊपर माइनिंग के ऊपर जो एक टाइप का धब्बा बोल दीजिए या स्पॉट बोलिए कि many people do not like miners या माइनिंग, इसको डिस्ट्रक्टिव बोलते हैं, कुछ बोलते हैं. ऑलरेडी सारे हमारा डिस्ट्रक्शन से सारा कंस्ट्रक्शन होता है, बट फिर भी एक तो हम लोगों को थोड़ा प्रोफेशनल बनना पड़ेगा. मैंने हर प्रोग्राम में बोला है कि माइनिंग इंजीनियर नीड टू बिकम मोर प्रोफेशनल. थोड़े प्रोफेशनल अप्रोच हमको लाना चाहिए. हमारे इसमें प्रोफेशनली रहेंगे तो हमारे ऊपर का जो स्टिग्मा है, स्पॉट है, वो थोड़ा हम लोग हल्का कर सकते हैं, उसको फेड कर सकते हैं. यही मेरा आपसे आग्रह है. आज थोड़ा जितना भी हम लोग होगा, आप एक्टिवली पार्टिसिपेट करिए चीज़ों में, लर्न करने का कोशिश करेंगे और इसको जाके अपने फील्ड में बाद में इम्प्लीमेंट करेंगे. यही मैं आशा इच्छा रखता हूँ आप सबसे. थैंक यू वेरी मच. धन्यवाद. जय हिंद, जय सुरक्षा.
Thank you, sir. Your enlightening words have added immense value to this gathering. Thank you for sharing your vision. May I now invite Chairman cum Managing Director, Hindustan Copper Limited, Shri Sanjeev Kumar Singh, to grace the stage.
Thank you, ma'am. इस वर्कशॉप के मुख्य अतिथि परम आदरणीय डीजी साहब, स्टेज पे डीडीजी उदयपुर मांडेकर साहब, आदरणीय प्रोफेसर आईटी खड़गपुर प्रोफेसर देव, जो मांडेकर साहब ने अभी कहा जो इसके सूत्रधार हैं, डॉक्टर आई नारायण जो अक्सर हमसे पहले से भी कई चीज़ों पे टेक्निकल बात करते रहते हैं, और हमारे डायरेक्टर ऑपरेशन डॉक्टर सिन्हा, इस हॉल में उपस्थित डीजीएमएस के सभी ऑफिशियल्स, सिम्फर, आईटी खड़गपुर, एनआईआरएम और सभी डेलीगेट्स जो अलग अलग इंडस्ट्री से आए हैं, सभी को मेरा सादर नमन, सादर नमस्कार। जैसा प्रोफेसर देव और डॉक्टर नारायण ने बोला कि मेटल माइंस के लिए, खास करके फेरस माइंस के लिए, कोई ऐसा भी हमारे पास गाइडलाइंस नहीं थी जिससे कि हम जो डेटा जनरेट करें उसको एनालाइज कर सकें। और फील्ड में है, प्रोफेसर देव ने बताया कि और जगहों पे है, बट इसमें नहीं है। तो इसके लिए ये वर्कशॉप, जो इसका जो केंद्र बिंदु हुआ जयपुर, इसी वजह से हुआ। प्रोफेसर देव डीजी साहब से बात कर रहे थे और हमको अच्छी तरह याद है, मैं जस्ट उसमें ऐड कर देता हूँ, सारी बातें प्रोफेसर साहब ने बता दी है। डीजी साहब का तुरंत मेरे को कॉल आया, हमने कहा सर बिल्कुल सर, इससे बड़ी चीज़ और क्या हो सकती है। और इनफैक्ट आई एम थैंकफुल टू डीजीएमएस दैट दे हैव गिवन अस द अपॉर्चुनिटी टू हिंदुस्तान कॉपर टू ऑर्गेनाइज दिस फंक्शन। थैंक यू सर। मैं इस आयोजन को, जो सभी लोगों ने इसको एड्रेस किया है, ये औपचारिक कार्यक्रम नहीं है। यह भारतीय खनन उद्योग में सुरक्षा, स्थिरता और वैज्ञानिक खनन, साइंटिफिक माइनिंग, जो अभी मांडेकर साहब समझा रहे थे, जिससे हम थोड़ा सा भ्रमित हो गए हैं, दिशा भ्रम हो गया, उस दिशा में ये एक ठोस कदम। और ये वर्कशॉप का बेसिक एडवांटेज यही होता है कि इंटरेक्शन होता है। सेमिनार में भी इसको कन्वर्ट कर सकते थे, बट सेमिनार में सर वो इंटरेक्शन नहीं हो पाता, वर्कशॉप में वो इंटरेक्शन हो पाता है। और हमने भी काफ़ी अपना जीवन काल, प्रोफेशनल लाइफ जो है माइनिंग करियर का, मैंने काफ़ी कोयले में और अभी पिछले 4 साल से इधर बिताया है। और जो मेरा अनुभव कहता है, जो मेरी सीख इससे अनुभव से आई है, माइनिंग इज़ नॉट जस्ट एक्सट्रैक्शन ऑफ मिनरल, it is extraction of possibilities and possibilities that shape the nation। आप सभी को पता है कि माइनिंग का क्या परसेंटेज है जीडीपी में, रेयर अर्थ के लिए क्या हाहाकार मचा हुआ है, भारत सरकार की कितनी सारी स्कीम्स आ रही। कल भी मैं एक मीटिंग में सेक्रेटरी माइंस के साथ था, सिर्फ इसी पर विषय पर कि इतना करोड़ दे रहे हैं, इतना करोड़ दे। देखिए साहब, माइनिंग अचानक से कितना एक फ्रंट स्टेज ले लिए। रेयर अर्थ कितने इंपॉर्टेंट हो गए, हो सकता है आपकी बिजली ना चले अगर वो रेयर अर्थ के मैग्नेट्स आपके पास ना हो। तो आप सभी लोग, अब सर वो स्टिग्मा नहीं रह गया माइनिंग पे जो पहले था हमारे साथ, अब प्रोफेशनलिज्म आ गई है। और इस तरह का जो डेटा जनरेशन होगा, जो प्रोफेसर साहब ने अभी एक्सप्लेन किया है, वो प्रोफेशनलिज्म में एक कैटलिस्ट के रूप में काम करेगा। और सिर्फ कैटलिस्ट ही नहीं, क्योंकि जैसा साहब ने बताया, हमारी जियो माइनिंग कंडीशंस बहुत ही डिफिकल्ट है। हमने देखिए चिली की एक बहुत बड़ी कंपनी, चिली क्या पूरे देश की सबसे बड़ी कंपनी, पूरी दुनिया की जो सबसे बड़ी कॉपर कंपनी कोडेल्को, उसके साथ हमने एक एमओयू किया है। और उस एमओयू में हमारी कैपेसिटी, कैपेबिलिटीज़ को भी बिल्ड करने का एक प्रारूप है। वो हमारे यहाँ आए, 3 हफ्ते रहे, हमारी जियोलॉजी को देखा, उन्होंने ये माना इस चीज़ को कि हमारी जो जियो माइनिंग कंडीशंस हैं, दे आर मच टफर देन द जियो माइनिंग कंडीशंस विच आर प्रेजेंट इन द ग्लोब। हम खुद महसूस करते हैं, खेतरी की अलग जियोलॉजी है, हिमालय खंड की अलग है, घाटशिला शियर जोन की अलग है, और सब में चैलेंजेस है। उसका रीजन सिंपल है, हम नीचे जा रहे हैं। 400 मीटर, 600 मीटर, अब तो हम ड्रिलिंग 1 किलोमीटर के नीचे करने जा रहे हैं कोडेल्को की मदद से। और वो जो डेटा हम जनरेट करेंगे, और इनफैक्ट साहब हम ये भी आपको बताना चाहते हैं कि इसी डेटा के बदौलत स्कूल ऑफ माइंस के साथ हम लोग एक एआई और मशीन लैंग्वेज को यूज करके जियो माइनिंग कंडीशंस को कैसे एक्स्ट्रापोलेट कर सकते हैं शिंगभूम शेयर जोन में, वो भी एक काम कर रहे हैं। वो भी काम एक चल रहा है, दिसंबर तक एक ड्राफ्ट हम लोग को मिलेगा। तो और ये सब किस लिए कर रहे हैं? सेफ्टी, सुरक्षा को ही बढ़ाने के लिए कर रहे हैं। अल्टीमेटली जो हमारा ऑब्जेक्टिव है वो यही है जो मांडेकर साहब ने कहा है, प्रोफेशनलिज्म आना चाहिए और सुरक्षा उसके साथ दूने रूप से बढ़ना चाहिए, क्योंकि नीचे जाना इटसेल्फ इज अ चैलेंज। अब वो सब सरफेस के रिजर्व्स खत्म हो गए हैं, सभी डॉक्टर नारायण ने कहा सुकिंदा वैली के बारे में, सो दैट इज ट्रू फॉर ऑल टाइप्स ऑफ डिपॉजिट्स। हम भी नीचे जा रहे हैं। इन मालंजखंड ओपन कास्ट हैज बीन कन्वर्टेड टू अंडरग्राउंड एंड वी आर मूविंग डाउन। इनफैक्ट हिंदुस्तान कॉपर ही नहीं, इसके पहले भी जहां मैं काम करता था, हम लोगों का एक मकसद होता था कि इंडस्ट्री और एकेडमिया का एक कोहेसिवनेस होना चाहिए, दोनों साथ साथ चलें। और इनफैक्ट डीजीएमएस ही एक सबसे बढ़िया प्लेटफॉर्म है जो कि सबको एक जगह ला करके फैसिलिटेट करता है। जितने सीरीज ऑफ वर्कशॉप हुए हैं, हम उससे बहुत ज्ञान अर्जित किया। सीगर साहब बैठे हैं, डॉक्टर नारायण बैठे हैं, इन लोगों ने हमें एक्सप्लोसिव्स के ऊपर में हैंडलिंग पे अच्छा ज्ञान दिया है, खेतरिया करके हमारे माइन साइट्स पे। इसीलिए जीडी गुप्ता वाज मोर इंटरेस्टेड कि सर ये सेमिनार साइट्स पे हो, बिकॉज हमारे लोग इसमें डायरेक्ट इन्वॉल्व रहेंगे, हमारी पूरी टीम रहेगी। जितने हमारे माइनर्स हैं, हमारे जो माइन ऑपरेटर्स हैं, जितने हैं, उनके जो लोग हैं, उनके जो माइनिंग मेट्स तक हम चाहते हैं कि इस तरह की इंफॉर्मेशन नीचे तक जानी चाहिए, क्योंकि सब बराबर के हकदार होते हैं सुरक्षा में। ऐसा नहीं है कि आप किसी किताब या किसी चीज से कर दें और लोग सीख जाएं, नहीं, ऐसा नहीं होता। डॉक्टर नारायण ने जैसा बोला ही कि 125 साल का ऑर्गेनाइजेशन है जो हमारे देश में सुरक्षा को, डीजी साहब इसको लीड कर रहे हैं और अगले साल इस विषय पर एक 125वां साल मनाने जा रहा है। इनफैक्ट जो भारत का जो नेट जीरो का जो 2047 का जो लक्ष्य है, उसको भी प्राप्त करने के लिए सुरक्षा ही एकमात्र ध्येय है। बिना सुरक्षा के वो विकसित भारत नहीं मिल सकता है, जिसकी परिकल्पना हमारे आदरणीय प्रधानमंत्री जी ने की है। और आप देख रहे होंगे पिछले 10 से 15 दिनों पे कितनी सारी मीटिंग्स हो रही हैं खनन के ऊपर। हम लोगों को ऐसे बुलाया जा रहा है जैसे लगता है कि हम लोग कल ये कर दे, परसों ये कर दे, नरसों ये कर दे, लेकिन साहब सेफ्टी के बिना नहीं हो सकता। इसका हमको ध्यान रखना पड़ेगा। इनफैक्ट जस्ट चूंकि एक मौका मिला है, हम आभार प्रकट करना चाहते हैं आईटी खड़गपुर का भी। प्रोफेसर साहब ने हमारे लिए बहुत सारे काम किए। इनफैक्ट आईटी खड़गपुर सिर्फ खेतरी में ही नहीं, मालंजखंड में भी हमारे लिए बहुत सारे काम को, न्यूमेरिकल मॉडलिंग इन्होंने हमारे लिए की है, उसको वर्क भी इन्होंने किया है हमारे लिए। बहुत सारे माइंस, जैसे हमारी केंदाडी माइन है, उसका रूम पिलर के लिए आपने हमारे को बताया है, ज्ञान दिया है। देखिए, एकेडमिक्स और इंडस्ट्री, यहीं पर जो उसका समावेश होता है उसका रिजल्ट निकल के आता है। और ये सब जो एसओपीज बनते हैं बेसिकली, ये सुरक्षा का एक सूत्रधार होते हैं। आप देखिए जो भी आज निकल के आएगा ये एसओपीज के फॉर्म में सभी लोग उनके पास जाएगा, और हर खदान, हर माइंस, हर ऑर्गेनाइजेशन इसको अपने ढंग से उस अपने प्रारूप में इसको ढाल लेगा। और ऐसे भी सब रॉक मास क्लासिफिकेशन के ऊपर मेटल्स में कोई ऐसा गाइडलाइंस अभी तक था नहीं, कोल में तो है। तो ये हमको एक प्लेटफॉर्म, जो डीजीएमएस का आज ये वर्कशॉप हो रहा है, ये पहला ऐसा प्लेटफॉर्म होगा जिसमें कि हम उस क्लासिफिकेशन की तरफ बढ़ेंगे। डॉक्टर नारायण मांडेकर साहब ने बहुत कुछ बता दिया वर्कशॉप कैसा होगा। हम सिर्फ यही कहते हैं कि साहब हम खनन करते हैं सिर्फ धातुओं का नहीं, हम खनन करते हैं सपनों का भी। जो सपने हमारे आदरणीय प्रधानमंत्री जी हम लोगों को जो बोले हैं बनाने के लिए 2047 के पहले जो होगा, और उन सपनों की सुरक्षा हमको स्वयं करना है। अंत में मैं डीजीएमएस और आईआईटी खड़गपुर का फिर से दोबारा मैं धन्यवाद देना चाहता हूँ। इस बहुत ही क्रूशियल वर्कशॉप है ये रॉक मास रेटिंग के ऊपर, चूँकि जियो माइनिंग कंडीशंस हमारे बहुत अच्छे नहीं हैं और माइनिंग की डेप्थ जो आज की तारीख में आने वाले सालों में बढ़ती जा रही है। ये हमारी जो चिली की कंपनी उसने भी हमें सुझाव दिया है कि आपको सुरक्षा का ध्यान रखते हुए ही अपनी माइंस को डीपेंड करना है। और खास करके मेरे जो ऑर्गेनाइजेशन के यहाँ पे प्रतिभागी हैं उनको मैं फिर से दोबारा ये बोलना चाहता हूँ कि इस वर्कशॉप में आप बढ़ चढ़ कर हिस्सा लें और वापस जा कर के और अपने कलीग्स दूसरे माइनिंग साइट्स को भी अपने इस अनुभव से उनको भी ये करें। और हमारे जो माइन ऑपरेटर्स हैं, जैसे मैं देख रहा हूँ एसएमएस से मिस्टर निर्भय जी हैं, डे साहब हैं, आप लोग भी इन सब चीज़ों को ऐसा इसकी मार्ग को ऐसे प्रशस्त करिए कि दिस शुड गो टू द डाउन लेवल। The findings of this particular workshop should go to the lowest level. That is the basic objective of not only Professor Saab, but of the DGMS and all persons present in this particular hall. मैं सभी प्रतिभागी जितने लोग यहाँ पर हैं सबको शुभकामनाएं देता हूँ और यही विश्वास करता हूँ कि हम इस कमरे से जब निकलेंगे तो कुछ ऐसे डेटा और एनालिसिस को लेकर के जाएंगे जो सुरक्षा में हमें मदद करेगा। जय हिंद, जय भारत, जय सुरक्षा।
Thank you, sir. We deeply appreciate your leadership and your words reflect commitment of Hindustan Copper Limited towards innovation and safety. Now I invite Shri Nirbhaya Sancheti, Director Messrs SMS Limited, to kindly address the audience.
Good morning, ladies and gentlemen, distinguished guests on and off the dais. Just due to paucity of time, I'll try to address and complete very quickly. I would like to say that this is an absolute pleasure that this workshop is organized under the MOU of IIT Kharagpur and DGMS. This collaboration reflects shared commitment towards enhancing safety standards in our country. The theme of today's workshop is rock mass classification and support design. Now, this is very central to safe underground mining. Now, I could say that as a non-engineer addressing this gathering, what I understand from is that to understand the ground conditions accurately and apply the right support system so that mining can be carried out efficiently. Such is the system of DGMS. SMSL is operating in MP, Chhattisgarh, Andhra, Telangana, Rajasthan, Maharashtra and Jharkhand. The only common support pillar that we have across these states is the pillar of DGMS. Sir, your guidance and support continuously throughout helps us do mining in safe and sustainable manner. The other thing that we do is we mine coal, copper, uranium, zinc, and we're very proud to produce 73% of Hindustan Copper's total production as of last year. And as Dr. Sinha says, they intend to go to the 12 million ton goal. We intend to retain this pie of our share with you in a safe and sustainable manner. I once again congratulate IIT Kharagpur DGMS for organizing this workshop and bringing a team of such experienced instructors and distinguished guests at one place. I wish the organizers very much success and the participants a very productive and enriching learning experience. Thank you.
Thank you, sir, for keeping your views and reflecting on stability of working and mine safety. Now we are truly honored by the presence of Director General DGMS, Shri Ujjwal Tar sir, and with immense pleasure, I invite him to kindly address the audience. Shri Ujjwal Tar sir.
Good morning, everybody. Respected Sri Sanjeev Singh ji, CMD Hindustan Copper Limited, Professor Dev from IIT Kharagpur, my colleague, friends, Sri Mandekar Sahab, DDG, my colleague directors, deputy directors from DGMS, different directors and other participants from different organizations, including scientific organizations like NIRM, SIMPHAR, and other technical institutions, and operators, MDOs, and senior officers of different organizations across India, particularly from underground mining. And my special senior, Sri P.K. Palit, DX-DDG, Director General of Mine Safety. So this is my immense pleasure to be here with you on discuss about this typical subject, highly technical, and so participation is obviously limited because lowest level participation is not there, but still the technical consultation, technical deliberation of such nature will enhance our confidentiality, also our confidence. It will enhance our confidence for nation building. I see that I have generally very much less occasions to come to this pink city. Jaipur is the pink city of India. So it is a very beautiful place to organize this workshop. And I thank the management of Hindustan Copper Limited for giving, organizing this workshop. I thank Professor Dev, IIT Kharagpur, who has taken leadership for organizing this workshop. And as part of already told that we have entered into MOU with IIT Kharagpur for the first time in DGMS, we have done so. And this is one of the such deliberations, and they are highly cooperating. And we are looking to future MOU also of different good national or international organization. You know, mining, I need to emphasize about the importance of mining because we are all belong to the mining fraternity. Contribution of nation building for mining, it need not to be emphasized much more. You see, we cannot think of development of the society, civilization without minerals, and minerals come through mining. And you see, from that's why our earlier ages are categorized as Stone Age, then Copper Age, Iron Age, Copper Age, then Bronze Age. So ages are also named like this. So importance lies there. Though we are not that much given that much credibility for mining fraternity, but nowadays this scenario is changing. Particularly, you see, even electrical vehicle, even iPhone, even every phone, even semiconductor, whatever say, and other the smart mining we are talking about, we need to have some minerals, sort of minerals. And now this RAS, you see, the capacity building, China is dominating in the world for rare earth minerals for processing and developing. Similarly, we are little bit lagging behind in this, but we think we all are, if we have the determination, we can catch up and we shall cross their estimation also. This GDP, if we think about, this mining contributes about 2.5%, but it should go up for contributing energy security to our development. Everywhere, some sort of minerals are required, so mining is very crucial and important. And similarly, this evolution of mining has also taken place. Many that Mandekar Sahab was telling that when we join in the mining, that mining is not today. It has evolved. Now, at least DGMS also, at least now women also are participating in the underground mining. So we can say that obviously there are changes when we say that we are, generally Indian society is protected about girl, child, and now girls are coming and women are coming to the underground. That itself shows really we are opening up, we are developed. Now recently, few days back, we have conducted one workshop on women in mining and redefining future. So it was such a beautiful that workshop, and their participation, their enthusiasm, it enlightened us. And it is really very appreciating this young generation. They are taking it a challenge, and they are doing very much good to the mining fraternity. And in the years to come, I think their participation will increase and it will give boost, a good name to the mining industry. We are not abuser, we are also doing something good for the country. That has to be spoken outside also. The mining is not only abuser, it contributes for the development of the nation and nation building and society upliftment, we are contributing not only as employer. There are a number of persons are directly employed in the mining, and indirectly so many professions depended on this mining. So emphasis of mining, it is there. And DGMS, this is the first time I'm doing that one pen was there that only DGMS, IIT Kharagpur and HCL. These three people, three organizations are collaborating for such good purpose. It is really very good for us to see. But why with this sort of workshop? If we look back into the history, that RMR classification has changed the paradigm shift of support design and support system in underground, particularly coal mines. In early, late 80s, 1980s and early 90s, that PAL committee was constituted and they came up with a revolutionary change for this classification of rock mass, RMR, and then steel support system introduction, particularly roof bolting. Then earlier in rock mining, it is underground, it is called as rock bolting, but in coal mines we say is roof bolting. Initially there was a very much apprehension how it will support. That is an active support, but we are doing earlier this passive support. From changeover from passive to active support, the changing the mindset, it took a lot of time. But by this time, there is a contribution of underground mining has been less, particularly in coal mines. But metal mines, it is still there, though it has reduced, but particularly I have seen taken in Hindu, I have some good association with HCL. Why? Because during my college days, I took training in Hindustan Copper in Ghatshila area. That was a very beautiful area, glamorous area, but when as an inspector I went there, I found there is a drastical change that this Ghatshila town has turned into a ghost town. So in this regard, it was a very painful for me, but then when in the later on my studies, I made a case study out of this Hindustan Copper Limited, how this mine has been closed, what should be done. There is obviously some policy makers who might be doing some mistake, misunderstand the concept of economics and mining. To develop an underground mine, it takes a lot of times, and suddenly closing this mines, it is painful. Today, what grade we are mining, you may say it is not suiting our economics, but this you see particularly metal prices, this depends on LME prices, metal price. So this is a dynamic nature, but mining has to stay. That only because today we are not able to mine the grade, we shall waste that because you cannot regenerate it. What has been given by the mother, nature's mother earth, that we have to take. Now how you will take, how you will purchase it depends on your technology. But economics is a part, but for the development, you see, when we don't have, there is one story, if a person, because this is the place of desert also, in management, first line is taken that in the desert, there are two people. One is very rich, and one is not rich, but he is having with this one bottle of water, but that this man is not having. He is feeling very thirsty, how to live. Now the bargaining takes place, that you give me that water, I shall pay this much, that much. Then the bargaining capacity went on increasing. Money does not matter at that time, that life matters. So between the business and the ethics, there is always play with each other. So we have to take into this fact that mining has to sustain. To make it sustain, we have to some mechanism that when it is grade is less, we discard it. It is not the way to do it, because the experience they have involved, this Hindustan Copper, they have experience for reopening, how many struggles they are making still now. More than 25 years past, but still though many new old mines which had been closed earlier are not being able to reopen, because it takes gestation period is quite high. So we should have a policy decision. Mining fraternity should have a stake in the government policy making, that mining is a special type of industry. You cannot compare it with other industry. You cannot increase its grade. It is not in your hand. What is available, you have to do with that. Now, you see, for this RMR I was talking about, when my college days, when I was doing some master degree, I had a very much fascination for accident reduction. So I wanted to develop one predictive model. Then I collected 10 years accident data and then did regression, regression analysis. That is only basis of historical data and future prediction model. But I stopped in between because it was not that time was, and this scope of the study was very high. But during the studies, what I found that if the width is a very crucial factor in accidents, where junctions more prone to accident, and when gallery width is much more, instead of height, width is much more important for controlling accident, for control of groups data. So this seminar, I think, is going contact. It should be a workshop that most interactive session you will take. How can I take that? It has been since long back when RMR was classified, more than 30 years, 35 years, 40 years, obviously, 35 years gone. So metal mines have no such classification method, crucial. When Professor Dev came to me and we are discussing, it was really interesting to see that we should do on our own, that something concrete should be done. And with this seminar workshop, I think we will deliberate, because all the academicians, research personnel and mine operators are here, experienced mining engineer. So at the end, we will come with some concrete conclusion, suggestion, so that it can frame a nationwide guidelines to follow for the future. And this, this is a good thing, I say. Another thing, this side, another concern is side slope rating. Not only this rock mass rating, side slope, because nowadays our production mostly comes from open cast. Number of accidents, it had increased due to slope failure. So how to stabilize this slope, both coal and metal, we have to think about it. We have to come up with some idea like rock mass rating or GSI rating. We should have some slope, side slope rating for its stability. But one thing, safety, which it is separate, I never think it is a separate subject. Safety is integrated in the system. What do we mean safety? If you are driving a tunnel, we cannot go, we cannot make our roof stable. We cannot, if we cannot support that gallery, we cannot go ahead. Our system fails. So it is not any particular different things from operation. It is integrated in the operation itself. It is integrated and it should be treated like this, that it is not another subject. It is integrated into the system for our production system or our operation system. So we should act accordingly and change our mindset. You see, the mining technology has changed so much changes now. Coal mines also, you see, though RMR is flowing, we are following. Recently, few coal mine accidents also have taken place due to roof fall. And in one incident, 3 people died, and all are mining sardar, overman, and assistant manager. Who have the responsibility to look after? They became the victim of this situation. So we have to think itself that how painful it is young persons are dying due to this sort of accidents. Now, roof fall accidents, though reduced because there is a less number of underground mines at present. But if we take this weighted average, still it is the contributory cause for roof and side falls, contributing loss, many lives, valuable lives are being lost. Every year, we are losing at least 30 to 40% for coal mines, and similarly for metal mines also. These people are killed. So, though accident rate has reduced considerably, since we record our sales, that accident rate per 1,000 persons employed has reduced from 0.94 to 0.19 in coal and 0.93 to 0.24 in metal. It is a great efforts because all you have contributed. It is not the DGMS effort. The union workers representatives, these technicians, these our researcher, our scientists, our operators, all have come together and taken a good step that though in production productivity has increased manifold, but accident rates and accident numbers are reduced. But we should not be complacent for this. We have to see that our aim is vision zero vision. So by 2047, as our government of India and our Honorable Prime Minister aim is to Viksit Bharat by 2047. We have done many since independence. We are progressed a lot. Earlier we are a poor nation, underdeveloped nation. Now, with these 75 years, we have cut that stigma. We are not at present, we are not underdeveloped nation, we are not poor nation. We have come forward from step from poor nation to developing nation. The one step had already we have crossed. Now next step, next vision is to be developed nation, that Viksit Bharat. But if we do not contribute, our mining, that's why mining community, mining fraternity in a whole has a very much important role to play for the making our nation developed by contributing from all the spheres. Production, productivity and safety. Zero vision we should have. And now one more thing I would like to share with you, that code, Occupational Safety Health Code, Working Condition Code 2020 has been implemented from 21st November, and rules will come up, regulation will change. So we mining engineers, practicing mining engineers, and our academicians and research bodies, I request you to go through the provisions and make update our knowledge for the because it is the application engineering, safety engineering. So we have to know, what the impact it has made in this mining community. So accordingly, we should percolate it down to the downstream, to our up to supervisor level, worker level, and mid-level supervisor, assistant manager. Already 4 codes: codes on wages, codes on social security, codes on working condition and occupational health. And these 4 codes have come into effectively from 21st. We are doing many such programs, and I think with this, I thank you for all for giving me the opportunity to stand and speak before you and sharing my little knowledge, though I am not much competent about this very new technology, which professor will deliver it. From this we shall learn a lot and come with some concrete suggestion. And I thank you again for giving organizing such workshop and attending my Udaipur team of DGMS and Hindustan Copper Limited and cooperation from IIT Kharagpur. We together, we shall be there, and obviously we shall cross all the hurdles in the path of our development. With this, I thank you all again. Jai Hind.
Thank you, sir, for your guidance and for reinforcing the importance of safety in mining practices by engaging emerging technology. Now it is my proud privilege to invite our chief guest, esteemed Director General DGMS, Shri Ujjwal Tar sir, to digitally inaugurate the souvenir of this national workshop. This souvenir is a reflection of collective knowledge, experiences, and commitment to safe and sustainable mining practices from learned mining fraternity. Thank you, sir. Please keep the slideshow on. Now I request all dignitaries on the stage to kindly open the book, which is authored and presented by Professor Debashish Deb on fundamentals and applications of rock mechanics. Let us all have the glimpse of this book, sir. As a token of appreciation and gratefulness for the dignitaries, we would like to present them mementos. For this, I first request Chairman and Managing Director, Hindustan Copper Limited, Shri Sanjeev Kumar Singh Sir, to kindly present memento to Director General, DGMS, Shri Ujjwal Ta Sir. Thank you, sir. Next, I invite Director Operations and Additional Charge Director Mining, Dr. Sanjeev Kumar Sinha, sir, to kindly honor Deputy Director General, Shri R.T. Mandekar, sir, with a memento. Thank you, sir. May I now request Director Mining DGMS, Ajmer Region 2, Shri K. Ravinder, sir, to kindly present a memento to Chairman cum Managing Director, Hindustan Copper Limited, Shri Sanjeev Kumar Singh. Thank you, sir. I now request Director Ajmer Region 1, Dr. I. Satyanarayana, sir, to kindly honor Professor Debasish Dev, IIT Kharagpur, by presenting a memento. Thank you, sir. I request Executive Director and Unit Head Khetri Copper Complex, Messrs Hindustan Copper Limited, Shri G.D. Gupta, sir, to kindly present a memento to Director Operations and Mining, Hindustan Copper Limited, Dr. Sanjeev Kumar Sinha, sir. Thank you, sir. Now I request Shri Umesh Singh, Executive Director Mining, Hindustan Copper Limited, Corporate Office, to kindly present memento to Dr. I. Satyanarayana, Director Ajmer Region 1. Thank you, sir. With this, ladies and gentlemen, we now break for high tea. Kindly join us in the hospitality area and return refreshed for the technical sessions. I would request everyone to please return within 10 minutes so that our technical sessions are started on time. I know you all appreciate the value of time, so please be back in 10 minutes. That would be highly appreciable. Technical sessions are on the way. First call for everyone. Our guests outside the hall, I request you all to please be quick with your tea and snacks so that we can start technical session well in time. The purpose we all are here today Second call, all the guests outside the room, please take your seats in the hall. Technical session 1 will soon be started. All guests and dignitaries outside the hall, I request you all to kindly come and take your seats. Technical session 1 will soon be started. I request speakers, chairperson and co-chairperson for technical session 1 to kindly come inside hall. It's about the 4 modified Indian labor laws effective from November 21st, 2025 are the Code on Wages 2019, the Industrial Relations Code 2020, the Code on Social Security 2020, and Occupational Safety, Health and Working Conditions Code 2020. I request all dignitaries to kindly take your seats. All the guests, please take your seats so that we can commence upon the technical session 1. The technical session 1 will be chaired by Director Ajmer Region 2, Shri K. Ravinder, and co-chaired by Shri Ram Murari, IBU CEO, Rampura Gucha Mines, Messrs. Hindustan Zinc Limited. May I request the session chairman and co-chairman to kindly take their seats on the stage. First technical paper is on rock mass classifications and support design for improving stability of workings in metal mines by Professor Debashish Dev, Department of Mining Engineering, IIT Kharagpur. I request Dr. Debashish Dev to kindly take over the dais.
Thank you, Mr. Chairman. The morning session, we have discussed the purpose of this workshop, and so let me begin with the concept that the main idea of rock mass classification is ultimately to design the support for underground mine, or for surface mine, it designs the safe slope. That is the ultimate goal, why we do rock mass classification. So let me first start with what is the philosophy of support design. First, if I have to do the support design, first a site investigation need to be done. This is the must. And then once we have done the site investigation, and over the course of this lecture I am going to tell you what data need to be collected from the site investigation. And then we go back to the laboratory and we do the necessary test to understand the intact side of the rock. And I will tell you a lot about this. In the morning session, Mr. Mandekar said, understand your rock. This is so important that we must understand the rock mass. And for that, the beginning is here and also here. This is where we understand the rock and the rock mass. Then there are various classification systems, starting with RQD, then RMR, then MRMR, mining RMR. This I am going to tell you later.
That's one. Another version is called MBR, the modified basic RMR. These are all made for mining purpose. Then Q, GSI, Q slope, slope mass rating. So there are many, at least 15 or 16 different rock mass classification systems. Now out of which one is important for mining purpose, that also need to be decided. So after getting these two, we go back here and we classify, we give a number between 0 to 100, 100 being close to intact and 0 being like completely powder. So in that category, we are giving a number between 0 and 100. And in some cases for Q, it's 0.001 to 1000. So, but we give a number. And then we should not stop here. Then we should know that we have to now apply this knowledge ultimately to design the support. And in the support design, we have to know the width and height or the geometry of that excavation, what we want to support. So then the geometry will come, also the stress will come. Now, very interestingly, some rock mass classification already handles the stress. They are already incorporated there. Now, when we make excavation, we have to know what is the method. Are we doing drilling blasting or it is only an excavator? So that will change the rock mass. So some criteria has already incorporated that also, that what method you are applying. So based on that, this number will change. So whether those are better for us, especially if we are doing for mining, so that need to be decided. But nonetheless, we have to know the stresses and the geometry. And then we have charts and tables already laid. Based on this, all this information, we can go back here and find out what is the required support. We parallelly do numerical analysis, and using all this information, it will go to numerical analysis, and we find out what will be the required support. And then we may verify and validate with this chart that whether the numerical analysis given the correct one, or then we together we take a judgment, okay, this is the best support for this rock mass, this stress condition, and this geometry. We are going to take this recommendation given by either charts and tables or from numerical modeling or combining both. So this is the philosophy by which we should go. So now, what is a rock mass? I think most of us know because we work with this. Even our rock are, although we call it containing no discontinuities, but even if you take a small piece of rock, that also contains some micro defects. So in other words, either you call rock mass which is full of discontinuities, they are what we call a dian type of material, which is discontinuous, inhomogeneous, anisotropic, non-elastic. Means in the mechanics field, whatever you do not want your material to be, our rock is that. You see, you compare with that with a steel rod. You know, it will be continuous, homogeneous, isotropic, elastic material. But ours is none of it. All are negative in our case. So that's why things get complex. On top of that, if you have a fault, then things get much complex to understand how that will behave when I create an excavation near it. So that's why we have to understand our rock and our rock mass where we are working because of this dian nature. So what does it serve? The purpose of rock mass classification. What is the purpose of it mainly? Because the laboratory values, whatever we are testing, this is for this intact rock. In the field, this is not the rock. In the field, something like this is our rock. So whatever value we are testing in the laboratory cannot be used in numerical analysis. We cannot use that. Then everything will be safe. You do not need support at all. Because we are using more or less elastic material, more or less homogeneous material. So we got to know how to adjust that value based on that rock mass, that either RMR value or Q value or whatever. So we need to find out a number which will tell me this is intact and this is not intact. What is the severity of that? It is not intact. So that's why this is the main objective of rock mass classification. See, in our mechanical friends, they do not do any classification of metal. They know the property. It's an engineering material. Ours is not an engineering material. If they do not like a strength of a metal, they will ask the vendor to change the metal. We cannot change it. Ours is only there and our minerals is there. So we need to find a way how to quantify these defects or the discontinuities. That is what is required for rock mass classification. So for numerical model, we need this to adjust the laboratory tested data or the properties. We need to adjust. And then there are various, there is one important thing, this classify groups of similar behavior. Let me give you an example. Let's say we found an area, the RMR value is 48. Let's assume. Now this 48 comes in many different ways because there are 5 parameters by which RMR is calculated. So you can get the combination of parameters such that 48 comes. Let's say it's a very competent rock, but heavily jointed. Strength is very good, but it's jointed and watery. So it gives 48. Again, one rock is not so competent, but not less jointed. That also can give 48. Now what RMR is saying, basically they are same rock. Their behavior will be same. This is what we are assuming. So this is what the rock mass classification is trying to tell us. We have many different combinations. We are trying to group it. So competent, more joints, same. Not so competent, weak rock, less joint are also same. Behavior will be same. This is what is the underlying assumption of rock mass classification. So that's why we need to classify them in certain group. Now this slide, I want to spend little time, because this is where those who do numerical analysis or give the result based on numerical analysis, they must be aware of what we are talking about. First, it's a very busy slide. See, there are many things. There are heavily jointed rock mass showing, and there is a tunnel or a drive for our case. Similar case here, there is a slope. This is a very famous drawing given by Hook and Brown to famous rock mechanics person. Now, what it's saying is, I come from bottom. See, they put 5 different classes. So this they are saying, it is coming from an area of this big circle. So we call it ROI, region of interest. So my tunnel is here. So what is my region of interest? I was saying if I do a tunnel here, this much area will be affected. Okay? So if this much area is affected, then what is the rock mass? It looks like there. So it looks like very fractured or the jointed area, at least 3 sets of joints are there. We call it, we are calling it that pseudo-isotropy or very fractured rock. So here, if this is the rock type, we have to do classification. We have to classify that rock or rock mass. Then we come little less area. We are assuming no, itna to effect nahi karega, or thoda sa kam. Okay. Then we are seeing 2 sets of joints. Now 2 sets of joints, it's still, we call it pseudo-isotropy. Again, the same as this. This is also classification required. We cannot do any kind of analysis if we do not do classification. Now I come little up. Only this much area we are assuming will be affected because of this, or in a slope only this much, this area. So then we are seeing the joints are widely spaced and there are very infrequent joints. Now this is where we call it pseudo-anisotropy. People say, some people, this is some controversy, some people say classification not required, but I feel this is also classification required. We can still do rock mass classification and do the analysis. Now if I go over this small area here and we find only one joint. So my interest area has only one single joint. Then the behavior of the rock mass here will be controlled by that particular joint, mostly. So rock mass classification will not result anything there. We have to know what is the property of this joint, because it is a what we call structure controlled behavior. Like if there is a fault, we do not do classification, we don't need to. We have to know how that fault will behave when we make an excavation. So it's a structurally controlled rock mass behavior. So I have to do this. A rock mass classification, either RMR or GSI or this thing, that thing, will not result a good analysis. And if you go little above, there is no joint. So you are thinking it will just affect the boundary. Then it's just like intact rock. So there is no classification required. That means rock mass classification are required from 2 or more joint sets are present. If it is less joint sets, then basically we have to know the behavior of that particular joint, not the overall mass, because that is going to control the behavior. So first we have to identify the area, that what we are talking about, that how much area we think it is going to affect. Now let's assume there is a drive and there is another drive here. Then definitely both the drive is going to control this entire area. Then we will go for rock mass classification. Okay? So this is what is the paradigm where we are going to operate our rock mass classification. Now, the classification system started mostly in 1963. Before that, there was soil classification system, because rock mechanics is younger brother than soil mechanics. Some group of people came out of soil because soil formulas and soil concepts, mechanics concepts were not working for rock. So they say, no, rock need to be tested differently. It need to be thought of completely differently. Because how it has started, everything started with metro. And that was in a either very weak the soil or very weak or weathered rock. The metro was hardly less than 100-meter depth when they started. So that time soil mechanics works fine. But as the depth goes down and they encountered harder rock, they realized, no, these are not soil. So this is different.
So the soil classification we started in 1950s did not work for rock. So then it came out, and the first classification was done by Deary for defining RQD, which you know all, rock quality designation. This is published in 1963. Since then it started, but first as a rock mass classification was this one, RSR, rock structure rating. It probably came in 68, 69. The Professor Bienaski, who did RMR, was heavily influenced by rock structure rating. It was basically for tunneling in hard rock, they did. So there are two parameters were there. One is geological parameter, one is construction parameter. So those geological parameter he tried to take for rock mass classification. So then he came up with rock mass rating. He called it geomechanics classification. At the similar time, when Professor Bienaski was doing that, at the similar time, the Q system was also going on. So RMR was going on in South Africa. Later on, it came to US. And Q system was totally in Europe. It's a European thing, mostly Norwegian. But they are more or less contemporary, 1 year here and there. And then after these two both were initially done for tunnels. RMR is for tunnel initially, not for mines. Then when this system came, even Bienaski was also involved. They modified it for mines. They call it MRMR, then call it MBR. So for tunnels is RMR, for mining basically MRMR. Mining RMR or call MBR, modified basic RMR. These two are for hard rock mining. And then very later on, this is in 1997, GSI came, and I will talk about this later. So this is pretty much the history, how it has come. So let me start with RQD, which most of you know how to calculate. So RQD is calculated from original version given by Deary in 1963, is from a borehole log. A piece which is more than 10 centimeter by the total run, the total length should be considered, and total length also he said at least should be 2 meter. You cannot do 0.25 meter and calculate RQD. Okay, then it will not make any sense. You will get almost 100. So that will not be right also. So he said at least 2 meter. Now we accept 1 meter also, because sometime in a coal mine getting 2 meter is also difficult. So 1 meter is also fine, the total length. But more than 10 centimeters should be in one piece when you are coring it. So does anybody know why 10 centimeter? Why he said 10 centimeter that time? Because this is the most, everywhere it is written, more than 10 centimeter. One piece, that will be counted. If it is less than 10 centimeter, we will not count it. Yes, absolutely. He takes twice the diameter. That time mostly diameter was 54 mm, which come around 50. So it took twice that diameter. He said if we get a piece. And one more important thing here, if we are following this, then it should be naturally occurring joint. If due to vibration or anything a crack happened, we will not consider that. We will consider that it was one piece. But many times, especially in the slope or everywhere, we do not have the core. Even it's a, if immediately they are, basically the moment they do the core, they should find RQD. Right there. It cannot be later on we will calculate. Core has come, you put in the box, and RQD must be calculated right there. So whoever the geologist present there, he will calculate it and document the whether there is any infilling or anything, everything will need to be documented. Now if this is not there, core is not available, then how do we calculate? Okay, so this is where now as you can see that developed in 63, but in 73 a formula was given that you do not need to know the core, even we can do by a scan line. So we go, let's say in a slope, so we put a rope there and we count the number of joints encountered. So this is your slope face, we draw a line or we put a rope and we count how many joints is encountered. So that is basically the, what we call lambda, the number of discontinuities per meter. So you then put it there, you will get the RQD. And it comes more or less same with that also. So this formula will be if you do not have any core. We can still find out RQD. We can find RQD also by what we call joint per unit volume, JV. These are well established because core is not available everywhere. So we have to get by this process. And the formula is 115 minus 3.3 JV. Now here I have given an example. Let's say we have 4 joints and let's assume this is 0.75 meter and we have 4 joints, so the lambda value will be this. You plug in that value here and you will get RQD as 90%. Okay, and if you do a core, you will get more or less same value. For JV, what we are going to do, let's say we have a block, this is very helpful in the slopes, where at least we know at least 2 face we can find out. At least this and this we definitely know, and if there is a slope like 2 free edge, then we can also know this side. So this says what we are going to do, the sum of number of joints per unit length. So I have given the example, let's assume this is 0.5, this is 0.5 and this is 0.5. So the JV calculation will be here number 3 joints cut by 0.5. This area has cut 1, so 1 by 0.5, and this area nothing has cut, so 0 by 0.5. So our total is 8. You plug it in there, so this RQD of that area will be 88.6%. So if you do not have core, no problem. We can still calculate RQD. We need not have to be with the core. RQD has, but only RQD cannot be used for classification. Even the dairy who has developed, he has never said that you use it for that purpose. Because it just quantifies the number of joints per core length. So what happened is, because the RQD is direction dependent, which direction hole is there, so if you are not careful, one area it may become 0 also. And in another direction it may become 100. Same area. We can have 100, we can have 0. Depending on the direction, if you are not careful which direction we have drilled it. So this is a problematic with, that's why we call RQD is direction dependent. Another is if joints are filled with calcites or some other strong material. Then in the core, we may miss that there was a joint. Okay, so, but there was a joint, it has infill, so that area unnecessarily will not be counted as a natural fracture or joint. So there are some challenges, but I think now we pretty much know how to calculate RQD. So RQD is, if you see the chronology,
So first soil mechanics classification, then came RQD, then at the same time Professor Bienenski was working on RMR. And he called it geomechanics classification. Later on he termed as RMR, and that became popular basically, rock mass rating. Mostly when he was developing this, I'm emphasizing that he did most of his data from shallow depth sedimentary tunnels. That is where his data came from. Later on came from some mines and some slopes. This comes later on. In 1989, when last he has revised this one, that time there was total 351 case studies has been studied with this RMR system, including tunnels, mines, slopes, caverns, everything. So RMR is not only for mining purpose. In fact, I will show you, he said it is not for mining purpose. You need to modify it to use it for mining. But it has good application, I think, in coal mine, because originally it was done in sedimentary rock. So it will be very good for coal mines. And the caution he has given in 1989, because he has given a very comprehensive report, what he has done in 73, and then in 89, after 16 years, he gave a very comprehensive report that what has happened with RMR. And then he says, these many people were arbitrarily using this. My purpose was not, so he said, RMR system is used for the purpose it was developed, not as the answer to all design problems. Because I was seeing everybody started using it, whether it is applied or not applied. So he gave a caution there that do not apply it arbitrarily, because my case study doesn't have this type of situation. So he also not sure whether it will work there. Okay. So now, but it is by far the most popular system, rock mass classification system as of today. And Q system and this one, these two are the most popular. So it has 5 parameters, as we know. Uniaxial compressive strength, so he is taking the intact rock. Rock quality designation, RQD will be there, joint spacing, joint condition. I will go one by one. Groundwater condition, these are 5 called RMR basic. This is called RMR basic. RMRB, where you will see RMRB. And you see they are additive. So you add those values. And all these are positive numbers. So as you are adding, RMR will increase. Okay, so RMR is additive in nature. So he is saying you can add the contribution of these 5. And the last parameter is negative. Last parameter is negative. That is the, based on joint orientation, we have to adjust these values. So that is negative. So basic minus basically this joint orientation is my actual RMR. So this is a table is given. I think this is amply known. So we have to do the test to find out. So you have to send the sample to the lab, or if you already have the lab, you can test there. But I prefer to use this continuous function, not this discrete function. See, the discrete function is, discrete values you see. Here you can see 100 to 250, 12. So that's a wide range. So do not use that table. You use the, later on Bienenski is given. So you see he has given the strength, and then you can find out what is the corresponding that rating for strength, corresponding for RQD, similarly for joint set, the spacing, we can use this spacing. Now normally if you have more than 2 joint sets, we are going to take the smaller one.
whichever is the smaller spacing, we are going to take that. Because you see, here it is big, joint spacing is this, and that is there is small. So we are going to take that if you have a more than 2. And there is that rating, in that side is the rating. So you know this spacing in millimeter and you can find out what is the rating. Joint condition is where we have to go close to the joint. Basically a geologist or a mining engineer with a geology eye must go to very close to the joint. ये दूर से नहीं होगा. And you actually observe or take a picture and then analyze. Because we have to see what is the aperture, that is open or closed. Whether it is filled with some material like clay material, sand material, or calcite or other material. And its roughness, you see this is very exaggerated. I am showing you the roughness of the joint. If you take it to very close, it shows like this. And this has, he has given 30 point. You can see out of 100, 30 is given in this category. So we just cannot ignore this joint condition. Okay, so it's a very important parameter in RMR, and we should not neglect this. And this 30 points he again breaks up into 5 parameter of each 6, and then you can see they have discontinuity length, the separation, that means that aperture, then roughness, infilling, any weathering. So each of them he has given maximum of 6 points, and accordingly we have to get this number. This is a very important 30% given into this. So we have to go close to the joint and see and observe. And the last one is the water condition. This is very important. This is, he has given 15 marks for that, and he has given whether damp, wet. There is some linguistic also, and linguistic term. We can understand which one is damp and which one is dripping. So based on that, we can give these points. So these 5 will add and give you the RMR basic. Then comes your joint orientation, which is negative. Okay? And negative in the sense you can see here, it is with respect to the axis, in the direction we are driving the tunnel. And like these joint sets, if a joint sets is like this, that means its strike is parallel to the joint axis, perpendicular to the joint axis, because the strike is out of plane. You can see that this is out of plane. So then he has given here, if the strike perpendicular to tunnel axis or strike parallel to tunnel axis, and then what is the angle. Based on that, whether it is a favorable, unfavorable, very unfavorable, and here the negative marks are given. As you can see, the unfavorable for slope, it may go up to -50. So if your RMR basic is 70, if it is very unfavorable for slope, your RMR is 20, 70 minus 50. So minus 50 point, taking it out because of the orientation. So it's so important, you see. So this, later on, I will talk about slope mass rating, and there they have considered this heavily. Okay, this, they went until -60, I think, in slope mass rating. So this is very important, but this is the negative side of RMR, so you have to subtract. So whoever is calculating the RMR value, you can see that RMR basic is not the last step. The last step is here. And so we have to know what is the tunnel axis with respect to the slope axis or the slope strike and its dip direction. So this is very important. I am emphasizing that.
whoever calculates this. Now, based on that, he has given the classification which we normally refer to, that we normally say good rock, fair rock, poor rock, very poor rock. And why I highlighted is here is this: RMR is best for this one, the standard time. This is what I can see the best use of RMR, and he has also given those for numerical modeling people. These two are very important parameters, goes into numerical model directly, and he has given some tentative values. You can see these are very arbitrary. When somebody gives 200 to 300, that means he is just guessing a number. It's not, actual number. He just say ballpark area, you use this value. Okay. And these are all in kilopascal. You can see. So we normally do not use that. Our strength is in megapascal, 1,000 times more than this. So if we use these values, the thing will collapse. So that's why, because he developed this for shallow depth tunnel, there kilopascal is fine. Now if you are 500 meter below and if you are talking in kilo, it will not work. It's in mega. It's in 1,000 times higher. So we hardly use this. Okay? But this one is fine. So I'm going to tell you later on. So what are the points to be considered in RMR system as far as mining is concerned? Now I come to mining side. This one previous to that. Strike parallel to tunnel. Huh? Yeah. This will be better. Okay, so the point to be considered is, what good part of RMR I see is it's very simple to calculate, but as I'm telling you, there are some point to be taken meticulously as far as joint condition is concerned, that 30 points. And it can be used for selecting permanent support system, but I will tell you how to do it. But concern is this RMR developed for shallow depth tunnel, and for coal mines it is very much applicable. For excavation in deep rocks, we have to modify it, and that is also given. RMR system mainly which it doesn't consider is this active in situ stress. The stress part is just completely not there in RMR. And also pore water pressure. If there is water, how does it affect my condition? It doesn't consider. It doesn't consider fault, shear zone, squeezing ground explicitly in that system. It is not there. He has not given any points for that. If there is a fault, should I reduce? How much to reduce? It's not there. Okay, so this particular structural discontinuities, big structural discontinuity, fault, fold, shear zone, not explicitly there in RMR. So that's why in mining, we have to be very cautiously use this. And blasting damage is not there. It is so far not there in any of the classification system. Blasting effect is not there. But due to blasting, we break the rock. Even the rock we are going to excavate next is also affected. But that is not considered in this classification system. In fact, no one. So these are the conditions in RMR. Now that doesn't mean that we are not going to use RMR. Yes, we are going to. Okay. So now we come to the application part. I actually searched what Bieniawski has told, that where to use it. Okay, he has developed it, so you tell us where to use it. So in 1989, he told that geomechanics classification, see, as I told you, he always like to tell it geomechanics classification. He said it's widely being used, mostly tunnel, slopes, foundation, and also in mines. But most of the applications are in tunnel. This is what he said in 1984. And he mentioned it in 89 paper. But in mining, what he says, the people have modified it. And this is one done in Australia, sorry, in Africa, in asbestos mine. This is the first modification in hard rock underground mine. First modification was done. And the second one was done in US. That time, Professor Bieniewski came from South Africa to US. And he developed a system called MBR for mining application. Now, this is what is MBR. So, you can see this is given by him only, okay? He and these people, this is easily downloadable, okay? You can just type that, this title, and you can get this report. It is freely available. Okay, very extensive report, I think 142-page report, okay? Now, what he says is, I am giving you the gist of this report, that you calculate RMR, see, strength of intact rock, discontinuity, discontinued condition, groundwater. This is RMR basic. You calculate that basic RMR and then you adjust the discontinuity also. So he said this part is RMR. Then there should be a adjustment due to blasting damage. So he said it may go to 0.8 to 1. So whatever either mila hai, you may have to multiply with 0.8. And he has given a table that kaun sa blasting ka liye kaisa karna hai, how to adjust. Okay? So, and these are all for hard rocks they have done, hard rock mine. So there is a blasting damage and this is where it is coming from, same blasting damage. Then there is a, because this stress was not there in RMR, so they are saying you have to adjust for the in situ stress condition. There also it can go up to 0.6. You have to multiply this RMR. And there is some structural discontinuities, you see, major faults or fractures. That can go up to 0.7, means you have to multiply. So your RMR multiply by these three factors will give. Then he said if it comes below 0.5, you consider it to be 0.5. Okay, so what we are trying to say then, if your this RMR comes 70, it may go to 35 also because of these three factors. Because these are directly related to mining. Blasting, stress, because we are at heavy depth, and as well as major structural discontinuities. So this adjustment need to be done if we have to use RMR for mining condition. In the morning I told that in my experience I have not seen people are using it. This part of they are calculating up to RMR and that's end of it. But for mining that is not the end of it. Mining ends there. And in this report they have given very externally excellent work, I would say. Itna saal pehle, itna good work. See, this is in 1982. That means they have started work in sometime late 70s. So what they have said, even they considered development ka time mein ek RMR or MBR, production ka time mein aur ek MBR. आप जो stop blasting कर रहा है, बोले then एक stop आप blast कर लिया, then next stop कर रहा है, then उसका change हो जाएगा. अब पहले जो calculate किया वो नहीं रहेगा. So production का time में different होगा. And what they have considered here, see, production again, major structure hai, see, distance to cave line, that means your stop line, वो कितना दूर में है, next blasting. Okay, and another is your panel size or the block size. So उसका लिए भी adjustment है. So finally, this is for production, this is for development. So इतना detail में भी study हुआ है for mining purpose. Okay? So we should not stop here. This is my point. Because itna study ho chuka hai. Okay, and there is some reports already available. Yeah. Oh, पूरा टेबल है उस रिपोर्ट में everything is there. नहीं, how much quantity of explosive, आप कितना दूर में है, सब कैलकुलेट करके वो दिया है. Everything is there. Yes, yes. That report has a very detailed, everything is there. Yeah. I have not shown all those, but it is available. Now, what is the use of this RMR, especially where we will use? As I told you, see, rock mass classification is ultimate goal is to design the support. That is our ultimate goal. So what we can find out? We can find out something called modulus, which we, for intact rock, we call it Young modulus, which we calculate in the lab. But here it is called the deformation modulus, which is for the rock mass. So that we can calculate.
Excuse me, sir.
Yeah.
Sir, why was there 1.2, sir? How can it increase, sir?
The stress condition.
Yes, sir.
Yeah,
Previous slide.
See, for a rock, if there is a horizontal stress, compressing it, it will be very difficult to break it. Rather, if you are not having that stress, you need low stress to break a rock. But if you are confining it, you need more stress. So that comes from that. Whether you are in a confined condition, then it will increase. That it will be very difficult to break that rock now. Okay, that's why it increases.
Okay, sir. Thank you.
Okay, it depends on the stress condition also. And so we can calculate this. So two formulas are given. My experience is this one over predicts, because from the other formula, so it gives bigger values. That's why I written. This we all know, the stand-up time. We calculate. I think this is one of the greatest advantage of this thing, that we know the stand-up time. When I will talk about Q, they have just reversed it. They said, okay, for a safe excavation, what will be the span? They didn't given time. They said, what is the maximum span you can go? जो गिरेगा नहीं, okay, खड़ा रह जाएगा. So that's the other way they have said. Okay, so this is, we all know, so I'm not spending time. And this is the original support design guideline by BNSKey. As you can see, he went by that classification, and the bolt and the shotcrete still said what will be required based on that. So I would say it's a mota-moti guideline. It's not a detailed guideline. That is a very discrete. See, in fact, within this 41 to 60, there are two different rock types. One is 40, another is 60. They are two different rock types. But it's given the same thing. So we need more continuous. It's not discrete. कि 20 नहीं, 5 होना चाहिए. Okay, it should be like that. Okay, but it's a mota-moti guideline. Okay. Then by MBR, this is the continuous guideline. This is what I'm telling you, that this is a very continuous system. I like this kind of chart. Okay, where you have a horizontal axis. Now, if you have a 48, this is, mind that this is MBR, so mining along. So you will go there 40, and you are getting somewhere here, so it's a heavily reinforced concrete. Now they have also given whether it will be requiring a constant repair, regular repair, or occasional repair. That means they are saying if you have 40, then you put this and it doesn't need much repair, it's fine. But if you are somewhere around 20, then you are going here, so what level of you are putting, let's say medium steel set, then you need to have repair. Here I think The repair, by repair they mean that you have to regularly check whether it is still connected with the rock mass or not. Or if it is a shotcrete type, whether shotcrete is still there or slabbing okay gir gaya. So those kind of things they are saying. Okay, so this is based on that MBR, and they have given as started from spot bolting to all the way completely reinforced concrete, and this support design is given. This, and I would suggest you to read and download this, and 142 pages, 195 pages, and it has very detailed with examples. 2-3 examples are there from US mines. Okay, so this is what. Yeah, in that is this, everything is there. It is there. Okay, so it is a very detailed. Yeah. Mike. These metal mines. No, we are all metal mines. Underground metal, hard rock metal mines. Okay. Okay, so the takeaway is the estimating an RMR and applying for support design is applicable for tunnels. For hard rock mines, MBR need to be calculated, considering all the adjustment, and the adjustments are given here. So this adjustment will be required. Follow the map. I'm just written that this report. Okay, there is 195 page. I do not like to put there. And then the required support will be decided based on these charts and whatever the tables they have given. Okay, so this is what is the state of the art as of now using application of RMR. So I think I will pause here for any questions, then I will go to the next. So if you have any question regarding RQD and RMR, then yes.
So while calculating your RMR, you have taken that stress as a positive or negative. So compressive strength, rock strength will increase.
It is positive.
Compressive failure.
It is positive.
Compressive failure is more quantity wise. Tensile failure is very less. So while taking the taking the direction of the drives, is there any consideration of major principal stresses, minor principal stresses?
Good question. I think in RMR directly it is not there. In Q system, I will tell you it is directly there. I will show you an example also. Let me go back here. This one. See here, this is just considering the direction of the joint with respect to your tunnel or drive axis. So as you can see here, this one, this is the strike is out of plane, right? Its strike is like this. It's coming out of the plane, and it is going like this. And as compared to that, you see, you are driving and you are basically seeing the joint. Okay. So anytime it can slip to you because you are doing drilling and blasting, and joints are like that. So anytime it can slip towards you. That's why this is very unfavorable condition. This is
as far as your opening and joint direction.
Yeah.
Joint orientation. But my question is, you are driving, you are opening a drive, you are advancing in one direction. So that opening will be subjected to two stresses.
Yeah.
One major principal horizontal stress and one minor principal horizontal stress.
Right.
So suppose your opening is in 90 degrees of opening is along the major principal direction, and your width is in minor principal direction.
Yeah.
Then there is a maximum possibility of failure of
Ekdam,
strikes.
100%. Yes.
Suppose if your drive is in minor principal direction and you are
Then you are not so much. Yes.
not so much.
Yes.
Is there any consideration of those?
In RMR, no, it is not there. In RMR, no.
in MBR it is there. In RMR there is no stress. He didn't consider stress because he developed for shallow depth tunnel. So stress was not a factor for him. But when he tried to apply for underground mines, they realized this stress is a factor. That's why you see this. Yeah, this. Yeah, if horizontal stress is more also than, as you are saying, direction curl. Isliye 1.2, he asked that question, why it is 1.2. Okay, yeah. So it can go 0.6 also. Your first condition. First condition, yeah, then you have to adjust that. Yes, absolutely. It is there here, but in original RMR, no stress. No stress condition is there. Okay, but here it is. Because in mining, we have to consider stress in our rock mass classification system. Because we are depth, range with respect to the strength of the rock is given.
Yes.
It is there.
No, up to which the RMR and up to beyond that we should go for modified RMR or this system. Is there any shallow depth we are talking about? No. Up to which depth we should consider that this system should be applied, that should be applied.
These I think, if I can remember, I think 800, up to 800 meter they have done this one. This modification was done. I think in this report it is there. They have given some examples from actual mine, how they have designed the support using this system. So in this report, I would suggest all of you to note this one, and you can just download this one. Maximum charge blast, they have considered like that. It is causing ground vibration. From there, maybe some existing joints, this may dilate, little bit open also. So those effects, they are directly considering how much charge per delay you are giving. It was not vibration, it was charge per delay they have given in the table. इतना हो रहा है तो कितना factor लेना है? If you are, how will that's what I'm saying. You know the charge per delay in the blasting. So based on that, there is a table. इतना charge per delay है तो क्योंकि value is from 0.8 to 1, so दे दिया कितना कितना देना है. ठीक है?
Sir.
Yeah.
You already covered in your lecture about RQD. Like we have to consider only 10 centimeter and more rock pieces. Now naturally already you have covered, but is there any comment if I have only less than 10 centimeter, like 9.9, 9.8 rock pieces, then I can say that it's a very poor rock because my RQD will be almost 0. Already you talked about that, but is there any comment in literature or something like that?
What, RQD less than 10?
Rock pieces less than 10 centimeter. If I have suppose 9.5, 9.9 and not a single piece of 10 centimeter.
So that will give you RQD 0.
Yeah, just.
But RQD 0 for even RMR also it do not take. In Q system it is said if RQD is less than 10, you put it 10. Because now I am going to start that Q. You will know that is multiplicative. Okay, the Q. This is additive, and Q philosophy is we multiply the factors. Here we add the factor. There is a no, you multiply the factor. Effect is multiplicative. एक का effect दूसरा में आता है. So you multiply. That is the best. Q is based on that multiplication. Okay, you can start that one.
What I think, sir?
Yes.
Here. I am here. Like this empirical and observational methods, you have to use in good spirit, but ultimately you have to take a good engineering judgment to design whatever.
Of course.
That's my.
Ekdam 100%. Ultimately, the practicing geologist or the planner or the mining engineer will take the final call. These are all guidelines. What I am saying. Yeah.
Thank you, sir, for this lecture. Sir, what is the drive limitation when we are calculating this ground supports? Like there is no drive width.
Width.
Yes, sir.
It will come.
Mention.
B. Yeah. It will come. Okay. So now I'm going to go to the queue system, which was parallelly being designed with as same time as RMR. But this was done mainly for hard rock tunnel in Europe. Now, this queue is RQD is still there. There is a one called JN, which is basically joint set number. JR, which is joint roughness number. As you can see, more or less same. There is also roughness was there. Here is also roughness there. Then alteration is that joint condition. It is there, JA. That means whether it has weathered and or some infilling material, those are there. Joint water, it is there. And this is the factor which RMR didn't have. It's called SRF, stress reduction factor. So in Q, stress is included in the system. So stress is now inbuilt into this calculation. Now you can see these are multiplicative. There is 3 basically, and these 3 has distinct purpose why they are there. And this value comes between 0.001 to 1000. 1000 is extremely good and this is extremely poor. Okay, so this is what is the Q system. Now, what is the meaning of these 3 ratios? See, the RQD is also we are measuring the joint spacing, right? We are saying 10 centimeter or whatever. So we are seeing the joint spacing. And JN is also a joint set number. That means how many joints are there. Okay, based on that. So this gives us an idea of the size of the block. How much is jointed. Kitna bada block hai hamara paas. Okay, whether it's a sugar cube type or big boulder. So that is my first. So it is giving us the idea of degree of jointing or the block size. Second is giving us the effect of friction. The blocks are there. Now, are they frictionally stable or they are very slicken sided? Okay, so this information is given by JR by JN. Whether we have infilling material or it is weathered, so friction chalai gaya, we'll say. Because ultimately these blocks are standing there because of friction. And if there is an infilling material, there is some cohesion. These two are controlling our stability. And whether they have that. Okay, this is this. And third one is the active stress. So this term was not there in RMR. It has been given in Q. So this SRF, I am going to tell you in a great detail. So they have given the Professor Burton, who has developed this, and his team, and they have given that how this value will be taken. So if there is one joint sets, he is shown like this. You take 2. If one joint sets plus random, then you take 3, something like that. It will come. So this is this joint JN table. Then this is the joint roughness table. And each table are readily available in any book. Even in our book also we have given. In any book, rock mechanics book, you will find that. Any website, you just type, then it will give you. Okay. So it's nothing secret about this. Only thing the use and the understanding what they are doing. So this joint roughness number is controlled by 2 things. One is roughness and waviness. See, the joint can be wave like this. And it can be wave but also rough. Aisa aisa hoga. Okay, so both of them are included in this JR. Okay, I will show you a picture. So this is what it is. Now this can be measured by profile gauge, or there is a Barton comb also. There is a, he has made a comb and with that. And they said if the joint is very thick and thick filled, then he is saying that roughness to chala gaya, uska andar kuch material hai. So he put it 1. Now this is what I was talking about. See, the joint profile can be stepped, undulating and planar. Okay, and out of that, this can be rough, smooth, slick and sided. Okay, so you can see that how he has given, and then he has given to show their behavior, means which one is rough and which one is, so he's saying this is a very good rough joint, but this is more or less slick and sided. He has given a pictures also, that how does it look. But actually, these are like this. You can see this is very slick and sided, but stepped. But this is like ekdam bad for us. If a joint is like this, ekdam plain, slick and sided, very bad. There is no friction whatsoever. Then the JA. JA is alteration. That means whether already weathered, water isko kharab kar diya joint ko. So there is many differences, tightly healed, hard, non-softening. When you will see the joint na, you will find kisi na kisi ek mein fit kar raha hai. Well, I have checked every time. He has thought, because right now Q has crossed more than 2,000 case studies they have done with this in all 5 continents. So it's a very well tested system. So किसी ना किसी एक तो fit करेगा ही, okay, आपका description जो दिखेगा. So and accordingly you will know. Very interestingly, this J R by J, this is also basically the friction angle. What do we call? The friction angle and cohesion we call it. This is also represent that. So that's why they have given this friction angle side by side also. So this can directly go into the numerical modeling, this one. Because we need this value in numerical model. So we can directly put from there. And then this is the water condition, it is same as RMR, more or less. Well, the concept is exactly same. There is no distinction here. This I am going to spend 2 minutes because this was not there in RMR. This is specifically for Q system. Now SRF is the stress reduction factor. So they are considering the effect of stress. Now they have divided into 5 categories. First one is, you see, the weak zone intersecting the underground opening. So there are some weak zone like clay zone. Sometimes we are driving, suddenly a clay zone has come. So how to alter that values, the rock mass value when? Now if you have more than one, what happens? So this is where he is saying you have a weak zone intersecting an opening. You are driving, suddenly saw a weak zone. So this will change. Now you can see he put 10 when there is multiple occurrences. Then if this is a single weak zone, he put 5. So let me just show you that picture first. So this is what it is. If this is the tunnel or your drive, you are seeing in the plan view, and let's say a single clay zone has come on the roof or in the side wall. So you will put 5 here. Okay, this already SRF will be 5. Your other rock is competent. These rocks are fine. But suddenly a clay आ गया. So उसका लिए घट जाएगा 5. But if it is multiple and your tunnel is here, so this will take 10. So and you can see the SRF is sitting in the denominator. So it will drastically down the Q value. Okay. So first is this weak zone. Then he has divided into competent rock. This is where our condition also comes. Competent rock but shallow depth. See, low stress, like Mr. Ujjalta asked, that with the depth. So directly depth is not there, but it's low stress and medium stress is there. Okay, so low stress means let's say 100 meter, 150 meter below. Medium is maybe up to 400 meter. उसका बाद आपका stress बढ़ता चला जा रहा है. So your rock is very competent and you are in low stress condition. Next, competent rock, massive and stress related problem. This is basically very high stress region which 1000 meter, you are going 750 meter, 800 meter below. Then you are coming into high stress zone. Okay, this is the zone you are coming, and see this part, this K, this spalling or the rock burst, किसी जगह में हो गया जैसे माइंस में, किसी एक इसमें rock burst हुआ है. Then they are saying if this condition happen, you may take up to 50 to 200. मतलब it will drastically reduce the Q value. Because एक जगह में already हो चुका है. That means this area is rock burst prone area. Okay, so or very high stress condition. Your rock is very competent. Also there is lot of stress. This is not good for drivage. So your Q value should go down. Okay, this is what I am saying. This is not there in RMR system. We are missing that. So later on they have added it. Okay, but here it is already there. So similarly like this, there are many 5 conditions are there. So I am not getting in detail. So as I am telling you, see this, you are making a tunnel or a drive, let's say here. So there is a very anisotropic stress. आपका ये stress very high and this is very low. What Ravinder ji was also telling, that एक बहुत ज़्यादा एक कम है. Then क्या होगा? See, same rock. Your tunnel is here and your tunnel is here. Completely 2 different scenario. RMR will say same value. Q will say very different value. They will say this is not good place. Okay, your Q value will be very low. Here you are very safe because you are near isotropic condition. दोनों side से more or less same stress. So you are in a much better condition. Same rock mass. Just because of location and stress changes, so your rock mass value will change. Then they have given the category or the rock mass class. My feeling is anything above 4, you are very good condition. Okay, 4 and above, it practically do not have to think much. But if it goes below 1, this is where major support system will be required. Okay, so below 1, D and below. Okay, but if it is anything above 4, you are fine. So this system, I think it consider many things, and over the years they have modified. It consider many things. In situ stress considers, weak zone, shear zone, slabbing, spalling, everything is considered in one criteria. However, again, blasting is not there, but majority things are there. Now, where is the application? Again, same, rock mass strength we can calculate. So, what is the strength of rock at the field? We can calculate directly. Similar like RMR, we can calculate the deformation modulus also. Same, which I am telling you, this directly goes in numerical modeling. Okay, those who know, they are saying, yeah, we use this. We can calculate the bolt length. I will talk about ESR just next slide. This is called excavation support ratio. So this and this B, I think somebody has asked about the width of the gallery or the width of the drive for the excavation. This is that B. Okay, this is very much included when you calculate the bolt length. Okay, ज़्यादा बड़ा होगा, ये length भी बड़ा होगा, तो होना ही पड़ेगा. Okay. Then this is the opposite of stand-up time. I told you, this is saying maximum unsupported span. So, कितना बड़ा रख सकते हैं? So, it is based on Q and there is a ESR, I will tell you this table. And the maximum roof support pressure, that we do not use much. Now, what is ESR? it is excavation support ratio. This is depend on what is the purpose of that excavation. Okay. Now, let's say temporary mine opening. They say you take 3 to 5 value somewhere. If it's a vertical shaft, it's 2.5. Rectangular or square section of the shafts, if it's a rectangular shape, 2. Permanent mine opening, which here we do mostly, let's say, footwall drive we are doing, which will be more or less permanent. Then we use 1.6. Mostly ours is 1.6, mostly when we design something, or sometime 1.3. But powerhouse, storage house, because this also apply for many civil constructions. So that's why these are there. This is 1. Now, this excavation support ratio comes span divided by ESR. This gives the equivalent dimension for calculation of the support. So you have to just know, let's say if this is 5 meter divided by 1.6, so 3 point something aega. So that is my equivalent dimension. And this is the span I already told. Then it comes to this support design. This is one of the most used support design chart nowadays for mining, tunneling, and every other purpose. And it has modified over the years. We are also use this heavily, this chart. So what it says is, this is Q from 001 to 1000. This is Q. And this is that equivalent dimension, DE. Your span divided by ESR. ESR, again, depending on what purpose. Okay, 1.6 for permanent mine opening. So we are giving there, and then it says, see, 1 से 8 तक zone divide किया है. 1 मतलब no support required. If your things are here, मतलब that's why I told you anything above 4. Okay, and you see, हमारा dimension maximum होता है 5 meter. Your this 5, 5.5 meter divided by 1.6. Those are permanent, so it will come around 3 point something. So if you can see 4 and 3 point something here, so you are right at the borderline. So very minimal support is required. So हमारा mining case में anything above 4 support just bolt लगाने से भी हो जाएगा. But if you are doing a crusher chamber, let's say, which is 15 meter wide, okay, yeah, height भी है बड़ा, then you may, and if your rock mass is, let's say, towards 1, then this will come somewhere around here. So it comes around, let's say, number 4. I will show you with a example. So it's number 4. So what it's saying is then that these red lines here are this 6 centimeter, 9 centimeter is the thickness of shotcrete. Kitna dena padega. And these are all fiber reinforced shotcrete. Okay. Kitna percent fiber lagega, kya lagega, everything is there. Okay. And then this side is the bolt length. So you can come here and let's say if your data point is here, so you can find out what is the length of the bolt will be required. Okay, so length of bolt मिल गया. इधर देखिए spacing of the bolt है. So आप इधर से इधर connect करेंगे जहाँ match कर रहा है उधर वो spacing मिल जाएगा. So you are getting the spacing, getting the length, getting कितना thickness of the shotcrete, you will be requiring for that. Now if you come in this zone where it is RRS is required, now in the next I have given the explanation of this. The RRS is nothing but आपका reinforced concrete, मतलब जिसको हम लोग RCC बोलते हैं, वही. And इसमें आपको सिंगल रॉड चाहिए या डबल रॉड चाहिए, वो भी लिखा हुआ है. वो रॉड का डायमीटर कितना होगा जो रेनफोर्स कर रहे हैं, वो भी लिखा हुआ है. कितना स्पेसिंग में चाहिए, that is also there. Everything is given here. So this chart, someday when we will give a training, we will go in very detail. So I am not spending time. So it is like this. In a zone where you are some around here, see the Q value is very low, let's say in RRS B, then what you need to do and how to construct that. So every details are given there. So पहले आपको shortcut मारना पड़ेगा, then इधर reinforced concrete देना है. And these are the reinforcement. इसका distance कितना होगा and इसका diameter कितना है, everything is given. So it's a very well designed support system, and as I am telling you, it has been applied in over 2,000 case studies, and they are applying this chart now. Now the example, एक छोटा सा example, देखा हम Q system खत्म करेंगे. So we read it. A drift of dimension, let's say 5 meter by 3.5 meter will be developed at a depth of 750 meter below with a schist type of rock which is competent, let's say. The average vertical stress gradient is itna megapascal per meter. This is the stress gradient. The joints are smooth, planar, slightly weathered with minor surface staining. This somebody has observed that. Laboratory test of core samples of intact rocks give an average uniaxial compressive strength of 120 MPa. So it's a very competent rock. But joints are smooth, planar and slightly weathered. Joints are like that. Okay. The principal stress directions are approximately vertical and horizontal, and are of magnitude of the horizontal stress is approximately 1.5 times of vertical stress. Let's say stress measurement shows that horizontal is 1.5 times the vertical. Okay. Now the rock mass is locally wet with very little flow of water. So it is wet condition. Because this is now what is the support I should design for this one. This is the problem. So now first is, by looking at this rock, I can say it is a very good category, because if I see the dimension, this 5 meter, if this is 5 meter, then this is more than, close to 3 meter or 3.5 meter. So spacing is very big. So, and you can see there are two sets of joints, one this way and one that way. So I can say RQD is good category, let's say put 80. And JN is two joint sets here, directly seeing two joint sets. And let's say kuch random hai, so I took random. So this comes right here, number E. So I'm JN condition, I'm taking this one. So my RQD 80, JN is 6. Now in JR, this is just assumed because this condition said is smooth and planar. Your joint condition. See, this side joints are smooth and planar. So I have taken smooth and planar. The value is 1 for JR. And this is slightly altered. It is written slightly altered. So I took the value 2. So JA is 2. And it is a medium inflow because it is wet. It is showing not damp. So I consider 0.66. So this is becoming JW. So itna pass to ho gaya. Now come the SRF, how to calculate it. So for SRF calculation, what we are seeing is the vertical stress will be 750 meter into, this is the gradient. So vertical stress at that depth is 20.75 MPa. Okay, at that depth. Horizontal stress is 1.5 times of that. So it is 30.375. Now, the compressive strength is given 120 MPa. So this is the ratio we get. So आपका जो बोला था measure divided by this, we are seeing 0.253. Okay. Now this, I went there in that table, SRF table, it's a competent rock with medium stress condition. See, if this is 0.75 or close to 1, that means very high stress आ गया. ये 0.25 मतलब 1/4, we can consider about medium stress condition, so SRF is 1. So we can put at 1. So now the Q value is coming to be 4.4. So 4.4 we get the Q. Now I go back to this chart and I see it is 4.4 and मेरा 5 meter हो गया इधर. So 5 by this is a permanent because it's a, let's say it's a permanent drive we are making. So ESR, the excavation stress ratio, we are taking 1.6, so it's 3.12. So आपका जो वो drive है, in this it is right here. So this tells me about 2.4 to 3 meter bolt maximum, and 1.7 meter हो जाएगा with fiber reinforced. If you are putting with fiber reinforced, it will be 1.7 meter. मतलब if you are putting the shotcrete also, then bolt length कम कर सकते हैं. And bolt spacing will be 1.6 to 1.8 meter. From this we can see right here. So 1.6 to 1.8 meter. Fiber reinforced of 5 mm, 5 centimeter. We are putting maximum unsupported span up 5 meter किया. Maximum you can go up to 5.8 meter. 5 meter आप कर रहे हैं, but you can go maximum up to 5.8 meter. उससे ज़्यादा नहीं जा सकते. So this is what from here. But if this is a crusher chamber of let's say 15 meter हम कर रहे हैं, then ये 9.375 हो जाएगा. So मेरा ये इधर आ जाता है. इधर आने से हमारा bolt length increase हो जा रहा है. Okay, and then bolt spacing घटाना पड़ेगा. So घटा दिया. And fiber reinforced of 6 mm करना पड़ेगा. ये हम 6 mm का आसपास आ गया. Sorry, 6 centimeter. So this is how your support will be designed from this chart. Okay, so this is the advantage of Q system. Now here you can see, consider joints, consider stress, consider intact rock property, everything you have considered. इसमें सब ले लिया. Other than the blasting, okay, जो we go. We'll take question after I finish this very quickly. See, this GSI is a very new system.
One question, sir.
Yeah.
So in this whatever support calculation, that vertical stress जो gradient है, that we have taken it as 0.027
MPa per
average, let us say. So based on that vertical stress, we have calculated the horizontal stress.
Yeah.
Horizontal stress, assuming that it is 1.5 times the vertical stress.
From the stress
vertical
measurement.
Stress. But the problem with metal mines is 700 meters is a shallow depth. In shallow depth, vertical stress will, horizontal stress will be more than vertical stress. As we go deeper and deeper, we will attain a equilibrium condition where rock will be subjected to equal horizontal and equal vertical stress.
Right.
So below that point, that
almost 1,000 meter below. What you're saying, it comes around 1,000 meter.
Oh, okay. If we go below that, so rock will be subjected to only vertical stress and your horizontal stress will be almost nullified, or it is offset by the vertical load. So there we will be subjected to, that excavation will be subjected to higher strain values. Excavation opening jo, that will be subjected to higher strain values. And that will result in bumps and side falls. So for that, what kind of support design we will have in this mechanism?
Right. See this one, the number C, I took from number 2, right? This one, I took this one. But there is a number 3 also. Competent, mainly massive rock, stress related problem. This is what you are referring to. Now, if you see spalling is occurring someplace at that depth, then you can see this value can increase all the way up to 50, 1 से 50 हो जाएगा. So your Q value will reduce drastically because ये 50 से divide हो जाएगा अभी. So they have considered. I told you, you think of a problem, it has a thing. You will find somewhere it is written. मेरा अभी तक नहीं हुआ कि I saw something and it is not written there. So somewhere you will find that it is written. And if somewhere this burst has happened in that particular mine, let's say, then they are straightly saying you have to take 200. So 200 से divide हो जाएगा. Very high. So that is what here they are considering. This is a very unique condition, and that's why अलग करके टेबल दिया इसका. पूरा स्ट्रेस का मेजरमेंट का साथ वैल्यू दिया. ये जो वैल्यू है ना, वो इसका क्या, इसका इस दो को अलग करके डिवाइड करके एक्सप्लेन किया कि व्हाई इट इज सो हाई. बिकॉज द स्ट्रेस रेशियो इज यू सी 10 टाइम्स, और आपका जो कंप्रेसिव स्ट्रेंथ है हम दिखा है 0.25. दे आर सेइंग दिस रेशियो इज ऑलमोस्ट 10 टाइम्स. मीन्स फ्रॉम इफ योर compressive strength is 50 MPa, it is almost 500 MPa coming. It is that range ho gaya. That is what is the rock burst prone area. So they are saying you have to modify Q very drastically because you are in a zone where stress is very high as compared to strength. So they have further explained with this area. So any situation it is there. So far I have seen it is there. Stope का due to stope means इसका effect आएगा nearby drive में definitely, because stope आप जब ले लिया then the effect of that will come to the, let's say, the footwall drive और इसका nearby जो extraction cross cuts जो भी है उसमें आएगा. इसका effect directly नहीं है, इसमें नहीं है कि इस once you mine this area, what is the effect there? It is not there. At least I do not see it is, they have considered that. But if you are doing a, let's say, a chamber, crushing chamber or any other big excavation, you can consider. Yeah. Yeah, right. After तो हो गया, you are not going there. Yeah, right. Yeah. So the GSI, it has the first published in 1997. Now, this talk will be based on these three paper. So it consider only two parameters. It is very simplified. It's a kind of oversimplified, but it works. It is very interesting. It is simplified such that it also works. So there are just two things they consider. One is blockiness of the rock mass, and another is condition of the discontinuities. That is the two things they are just considering. No, what are बाद में add किया है, I will tell you. Later on they have added all those. But ये जो green color है, this is a practicing geologist can estimate GSI with very ease. It is for them. And what they have done, the technology, they have given it to the help to the practicing people. Okay, so that they can calculate at every 10-meter distance if they like. Okay, it is so easy to calculate, and that is the main purpose. And another purpose is that these value now required for numerical modeling. Without this, we cannot use numerical models. So the author of this, those who have said, they have said they have given some caution also. कहाँ use करना है, कहाँ नहीं use करना है. And They say this approach is ideally suited to situation in which rock mass behavior is relatively simple. For example, RMR values in between 30 to 70. They said in this range, RMR hai, so this is will work very well. Okay, so if it is below 30 and above 70, it will not work. Where mostly sliding and rotation type of effect is there in the rock mass behavior. And they said that this, I 100% believe this is not going to replace RMR or Q system. एक कहना से आई GSI calculate कर लिया और कुछ नहीं करना पड़ेगा, वो नहीं चलेगा. This is additional. Okay, so this is never intended. Even they say never intended to replace this. And its only function is to estimate the rock mass property. And this is what I am going to tell you now. GSI calculation for adjusting the rock mass properties. See, I told you we can calculate rock mass strength, rock mass modulus, deformation modulus by Q by RMR. But this system is now directly going into numerical mode. So nobody can avoid it. मतलब हम लोग जब भी काम कर रहे हैं for different like ACL or different, we calculate it and we directly put it. Although it is not mandatory for submission in the report, but I have to do because I do numerical model. And इसको हमको calculate करना ही है. So this is the chart. That's it. This. इसमें है एक structure and एक है decreasing quality. That's it. And कुछ number दे दिया. So you are taking print of this, going to the mine. You seeing your wall and roof. And let's say you are standing there, seeing it. कौन सा condition best suit कर रहा है हमारा इसको देख के? Okay, which one? So you have chosen, let's say, very blocky. Okay, then you see the joint condition. Whether it is rough, slightly rough, this, that. So you are saying, okay, it is more or less somewhere around here. 50 का आसपास है. You just give a circle here. That my value is this. And write the location. Go again 10 meter or 20 meter, do the same thing. See whether any changes are occurring. So that's why it is very helpful to practicing geologists. In a one day, they can calculate many values. But in Q or RMR, it is not possible. This is, so they brought the technology to the hand to the practicing engineers and geologists. And then, very interestingly, when you are calculating just like this, then you calculate RMR that place. And they found out, the authors found out, it is just or more or less 5 minus of that RMR. So they verified it by existing RMR value and use this. And they say you can GSI, you can put RMR 89, which is the latest version what we use, and minus 5. So it works. I mentioned this before, and that's why the caution here is we do not calculate GSI for these two. Okay, it is not required. So this is the author's caution, what they have given. They said there is a mine, iska GSI they calculated 85, but this failed. Okay, they could not understand why. GSI is so high, that means RMR was almost 90, 85 tha, or 80. So 80 RMR failed. Then when they inspected, they found out it is the stress which has caused that. Okay, even this almost intact rock could not handle that stress. So it failed. So say GSI 85, everybody will think it's very nice. कुछ नहीं होगा, but होता है. तो बोला है कि जब इस तरह का condition है, very high stress condition and anisotropic, principal stress, major are very high, minor are very low. This is not a good system because GSI do not have stress into consideration. Another बोला ये, जो number 2 point, I told you this one. So this one is, this is controlled by individual joint, इसका failure. So बोला कि is individual, then we have to find out the property of that individual this. You cannot say it a mass. It's a joint control failure. The joint fail कर रहा है, not the mass. So आपको joint का बारे में ध्यान देना है, not the mass. So these two conditions, they said it may not work. बाकी सब GSI के लिए एकदम perfect है. And हम लोग जो calculate करते हैं normally I have seen in Khetri and Kolihan, it is about 56, 60 इसी range में है GSI. So it is perfect for these mines. For this also we can use this type of rock. For very weak rock, they have given another chart. I'm not spending time there. And if there is a water, they say you just shift it depending on where your value is. So you can shift -8 or just right shift hoga if it is wet. Now why we do GSI? See, this is the failure criteria now being used. It's called Hook and Brown criteria, and every numerical modeling is now using this equation for testing whether rock will fail or not fail. This is the equation. This is the major principal stress, minor principal stress, UCS, and these three are the parameter based on GSI. So we have to calculate GSI. Otherwise, we will not know when rock will fail. So these two stress we get from the numerical analysis. This we supply as a tested value from the lab. These three parameter, MB, S and A, we calculate from GSI. And this goes into numerical model. So definitely we have to know this GSI. Now, what is the relationship between these three? GSI RMR, I already said. RMRQ, this is the relationship. There is two ways it can be calculated, which 2% has given 2. And this is mota moti a chart between those block size. See, this is 100 is for RMR, Barton ka 500, then what will be that M and S values? So, wo jo is equation mein jo M and S values, those are given there. So, we do not use this chart, we directly calculate. But there is a chart given between, this is RMR, Q, and you can see this is RMR and Q, and what will be the value of that. From here, we can calculate, this is all goes into numerical model, as I'm telling you. This equation is there. We'll go, I'll show you one Excel file, how it is changing. So we calculate this rock mass strength. See this MBS, A, it's interrelated, and these all three are based on GSI. So we cannot avoid this. And this also goes into numerical equation. So we have to calculate them. Just a quick, this thing, I think in the morning, Mr. Ujjwalta said that we have to devise, I think Mandekar Sahab bhi bola hai ki, finally, what is our aim? Our aim is to whether we can make a system which is applicable for Indian condition. So, a suggestion. Now, if let's say this is the stope and this is the footwall drive and we are going to the stope. Now, let's say if now the geologist, they can calculate at every 15 meter or 20 meter, so we can calculate the contour of GSI, right? On these drives, we can calculate contour. So I'm just giving an example. This is just I made it up. So let's say this is where is 60, then suddenly it become 40, then 50, then it is 40. Then something like this happened. in this. Now, we will see a pattern of how the GSI value is changing and which direction. So this may be, we are already making geological map, we already make mining map, mining plan, the working plan. Now there will be a GSI plan. So you also know GSI plan. Now on top of that you put your support plan. क्या support लगाया था? उसका भी एक index निकाल देते हैं and वो भी इसका ऊपर डाल देते हैं. So हमारा GSI इतना है तो कितना support दिया था? Whether we have did it correctly or we need more support there. So if we have this kind of maps, which you can consider like a geomechanical maps, means GSI भी हो गया, support भी हो गया. So we can know that for the geology condition exists in the mine, whether we are responding with the proper support. और किसी जगह में कम हो गया, किसी जगह में ज़्यादा डाल दिया जिधर ज़रूरत नहीं था. Okay, so this can not be. This is for the future. A map, two map can be developed like that. So this is probably for the future. तुम तो Excel file थोड़ा डाल दो. I will just show you what goes into the numerical model. If anybody wants, I can give this Excel file also. You can carry on. Let's say this is underground. We have to give depth, density of the rock, GSI value, blast disturbance factor. Blast disturbance factor comes here. Hook-and-Brown parameter, then MI, there is a initial value we have to supply, and compressive strength of the rock, and these two are tested in the laboratory. Okay, these three rather tested in the laboratory. Now these are the input. Now what we will get is we calculate MB, S, A and all this stuff from that, and you can see we automatically find rock mass strength from that equation I showed you. Now you compare intact rock 56, आपका value हो गया 8, field में 8. You have tested 56 in the lab for 60 GSI and blasting damage factor about 0.5 out of 0 to 1. This becomes 8. So your field compressive strength is 8 MPa. It's not 56. This goes in numerical model. In numerical model, then this, see here, this is 9.87 GPa. This becomes 3.48. So this will go into numerical model. Okay. Srinivas, you just change that GSI. GSI को change कर दो. You make it 40. So this will change. Okay. So now you see, just before 49 हो जाएगा 1. So it's just like becoming like a soil. Okay. So and sigma CM from 8 से 4 हो गया. So this is, that's why the GSI is so important. को थोड़ा सा change होने से आपको rock mass property drastically change. Okay, this is for tunnel. Similarly for slopes, also we can calculate. Formula में थोड़ा सा अलग है. For slope also we do the same, and that's why GSI we need to calculate for numerical model. So if you have any questions, I have just one more presentation on slope, and then my presentation will be over. Then Srinivas will show you some numerical model we have done, uska thoda case studies, how we have done it and what was the result. Any questions on these two? Yeah. थोड़ा माइक जोर से बोले थोड़ा.
Presentations with all attendees or something like that. Another question is, sir, simple clarification. Why this GSI is not so popular in our country? That's my so simple question actually. And how we can make it popular?
What?
Why this GSI system is not so popular in our country, and how we can make it popular if it is not so?
Very good question. See, nowadays we all use hook and brown criteria. There is another is Morculum, you know. So, but even if we are using Morculum, we still need rock mass values, and that comes from GSI again. So, whether one likes it or not, now we have to calculate GSI along with either RMR or Q, whatever we are choosing. We cannot avoid this. Because if we have to do a numerical study and submit a report, then you cannot avoid GSI anymore. Because अब कोई भी सॉफ्टवेयर फ्लैग ले लीजिए, जो भी सॉफ्टवेयर ले लीजिए, सब ये मांगेगा आपको कि ये वैल्यू दीजिए. Now what value we are giving now? See, now we are calculating ourselves. What I want, the geologist or the mine planner in the mine will calculate in every 20 meter, 25 meter. Okay, because it's so easy to calculate. And you make a map, then it will be very easy for us. हम लोग जाएंगे इसको लेंगे and हम पूरा mine में different value. अभी क्या करते हैं? एक लेवल में एक वैल्यू दिया, दूसरा लेवल में दूसरा वैल्यू दिया. अभी मैं every 50 meter में I will change the value. So my modeling will be much more accurate. The results are what I will get. So that is how it will become popular.
अभी सारा जो स्टडीज स्लोप स्लोबिलिटी में हो रहा है, सारा वो बुक एंड ब्राउन क्राइटेरिया में हो रहा है. पहले बहुत सारा स्टडीज में वो हम लोग पूछे थे, अब हाउ यू डिराइव दिस प्रॉपर्टीज, जस्ट दे डिड इट इन लैबोरेटरी एंड दोज प्रॉपर्टीज मीन्स इंटैक्ट प्रॉपर्टीज ओनली दे यूज. दैट्स व्हाई इट वाज नॉट पॉपुलर बिकॉज most of the studies we have reviewed, in that one intact properties are being used instead of rock mass properties. So now we are insisting for the rock mass properties. They should have to calculate rock mass properties. If they want to calculate rock mass properties, this GSI is the because it is an input parameter, so they have to go for GSI.
Yeah, अब देखा है अभी 9.87 was modulus intact, and if I put 40 and blasting effect 0.5, this comes to 1. So आपका almost 90% modulus gone in that rock mass condition. So you cannot put that 9.87 and do the numerical model. आपको 1 value लगाना पड़ेगा. That is what.
Even in numerical modeling, generally we are using elastic properties, but rock is not elastic; it's a elastoplastic. So we have to go for elastoplastic properties also.
Right.
Because we are considering rock as a continuous rock bar.
हाँ, elastoplastically आपको either C5 चाहिए, cohesion चाहिए, friction angle चाहिए.
Not only along pre-failure, but we need a property post-failure also.
Yeah.
Post-failure curve.
Right. ना उसके लिए भी जो आपको cohesion and friction angle निकल रहा है, वो भी वो GSI से ही आएगा. That is my question.
Good morning, sir.
Yeah.
Myself, Ayan Giri from Hindustan Zinc Limited. So, excellent presentation. And my question is on, like, Q has these 3 major blocks of factors that we have. But do you believe that it somehow underscores the direction of the development or drivage? Because we do not have a correction factor in Q as of now. But in RMR, we have a correction factor where the dip and the direction of the development really plays a major role when you are designing the support. But somehow Q underscores that impact of the direction of development. Though Barton, in his earlier thesis, he has mentioned that Q, he has not considered a direction. But now, with the advent of time, I think, do you believe that there should be a factor in place for...
Right. I think directly it is not there.
You are right, directly not there, but in terms of stress it is there. Because they are considering the major principal stress, but not the direction, the value. So in terms of direction, it is not there in Q.
Yes.
You are right about
Means
that.
what I mean to say, the direction of the major structures in the development, it does not have a score, because if we say have the same joint number for a development, if we have a direction of development in a different, maybe perpendicular to that structure, or in a direction different to that, it has a major role in play when you are designing the support. So somehow it will have the same support design for the same rock mass, but it will have a different response of the ground.
Right, as I am telling you, direction is not there in Q. Direction of the joint with respect. Yeah, that can be thought of, this is one. Or what they have done, what Button has done, he put the value.
एक suggestion है साहब. If we are able to measure the actual in situ stresses, in situ stresses in advance, so that can be used for.
It is already there in Q. What he is saying, direction is not there.
Direction
but
is
value
not
is there.
Direction is not required. If you have in situ stress directions.
Yeah, maybe you are right also.
With that we can
उससे
have.
हो जाएगा. Joint orientation is not there.
So joint orientation with respect to drive edge direction.
Joint orientation
which RMR में है, इसमें नहीं है. वो that is what he said. But value is there. That is what I am saying. Okay, with the time
माइनिंग मैं सोच रहा हूँ कि not all over India, but then at least Hindustan Zinc and then now Hindustan Copper also doing paste filling. तो वहाँ पे बेसिकली आइडिया क्या है कि 100% एक्सट्रैक्शन. तो वहाँ जो रिप पिलर हम लोग लास्ट में एक्सट्रैक्ट करते हैं, और रिप पिलर एक्सट्रैक्ट करने के लिए हम लोग जो फील्ड मटेरियल है पेस्ट, उसमें ड्राइव करते हैं. तो उसमें तो जियोलॉजिकल मैपिंग कैसे होगा सर? तो उसके लिए भी हम लोग कुछ सोचेंगे. और हाँ
सर, वी आर डूइंग इन एचजेडएल. दिस इज द वेल डिजाइंड, दैट इज द इंजीनियर्ड ग्राउंड. whatever is cement, whatever is strength after days, वो तो और भी सर उसको फोरकास्ट करना, इट इज वेरी वेरी इजी. उसका मॉडलिंग फिर दूसरा होगा.
बेसिकली वो रॉक मास नहीं है.
यस यस.
हाँ, ओके ओके.
सर
यस यस.
हाँ, राइट.
कंटिन्यूअसली इन अगुचा एसके.
सर पेस्ट फिल जो है ना, पेस्ट फिल इज अ होमोजेनियस काइंड ऑफ मटेरियल एक्चुअली, एंड यू गेट, यू नो, व्हेन यू टेस्ट पेस्ट फिल you get up to 2 megapascal usage or something like that. So that's why, because being it's a homogeneous material, sometimes you.
I 100% agree with you.
Your drivages.
I am for professor कि हम लोग बहुत discussions किए कि भाई GSA आना चाहिए. This is very user friendly and बहुत अच्छे से use होगा. But the problem is कि जहाँ पे ये GSA नहीं रहेगा, वो सॉफ्टवेयर काम नहीं करेगा, तो we don't have anything specific for that drives. So then the future regulating body should not object and say कि यहाँ पे इसके लिए तो है नहीं GSI.
नहीं, आपका पॉइंट पूरा वैलिड है. आई थिंक वी हैव टू डिस्कस ऑन दैट.
यस, थैंक यू सर.
पेस्ट फिल जो जा करते हैं वहाँ के इंस्टीट्यूशन ऑलरेडी.
सर मैं माइनिंग इंडस्ट्री से अपने पैर पे क्यों लात मारूंगा, पेट पे क्यों लात मारूंगा? मैं चाहता हूँ कि उसका सोल्यूशन भी फ्यूचर में हो.
ओके, थैंक यू.
एंड दिस इज द बेस्ट प्लेटफॉर्म. थैंक यू सर.
ठीक. आई थिंक पॉइंट नोटेड. Okay, my last presentation is on slope. I'm going to talk about two classification here. One is Q slope, another is slope mass rating, which is a modified version of RMR. And this is a modified version of Q. Now, in Q slope, again, what we get by calculating Q slope. I'm directly going there. This is also now about 10 years old method, and the authors are claiming that 600 case studies they have done based on that. I am not sure how many mining, because that is they have not classified, so this part I cannot say. Whether it's a civil slope or mining slope or both, I'm not sure. But what it does is, it calculates a value and give the slope angle. This is what its main purpose. A benched angle it will give for long term standing. So without any support, what should be the slope required? So that is what it calculates. For example, they have given, if this is a slope, so they are saying based on the Q value, your slope angle will be different, and we see that. Okay, even in mines also, आपका top benches slope का जो angle है, it will never be more than 45, but in the bottom benches it will be 70 degree. Okay, so there is something is acting there, and this is the authors have found out a relationship with Q कि ये हम कर सकते हैं, and that is what I am presenting to you. So here the base parameter is this of the Q. See here क्या होगा, water condition change होगा, and the stress condition is drastically changed. It is not like underground. So that's why they have handled it different. This is where they have changed. And ये जो orientation का बात हो रहा है, this is also they have modified this for the orientation, because in slope you cannot avoid orientation. You have to know what is the orientation with respect to your joint. Orientation of the slope with respect to your joint orientation. So this you cannot avoid. So they introduce, instead of JW, which was water, they call JW ice. It's a environmental and geological condition. It's a very interesting parameter. And they did a SRF for slope, because it will not work underground wala idhar kaam nahi karega. So isliye they have made a new table for this slope. And this one they have modified by that factor, that environmental and geological factor. They call it a O factor. Now I go ahead with this with some example. So I have taken these two pictures. One is something like this and one is something like this. Can anybody guess what will be the RQD for this? Although scale is not there, but let me go ahead. I just put some value. I consider it is fair, because you can see there are at least two sets of joints with lot of random joints. So it will be in the fair quantity, and so this will be about 65. Joint condition, joint number we will get from 6, so it is 2 joints. We are seeing one like this, one is like that, and another is like this. We can see these two very well. And some random, so I have considered it 6. This one, its RQD is good. If you can see, these pieces are bigger. It's a very big picture. So each individual block is more than 10 centimeter. Okay. In fact, where from I got this, they have written, pieces are very big. But it's a lot of pieces, like a sugar cube piece. So RQD is good, but there is 3 sets of joints with random. At least 3 to dikhai de raha hai. And random, so you can take 12. So this is the condition for RQD and JN. So we can put this. Then we come to the O factor, that means the environmental factor. This I just assume. So this is the, I have given you, I consider it C2, the first wala. C2 matlab this, smooth and undulating. But one has to go close to the joint and see what is there. So this is just assumption, okay, C2, this is not exactly known. So I gave this, and joint alteration, next page I am going to show you. And for this one, I consider E, which is
rough and irregular and planar. Okay, I consider that. And this joint alteration factor is taken pehla ko bilia and second ko delia. Okay. As I am telling you, this will come from the field. Okay. Here is just assumed. So B is unaltered joint wall and surface training only, and D is silty sandy clay coating. We are assuming, let's say it's 3. So we get, then this one is 2 by 2, and where from this factor is coming? This is that new factor they are saying based on orientation. Now this is that favorable, unfavorable, again the same thing comes. Okay. And this I have considered it's unfavorable 0.75, and this one very unfavorable, let's say 0.05. These are all will be with respect to the joint plane angle. So this, and if you have a wedge type, then 2 joint plane will be there. So actually this is summation of this. So here we are just taking these 2, because there is just one joint, there is no wedge. So this I already explained. Now this is JWIs. It's very interestingly they have designed. They say geological structure, whether stable, unstable, intact rock, competent, incompetent, and what type of condition. It's a dry condition, wet condition, tropical storm condition, or icy condition. So this, other than maybe Kashmir or this thing, Himachal, this will not come to our place. So ours is mostly these 2, and maybe some area in eastern part we have stormy condition. So in this case, I consider the first one as a competent rock. This is a competent rock, but it's we considered. Sorry, it is the second case. It's second case. Second case, I consider it's competent. Rock is competent, but it is unstable. Okay, and let's say wet condition. So 0.5. Second dollar, I consider it stable. The slope looks stable, rock, but also competent, and it's 0.7. So taken here. Okay, sorry, it's here. This is 0.7. So ye aa gaya, and the last part is stress factor. They have given 3 tables, and they said out of these 3 tables, whichever is the maximum you have to take. So in our case, in this case, we can consider them slightly loosening due to surface or loose block. This I consider for the second one, and this I consider for the first one. And here the stress related data is not there, and this is also measured discontinuity is not there. So these are not available, only this is available. So we will consider this is 2.5 and this is loose block 5. So now the total calculation, total calculation will be coming 2.27 for this, and this is 0.17. And this is the formula they said. Now if you want to make a bench for rest of the life without any support, what should be the angle? This is what it will give you, this formula. Okay, without any support, what is the angle? So they said 20 log 10 Q slope, whatever the value, plus 65. And so this comes about 72 degree, you can keep. It's the bench slope, not overall, bench slope. And this is 49 degree. So where from it is coming? From their data, they gave a line. This is that line, and our these 2 cases are this 72 and 49. So I then summarize that for the example 1, if RQD is 65%, 2 joint sets and random foliation joints, smooth undulating joints, all these, then it will be, your bench slope angle will be 72. And in the next case, although RQD is 80%, but you have 3 joint sets and all, so this will come to 49 degree bench slope angle.
So after getting that, what do we do? We calculate the bench slope angle. Then we make the, let's say this is the overall slope we make. So at different day, this is different angle we have. And these are the joints, it is there. Then the Q slope values are determined. So we got the geometry. Then we calculate the friction angle from this. And if the joint is filled with clay or sand, we will put some cohesion value. And application of GSI here, it is Q slope will be designed like this, the slope will be designed based on this Q slope values and the slope angle. Then friction angle and cohesion will be estimated from GSI, if you are using GSI. And then once we do that, it will go to either limit equilibrium method there, and in limit equilibrium method, you will require this C value and these two value. These two value are required, and along the joint it will slip. If you have water and a tension crack, then all kind of pressure stresses we have to consider, and this is the general limit equilibrium method what we use. So with this geometry, how it will stand. And if we are doing the numerical modeling, we have to make the mesh and put the same material values, and you find out what is the safety factor from the numerical model. So either way, so Q slope is being used to find out the bench slope angle, which will give me the geometry. I do not know the height of the bench and the width of the bench. This is my design parameter. So let's say I need a safety factor of 1.5. So what height and what width I will vary, and either using limit equilibrium or using numerical method, we'll find out what is that safety factor. Okay, so this is for Q slope. One example which I did, but I didn't use Q slope, I used GSI for this. It was from Orissa. You can see the condition of the rock. What was there? Let me tell you the problem. They made a high wall and they want to make it in a bench, they made it very wide. They want to build a thickener there. So it's about 35-meter diameter thickener, so that's why they want to make it high wall. When they made it high wall, you can see how it is. And in that rock, so definitely what type of support is required here, we need to know, because they made it very stiff. And this is in BHQ. So a rock is very competent. I think 280 MPa tha iska strength. It's very, so, but you can see the joints, 3 sets of joints. So what we have done, we have mapped the GSI in that area. So we found this is the vulnerable area, very low. Upar mein thik tha, is side mein bhi thik tha. So this is the area where was the most vulnerable. So we did the numerical modeling with bolting and all this thing. This is our in-house developed software. So with this, we found out what is the safety factor and how the velocity of this slope will happen. So we found out more or less with bolting, it gives safe. So bolt length kitna chahiye, kitna diameter ka chahiye, and bolt kitna load le raha hai, everything we found out and given it to them. And the last is the slope mass rating. It is a modification of RMR system. It's more or less same. You have to calculate basic RMR without the adjustment. Idhar adjustment nahi karenge. It's just basic. And then there are 4 factors. Okay, F1, F2, F3, they will be multiplied plus F4. This is their original version. This is still the same version. So here there are 3 angles we have to know. One is joint, this is the joint deep direction from the north. What is this angle? And this is the slope deep direction, and the slope angle and the joint deep angle.
So these are the angles we need to know. And then they have given the table. There are three things. One is the difference between these two angles. So most vulnerable is both slope and the joint are in the same direction. This is the worst condition, one of the worst conditions. If they are 90 degree to each other, that joint will not do anything to the slope. So if the difference is very small, this is very bad, right? So they gave some table. As you can see, so these are the values they have given. They give A, B, and C based on F1, F2, and F3. So what we say is normally, if the strike direction of the slope and strike direction of the joint, they are within 20 degree, okay, and this joint ka deep angle is less than slope ka deep angle, then it is a vulnerable to failure. Means joint नीचे है, slope ऐसा है, so ये slip करेगा. But if joint angle ज़्यादा है, slope ऐसा है, तो उसका कोई effect नहीं है. Okay, so this is what it is there. You can see here. See, when it become minus, then only you have problem. Okay, so मतलब joint angle नीचे चला गया. So you can see this, recognize this minus 50, same coming from that unfavorable in RMR. So so it's a very, calculation is very simple. Let's say we assume RMS B basic is 50, then this I just assume if you are taking this for these three conditions, and let's say the blasting or mechanical it is 0, F4, then this will give you, if this is 50 and this is minus 17, so it becomes 33. So your SMR is 33, and if it is become 33, what it means? It is coming into this category. So बोल रहा है कि ये very bad, unstable slope, failure will be planar, and probability of failure is 60%. This is what it is saying. Okay, so this is telling about the condition. And then what is the support requirement is there. The drainage करना पड़ेगा, shortcut करना पड़ेगा, like this, because you are in this zone. So इसमें जो zone में आएगा, सब आपको करना है. Okay, so wherever it is cutting here, so you are doing. So this is what is the suggestion from SMR. Okay, so this is pretty much my presentation. So if any further question.
So which one is original one?
No, this is the original one.
I have seen that version also, like where it is minus F1, minus F2, minus F3, something like that also.
No, maybe minus, it depends how you are taking that value.
In direct, in formula itself, it's mentioned minus.
No, this is the original. I have taken from the original paper, the first paper. This is it. So they are positive, and how you are considering it, this is, see, the thing is, अब देखिए इधर alpha j minus alpha s. Here you see it is given alpha j, मतलब joint minus slope. अभी किसी ने slope minus joint किया, then वो negative हो जाएगा. How you are considering that factor? नीचे भी देखिए, joint minus slope. अभी slope minus joint करेंगे तो ये सब negative में लिखना पड़ेगा. So how you are considering that factor? It is. So कोई भी एक follow करने से हो जाएगा, कोई भी एक. Okay. So thank you, sir. So I hope I could convey my thought process. Okay. So now Madam will say something, I'm not sure. You will say something, right?
Thank you, sir. You have clearly explained the evolution of support system for metal mines since 1963 when it was initially started. You have clearly explained the RMR, modified RMR, Q system, then GSI, and the linking of all these three parameters for calculation of supports and effects of various geomining conditions, particularly and geophysical and geomechanical properties in calculating various boundary conditions for your modeling. So as of now, we are not having a standard procedure for calculating our support system for metal mines. Though RMR is in coal mines, which is basically for sedimentary rocks, for metamorphic and igneous rocks, the system which is being used is varying from mine to mine. All these works, which will tailor-made for Indian mining conditions, will definitely benefit our mining fraternity, so that we will have a effective support system and effective support calculation methods in future, so that we will go for safe working conditions in our metal mines. Thank you, one and all.
Thank you, sir. Really, I want to appreciate Dev sir for your valuable contribution. Today's presentation have a reinforced and fundamental message. As Indian metal mining advances to greater depth and increasing the complex geotechnical environment, the precision and reliability of our rock mass characterization will define the safety, productivity and sustainability of our operations. And sir, your paper on the rock mass classification and support design, highlighting not only the historical importance of the RMR and the Q system, but also the evolving need for the more advanced data-driven design approach. His emphasis on integrating empirical analytics and observational methods provide a robust pathway for enhancing support and performance in challenging ground conditions. And sir, for your GSI system, further strengthening their narratives by demonstrating how modern classification frameworks, when applied with technical rigor, can significantly improve the accuracy of stability assessment for hard rock mines and structure. And your examples underscore the values of the geological judgment combined with the structural classification tools. As an industry, SZL and the wider Indian mining community stand at a critical juncture with a digital instrumentation, improved monitoring and advanced modeling now at our disposal. We can move from reactive ground control to a cultural of the productive geotechnical engineering. Thank you, sir. Thank you for your presentation. Thank you.
Thank you, sir. We now pause for lunch break. Please join us and reconvene for the second technical session. And for all those who have not scanned the souvenir earlier, QR code will be displayed on the screen, and those who want, they can just scan the QR code for the souvenir. Thank you all. I think half an hour would be enough for the lunch break, and hope to see you after half an hour in the same hall.
Hello, there is a QR code displayed outside of this hall, and this QR code, through this QR code you can download the e-souvenir.
We are about to start our technical session 2. I request all the guests who are outside this hall to kindly come and take their places. I request everyone to please take their seats for technical session 2 is about to start. Already behind time, I request everyone technical session 2 will be chaired by Shri Vinod Rajak sir. Who is Director DGMS, Northwest Zone Udaipur, and co-chaired by Shri Arnava Ghosh, GM Mining, Hatti Gold Mines Limited. Technical session 2 will be chaired by Shri Vinod Rajak, Director DGMS Northwest Zone Udaipur, and co-chaired by Shri Arnava Ghosh, General Manager Mining, Hatti Gold Mines Limited. So, I request coordinators to please inform Shri Arnava Ghosh, General Manager Mining, Hatti Gold Mines Limited. We trust you had an enjoyable lunch and are delighted to reconvene for technical session 2. This technical session is chaired by Shri Vinod Rajak, Director DGMS Northwest Zone Udaipur, and co-chaired by Shri Arnava Ghosh, General Manager Mining, HGML. For technical session 2, the first speaker I invite is Dr. Islavat Srinivasa Rao. He will be presenting paper on application of GSI system for stability analysis and design of hard rock mine structures. Dr. Islavat Srinivasa Rao. Each session will be given 15 minutes duration, and speakers are requested to kindly stick to the time limit of 15 minutes. Thank you.
Yeah, good afternoon. So this presentation is supplementation of the lecture given by Professor Dev. So where we have done, the most of the case studies where we have applied GSI system for performance of stability analysis and design of hard rock mine structures. So I will try to explain, there are some mines where the sub-level stoping method is used, and then room and pillar method is also used, and I will also try to explain one case study where it's a GIS system is applied for stability analysis of open pit mines. So the case study one, this is basically from Hindustan Copper. It's a Banwas block. So for doing any stability analysis or design of underground structure, we require, GSI system in order to reduce the, intact rock properties for conversion of rock mass properties. And these rock mass properties can be used as an input to the numerical model. So I'll just have a glance so that you can also understand what we do testing in the laboratory. So now you see, so this is the, the UCS testing machine, so where we perform uniaxial compressive strength and other tests. So the first we can estimate the density, so the density can be used to estimate, it's a stress gradient basically, and to estimate your horizontal stress or your vertical stress. So now you see these are the standard tests, how to estimate the tensile strength. So they will prepare the sample as per, the ISRM standard, which is L by D ratio. So these are given, and then we'll try to put it into the equation, and then we'll find, tensile strength. So if you can see the tensile strength, which is varying between, it's a 4 to it's a 5 MPa. So however, your compression will be little higher, so it's a 10 times of, it's a minimum of 10 times of its tensile strength. So these are the, compressive strength tests where we will perform, how we will perform. So we'll just try to keep in between, and then we'll estimate. So now if you see the where you have seen it's a compressive, your tensile strength which is in a 3 to 5 MPa, and you see the compressive strength how it is varying from 117 to 130 MPa for your ore body, and then similarly we estimate for footwall and the hanging wall ore body. So and then one more important parameter which is it's a Young's modulus, as Dev sir said in the morning. So you see from a compressive strength test we will estimate this Young's modulus, this is a slope we will take, and this can also be as a input for reduction of rock mass properties. So you can see, so here you have a value from 34 to 45 GPa for a ore body, and similarly for all other footwall and hanging wall rock, and this has been reduced quite lesser, more or less is a 10 times of lesser than this, and this can be used for playing the numerical model. And now there is a very important parameter, it's a Poisson ratio, so where we just find out from a user's test, and we'll just put the strain gauges and then try to develop the stress versus strain curve, and then we'll have a slope of this thing, and then we'll estimate. This can also be as an input for a numerical model. And you see this is a triaxial compressive strength test, so where we'll prepare sample, and for a different confinement load, so we'll try to estimate the failure load, and for footwall and then hanging wall and then ore body, and we'll try to plot in a sigma 1 and sigma 3 the plane, and then we'll try to estimate C5 from this test. So this is how the C5 test, this is basically which is intact in nature, so we'll estimate. And the main thing, it's a geological strength index, what Dev sir was telling. So now let's say we have a GSI of this thing, and for this thing it's a Hindustan Copper unit, so we have already given training, and they are so doing the well, the recording is a GSI, and they provide us accordingly. We'll try to take these values, and then minimum to average we generally take, and then do the numerical modeling. So coming to the slope design, you see, so there are the many critical sections where we have taken some boundary where, so now we need to establish the sloping parameters. This is from 1600 meter to 1800, and then 5500 meter to 5700, it's easting and then northing. So now so if you see the where we have played the your Young's modulus, if you see 35 40 GPa in intact in nature, and you see for a minimum GSI value, so it has been converted to 6.4 to the 10 the GPa. So this is what we are using for the numerical model, and then we will play with this, and then it's the most safe manner we will try to have a stability analysis. So So now here, as I said, so considering the minimum GSI and average GSI, I'll try to show you. So now these are your, the plants, our body, how it is varying, and so at different levels, so 180, 240 meter RL, and these are the stoves, how they have planned, and then this exact, the stove, so we have imported in the numerical model. If you see in a 3D, it seems to be like this, and then where actually mining is done accordingly, so we have put it into the numerical model. You see how it's a numerical model is looking like. So now this is your 240 ml, 180, 120, and then it's a 60 ml. So now when you see the 3D, so how your ore body is looking like, so where you have a stove, so these are the stove of level interval is 60 meter and this is 20 meter, and rib pillars it's a 15 meters. So you see, so you have two loads, the load 1 and then load 2, it's behind also. So then we discretize the normal procedure, and then so this is how it's a meshing is done. And now this is very important, the boundary condition. So in the morning also we were discussing the institute stress measurement. So where so this institute measurement, so based on institute measurement is a very important thing, and how we will try to give the institute stresses to the numerical model. This is what, so they have done the testing, the institute stress measurement. From there we got, they have provided this equation. So where Z is the depth of the mining, so we will place this, and then we will try to apply the major principal stress and minor principal stress, and then horizontal stresses basically, and then we run the model. So now if you see, it's a minor principal stress, so the positive in nature, it says it's a tension. You see all the corner and then sides are getting in a tension, and this, in most of the cases it's a roof, your crown pillar roof is also getting in tension. So now, so this is the major principal stresses. So now you see it is varying between it's a 15 to the 34 MPa. So it's a major principal stress. So now if you see, sometimes you may have a ore body, this is the ore body, and here also you have excavation. When you cut it, there is inside there is an intact rock. So where the parting is there, this is still it's a strong in nature, so which will also hold because of the the mining. So now if you see this safety factor, you see how safety factor is varying. You see this is the contour, and now your distribution, you see this is how the sites anyway it is going to fail. So this is how safety factor is changing from 2.5 to, so you can see how it is changing. So this is for the one level, this is top level 180, and then 120, and then 60. So based on this analysis, as Dev sir said, so they have a maximum as a 5 meter drive, and then assuming the ESR, it's a 1.6, and we got the Q, it's around 3 point something, and this is what the spacing of support. So we generally give to the various mining companies basically. So now what mining company wants basically, so you see they want it's a maximum extraction length also, okay. So we can play with removing some of the pillars and the crown pillars. So here you have a crown pillars and the rib pillars, and then we'll see how safety factor is changing, and finally so we can give some the suggestions. So you see how the crown pillar here is mined, and then rib pillar remained, and backside also mined. So here we have established it's a 55 meters wide, and then height of it's a 120 meter, the span we have given. So case study 2, so if you see this is the case study of UCL, it's a Tumalapalli mine, so where they were doing the room and pillar method. So you can see these are all our pillars, and these are the long standing pillar. They have a problem, so here most of the deposits they have completed in the one side, north side, and the other side they have to go, so they have to pass all the way through these standing pillars. These are the long standing drives. So now this is the vertical section you can see, and then so these are the plan view of your how the rooms and then the pillars are looking like. So this is how it's a institute model is developed, and then whatever geometry we have, so it has been developed here, and then you can see how your ore body is filled. So they have a two condition, they are also doing it's a partially filling for a 2.2 meter, and they have a height of mining, it's a footwall overbody they are mining, so 3 meter, and then they have a parting about 2 meter. On the above, they are also trying to extract 2 meter in the hang wall side. So they have a, the sloping part they are performing is a 6x4, and we saw for a 8x4 also whether it is suitable or not, and then so we did the analysis. So you can see this is a 3D mesh similar to your earlier case. So this, we also gave the good training to UCL Tumbalapalli, so they are also the recording it's a GSI. So with this GSI we have converted the rock mass properties, and they have been used in the numerical model. So now you see how your safety factor is a hanging wall, the pillar, and then footwall overbody pillar, how it is changing. This is the contour. So this is for a 8x4 meter. So and then we saw, so for different, the GSI, varying the different GSI, how, the fracture extends in the slopes. So you can see for a 8x4 no filling condition, you have in the corners how it is failing, extending the failing. So this is the long standing drives basically, okay. So for a 6x4 in a filling condition, in the inside the slope pillar, so your plastic strain has been reduced. However, so in a long standing pillar it's almost remains same. So the for 8x4, the meters sloping pattern, this also we have seen. So for a filling condition also we have seen, and based on this we have developed, the slope stability charts can be developed. Maybe you can see for a critical, the cumulative equivalent plastic strain. So where this cross says no filling, and then this says the filling. So when it's a support is required, when it is not required, and how it can go in a unstable condition. This also we have developed. So this is for a long standing pillars. For a case study 3, so you see this is the case study of the Balasur Allies Company Limited from the eastern part of India. So you can see where you have a ore body of 290 meter and width is 20 and then 200 meters. So they wanted to go by the sub-level sloping method and to have a decline, and then your vertical shaft, what should be the distance and what should be the the lining thickness of your the shaft. It has to be decided. This is how the slopes are developed. And you can see here when you take the cross section where you can see there is a decline, and how decline is being affected by sloping operation where you perform. This is zoom view, and here also there is a shaft, and how so it is being affected. So based on fracture extension here, and then we have tried to the estimate the concrete strengths which can be used for a this shaft. So assuming the safety factor it's a 1.5 and the lining thickness 0.3 meter, so we have suggested from 29 to it's a 46 MPa. So coming to the case study 4, so you see to optimization of your slopes basically. So how GSI changes the sloping sizes, and then rib pillar sizes and crown pillar I will try to show. So this is also it's from a Colihan mine. So so you see, so this is how we change the 40 to 60, and then I will try to show you. So you can see clearly here with the increasement of your GSI, certainly the strength increases, and this is the contour you can see. So these are the rib pillars where we have studied. So this color it seems to be it's a 3 to it's a 3.5. As you are increasing GSI it's a 50, you see how the core of your rib pillar is changing, increasing its safety factor. You can see from here and here you see how it is all the way going above 5 here, okay. So so that is with the increment of GSI. Now if you increase your slope width from 20 to 30 meter, how your safety factor of your rib pillar is reducing, you can see in the crown pillar also, so it can be clearly visible, okay. So now you can see here for a now sloping width, it's a slope width 20 meter, GSI 40. If you increase the rib pillar size, so how your safety factor improves, you can see here. So about the 3, and now you can see the extent of your safety factor so has a value of the 3 is increasing. So here also it is increasing, here also it is increasing. So coming to the case study 5, so this is basically for a open cast mine. So where we also recorded GSI. So this is how we have recorded This is the condition of the open cast mine. This is also from a eastern part of India. So, so here, so we have played with 45 to 55 GSI and then saw how your safety factor is changing. You can see from a GSI 40 and you have a 2.7 safety factor, 2.75 and you can 2.76. This is the limit equilibrium method is adapted here. So now if you see sometime when two mines adjacent you have and then when they reach the extreme the ultimate pit, sometime they can also have a excavation at the boundary. So how we are going to design the boundary pillar, this is also very important thing. So you see as per MMR we can keep the 15 meter on the top. So now you see this is how the ultimate pit is designed for this, and let us see how with the increment of GSI how it is changing the slope. You see, so in the left side it's a mine A, you have a 2.5 for a GSI 40 and this side also it's a 2.51. And now so increment of GSI again your safety factor is increasing, here also it is increasing. So for a 60 you can see it is increasing 2.67 and it's a 2.675. So this is how the GSI plays a vital role in designing the the hard rock mine structure. So I would say, so in all our analysis, and if you want to publish any papers throughout internationally also, so we are using the GSI. So the GSI can be one of the important classification system for reducing the rock mass properties and to use as an input to the numerical model. Thank you. Yeah, if you have any question, then.
Dr. Rao, your paper, thank you for a good presentation. And this basically what I understand that it concentrates on stope design of stoping parameters like pillar dimension and stope dimension, all these things. So as per your observation, what you have observed, like when you have design means जैसे री पिलर का dimension क्या होगा, stope dimension क्या होगा, and based upon that what will be the rock behavior. So as per your study and as per after implementation of that thing, that design in the field, what kind of variation do you observe in rock behavior after this मतलब जो आपका design है उसको implement करने के बाद?
So, sir, if you see, we have varied GSI from 40 to 50 in some cases. Even if you see in a Hindustan Copper Banwas, if you see, we have seen, GSI of, they have recorded GSI of the hang wall and footwall and at different level. And then we have incorporated this. So it's not just as taking a single value for a host rock and taking its ore body is a single value for a the entire from 240 to all the way 60 ml. So we are recording all the values at different location, and we are trying to take the minimum, we are trying to take the average, and then we are trying to suggest the optimum stoping dimensions, like what should be the crown pillar, what should the stope width, what should be the rib pillar in between. So here in if you see it's in Banwas, so see they are also removing the crown pillar in between two levels. So we have given a maximum span. So about there is a one stope and one pillar, rib pillar can be mined, and then again stope. So the horizontally along the strike, if you see 55 meter wide and then vertically 120 meter size. So this is with this condition, our numerical modeling says it's stable, and then they are also practicing last few years, so without any problem.
Precisely what I wanted to mean that maybe after as per your design there would be certain kind of stress and certain kind of deformation to the surrounding rock mass after stopping operation. So when you monitoring जो propose करते हो,
sir?
Monitoring of rock, rock behavior.
Yeah.
So as per that, how far that results correlate with?
See, we are also involved in monitoring of Hindustan Copper as well as UCL in other mines also. See, this is not the whatever stress which is coming. Even monitoring, it's not a after, the induced stress only we are trying to monitor basically. Induced one. So it's not a in situ thing basically. And from the, the monitoring data also, we did not find any, abnormal increment of stresses and numerical analysis. And so this, the optimum sequence is very good, it's a fine, and they are working properly.
Rao sir, so what was the minimum width of the rib pillar? You have
so here it's a
given
15.
Was it was the thickness of the rib pillar different for different levels?
Here, whatever the 3 levels we have simulated. So in general, in the pillars above and then it's a below pillar also should be continue. So and yeah, so it's a and then so the whatever we felt from this analysis, probably maybe if you go beyond the 0 meter RL also. So 0 meter RL also at that level also we are doing the stability analysis, but there also it find it's 15 meters found to be safe. So even probably even if you go it's a little deeper and maybe stress changes, and probably there may be a chances of increment of the size of a rib pillar.
So you have seen in last your slide, you have seen that you have shown one presentation regarding slope angle of 25 degree.
Yes.
So both are saying very stable.
So this is about the 25 degrees.
Factor of safety 2, almost 2. What could have been the slope angle? More than 25 degrees, to which angle we can go?
Now you are saying overall slope angle or bench angle?
No, overall slope angle.
See, this is
both. Here you have said bench angle.
No. This is overall bench angle is 80 degree, and then overall slope angle we found it's a 25 degrees. Yes.
So it is showing almost 2.5 and 3.
Yeah. So 2.59.
So if you bring down, how much up to how much extent we can go?
Yeah, we can simulate it. This entire profile we can try to just fix it up. It's a change, and this side also a little bit steeper, and then we have to simulate again,
so
and to have a 1.5 is a safety factor.
For 2.5. I'm asking for 2, factor of 2. Has it been simulated?
No, for high wall slopes, this long standing, you can say it's the benches. Okay. So we have a criteria, it's a 1.5. So we can furtherly see here to show, these things. So I have done it. So we can little bit steeper and then see. So the how safety factor is changing when the certain profile is matching to the 1.5. That can be optimum, the profile.
Okay. Thank you, Mr. Rao.
Dr. Rao, one more question. How in your design, how you are considering the effect of blasting?
Effect of blasting, you are saying? Now, if you remember in the morning session, Dev sir said there is a D. Okay, so disturbance factor. So we have given it's about more than 0.5, it's a disturbance factor, and then converted this all the values. So all these values, the C5, whatever we got, and then ECM and sigma CM we got based on the blasting parameter, which is a disturbance parameter. So always we have to take, let's say, instead of this, if you are using some cutting machines, so where you do not have any disturbance due to the excavation process, so there you can take it's a D equals to 0. But wherever it's a drilling and blasting practice is being done, so we have to have a disturbance factor. So all these properties came from a disturbance factor.
Anything, and there was one recommendation of National Conference on Safety in Mines that to devise some system that which can identify or detect any hidden geological discontinuities or slips or cracks inside the in situ rock. So has there been any development in that field?
We are trying, under the guidance of Dev sir, we are trying to send, the one proposal to Minister of, the Mines and then Minister of Coal to see how best it can go. So there are, some, techniques available, the outside the country, So we are trying to build in-house. So that's what we are trying to do.
Thank you, Dr. Srinivas Rao. Thank you for
Thank
your
you.
good presentation and case studies.
Next presentation is by Shri Ayan Giri, Head Technical Services AGM, and Shri Binayak Banerjee, Head of Department Geotechnology, Rampura Gucha Mines, Messrs. Hindustan Zinc Limited. They will be presenting paper on a systematic methodology for ground support design in underground metal mines.
So good afternoon, everyone. Myself, Ayan Giri. I am with Hindustan Zinc for last 12 years, and I am currently looking after technical services at Kayad Mines, and I am with Binayak Banerjee.
Good afternoon, all honorable dignitaries and all mining professionals. I am Binayak Banerjee, Head of Geotechnical Department, Rampura Gucha Mine of Hindustan Zinc Limited.
So both of us will be presenting on ground support methodology for underground metal mines. I understand it is very difficult for everyone to stay active after lunch session, so please be attentive. So this introduction is mostly on underground excavations require ground support to ensure that our workers are safe in underground, and hard rock mines often experience stresses, fractures and dynamic events, which we will be covering. And we will be also covering a systematic support design methodology that improves the stability of the mine. And our major objective is to control rock deformation, prevent collapses and rock falls, maintain excavation shape and function, manage dynamic load, seismicity as well as blasting, and ensure a cost-effective and much more reliable support.
Basically, in this presentation, what we are actually trying to showcase here, the simple methodology which actually we are using in Hindustan Zinc Limited, all the mines. Basically, it is just a flow chart of what we should be doing once we have the data from the underground or surface, even whatever the superficial features we have through various system in place, the rock mass characterization, what we follow. Basically, we follow the Q system, and how to use that for the support designing purpose that we have gone through in this presentation.
So basically the factors and process overview outlines the geological factors that we'll be covering. That is the rock type, the joints, faults that data will be capturing, and the geotechnical conditions where we consider the Q, GSI and RMR values in our designs. Mining methods, mostly we go for sublevel open stoping, and excavation geometries that will be considered that will determine the support with the span, shape and the depth, and operational factors like what sort of equipments goes in the drive and what are the major damage potential that can happen. And for the design support process, the flow is like rock mass characterization, then stress analysis, then we go for excavation geometry assessment, design of support system, then very important is the verification and implementation and monitoring and review and optimization. So this is a broad overview of how we are collecting the data from underground. So this is a spreadsheet that demonstrates what sort of data we are collecting, like RQD and JN, JR, JA, JW, SRF. So we use this spreadsheet and we have categorized it as per our mind, majority of the domains that we find, so that the people who go there and collect the data, they can collect it very easily. And then we convert it to RMR or GSI with the formulas that was discussed in the morning. And this is also a demonstration of a plan that you can see here. So apart from calculating the RMR or GSI, we also take information of the joint, the dip and the structures, because they play a major role when we are designing the stope or where the excavation comes in place. So that is also very important and an integral part of the overall mine design.
Basically, another thing to look about in this slide is what we mainly do is we divide our complete development areas into separate geotechnical domains. These domains are basically, each domain has got its own characteristics. Doesn't matter whether those are of same rock types or same joint planes, but they will have the same Q values or the same RMR values. Based on that, those domains will, that particular domain will have a separate kind of support. So that's what we generally do with the help of these rock mass classifications.
So you can see it here, how we make the domains. So these are some of the examples of what sort of measurements are being taken and how the drive actually looks like. So this is an example of one of the legacy developments in Jaipur, and you can see the quality of ground, and hardly any supports are required in this ground. And because these grounds are a testament of time, they have been like this for more than 40-50 years, and they hardly have any deformation or change. So this is also a blocky ground, and its RMR is calculated as 70 and Q in 15. And you can also see only systematic support being placed, no skin support and anything. This is a weak foliated rock where it's in a very low stress zone because it's a very lesser depth excavation, and you can see the RMR is 40 and Q is 0.9. So this is a different sort of an excavation where it's a blocky rock mass, high stress regime, and the RMR is poor to fair 40 and the Q is 0.8. And we have not yet reached into any of our developments in this sort of ground condition, but this is taken from one of the mines in Canada, just to depict how the ground condition looks like and what sort of supports are being taken in deeper and very high stressed ground condition. And you can see how the supports have squeezed inside the ground. So if we talk of the practical limitations of the rock mass classifications that we have felt when we go and collect the data in underground is mostly like RMR and Q both are, lot of the values that we collect is very much subjective. It depends on the person who is actually collecting the data. That is one issue. Second is Q does not have a directional, like in the morning we were discussing, when we collect Q for a different drive dimension, whether or not it is perpendicular to the foliation or parallel to it, it basically discounts it, which is a major parameter when you actually go and design the support. So that is an area practicing geotechnical engineers need to look into, so that they do not under design a support just where the Q or the rock mass values are very good. I think Vinayak will take it further.
So basically here, this is empirical design methods. There are three methods actually which we follow. First one is the empirical method, second one is the kinematic method, and last and foremost is the numerical method. So as you can see from here, as you can see from here, the Q system support charts already we discussed in our first session, the GSI, the RMR, these are all part of the empirical design. Now what we know about the kinematic block analysis or the wedge plane failures, generally this is the main data which we procure from the field, and we use that data with the help of some softwares. For us, we use the rock science softwares, the Unwedge or the DIPS or the Rock Lab or the RS2, RS3. These softwares we use and we find out what are the major planes which can be harmful for those particular excavations or particular design in that design which should be considered. So that comes up from the kinematic analysis. And finally comes up the finite element or the finite difference modeling. Here in this, generally we evaluate the stress distribution, predict the deformation, optimize our support spacing and length. Actually what we try to find out is what we should be doing in a state where the rock is demanding such support. So basically we design that, and once we implement it, that also, that doesn't end there, because as you can see, the modern design actually typically integrates both validated by field observations and monitoring. So once we have our observations from the field, again we have to redesign or reevaluate our design and see which is the best case scenario. This is the stress analysis which we do. Basically, there are multiple softwares, FLAC 3D, RS2, MAP 3D, some are finite element, some are finite difference methods, some are boundary element methods. And what do we do with those is basically identify the potential failures modes, whether it is slabbing or spalling, buckling, shear failures, or stress-driven rock burst scenarios. Means generally it is in deeper underground environments where we have got the rock burst issues. And most important in this is the excavation geometry and the stability, because it is basically impacted by the span, which we were also discussing, that what is the width of the excavation, what shape it is, because generally we try to give it a arch shape so that it can have lesser stresses around it and avoid square shaped patterns. Then influence of orientation relative to joint sets, whether they are parallel to them, whether they are perpendicular to them, the probabilistic methods for failure potential, and finally the empirical charts for stand-up time. So this we have already discussed. This is the empirical methods. This chart is the empirical methods. And let's go to this kinematic analysis which I was talking about. This one has been done in the dips. Once we have all the geological structures mapped out in underground or in surface, what we do, we actually put it into a software, the dips, and then we find out which are the critical joint sets which are affecting the stability. And once we have those three sets, we actually give it inside the another software which is the Unwedge. That gives us the potential wedge where what should be immediately supported or what is the best case scenario if we will be supporting. As you can see here, not only the rock bolts, the blue colored ones are the rock bolts, the red colored ones are the cable bolts. So somewhere the cable bolts or the long strands are important. So where it needs to be done, that is taken care of by this software. And finally, the numerical analysis or the numerical modeling. This is just a short example that with support or without support, how the factor of safety changes. So this is just to explain how it helps us to give us an idea that if we put a particular spacing rock bolts or cable bolts, how that will act or how that will help to stabilize the excavation. And on the right side is basically, since we have been doing open stoping in almost all our mines with backfill as paste. So this is a Matthew stability empirical approach also, but it is for the stope stability, how we can see in an earlier stage that whether a stope span is stable or not. So that is basically the stability index on the y-axis, and the x-axis is the hydraulic radius. So hydraulic radius is basically the area upon perimeter of that span which needs to be opened up, and the stability index is basically the product of the stability, the Q value, and three more factors A, B, C. Those A factor is the stress factor, B factor is the joint orientation factor, and the C factor is the gravity factor. So all these actually comes into play, that where my stope, maybe the crown or the roof or the side walls, where does it lie? Whether it's a potential caving zone, an unstable zone, or a stable zone. So this is one of the calculations here we have shown. Basically excavation size 5.6 by 5.3. This is RQD value 47 with J and JR values. So Q, basically this is, we have calculated through the empirical methods that what is the Q of the roof or the Q of the wall. And as in the first session we saw that excavation support ratio 1.6 for the permanent mine openings. So this is what we have calculated, and we have the design parameters in place that generally this is done for anything that is, if it's the Q prime range is greater than 5. So we have, as I told earlier, that we actually divide our complete development areas into different domains. So this is one of the domain. So the Q, if ranges from 5 to 10 or below 5 or more than 10, then obviously the support design will change. And the factor of safety, we always keep 1.6 constant, and based on it, we have calculated what's the maximum stable unsupported span for the roof, for the wall, what is required support capacity, and what type of bolt we need to do, maybe resin bolts, friction bolts, or cable bolts. So as you can see, with the help of resin bolts, and we also use welded wire mesh because of our squeezing rock conditions, we have a Q value which is from about 0.124 in between they lie, and RMR is about 50 to 55. So that's why we had to use welded wire mesh along with short kit. So as you can see, the final factor of safety which we work on is 2.5. This is just an example for this kind of design or this kind of assessment we do for each and every development we have in our mines.
On top of this, all the formulas that are being used, we saw in the morning presentation only. So yes, no additional formula or anything is used in here.
These are all
so these are just spreadsheets that we make so that we make our work very easy for day-to-day work.
These are all derived from Barton's Q. This Barton's Q parameter, it has been derived, and he has only given this kind of support capacity formulas or the unsupported span formulas, and we just use them. This is just the first step. The second and third, as I shown earlier, the kinematic and the numerical analysis. And then coming back to our design, whether this design is up to the mark, whether this is relevant to what we have designed or it needs to be changed. It's a continuous evolving procedure. So this is the support design principles in here. Basically, this is what we want to look for is the rock mass cohesion and the interlocking properties. Reinforce the key blocks which are about to dislodge. Control the deformation, because ultimately gravity failure is bound to happen, but how well we can delay it, that is what we are looking for, so that our manpower, our machinery, everything becomes safe. And somewhere in dynamic areas also, we will come to that some dynamic supports, we have just one slide on it, that deeper mines where we require dynamic support, because somewhere, for in our case, in Rampura Agucha especially, we have squeezing ground conditions, and our rock mass is hardly, rock input parameters, intact parameters is 45 MPa, so rock mass is pretty weak. So in that, maybe as we go deeper, we may have to in future, not now, maybe in next 200-meter deep levels, we have to start using dynamic support. So that also will come to it. In general, what we have is the surface support, the mesh, welded wire mesh, the short kits. As reinforcements, we have rock bolts, split sets, and cable bolts. And these are retaining confined support, but these are generally the old, in the old ways we used to make this steel sets or timber sets, but now they have not been in use. Now coming to the QA/QC and the challenges part, most important is the QA/QC part, because the quality of the support which we are designing or which we are implementing on the field, that needs to be regularly checked, regularly monitored. And if there is anything which needs to be changed, it has to be implemented through the design part. So that's why this quality control or the monitoring measures, first the pull tests of the bolts, that's a very important. The bolt capacity which we are having, which we have designed for, whether it is actually we are having that in the roof or not. Second, I
want to make a point on the pull test. I think all the mines who are using rock bolts, they do a pull test. But what we miss is when we are using a hydraulic pump and there is a piston below which the rock is being tensioned, so we hardly miss that it should open only 2 inches, beyond which whatever results we get is not the right result that needs to be recorded. So the team who are actually doing the pull test should be also cautious, because nowadays all the mines are doing resin grouted bolts. So it's a thing that we always record the resin grouted bolts, it will take 20 tons, 25 tons. So we test up to 15, 20 tons. And sometimes we get false results. So that is an area that we need to be very careful on.
Quality area. Yes, basically convergence monitoring, instrumentation obviously is very important. The stress cells, the extensometers, or we have now leader scanning also available. We can scan our drives from time to time and see what is the deformation potential of those areas. So basically, what is the last point is very important, is continuous feedback loop for optimization. The more we have the monitoring data in place, the more we re-evaluate our design, the more we can help to make it more successful, make it more safer mine for all our workers. Now coming to the challenges in support design, basically the depth-induced high stresses, because we never talk about the mining-induced stresses. Once we have multiple excavations, what we have actually designed, but that design doesn't take into account all the excavations or what we are planning in near future. Every time we make an excavation, the mining-induced stresses keeps on changing. That needs to be accounted for, and that needs to be evolved with time. Now, second thing is seismicity. This is also continuation of the rock burst areas, which basically if any mine gets deeper, seismic events can occur because of the modulus difference between rocks. And water inflow is very important, because it actually, the inherent properties of the rock gets reduced, the equipment constraints, and finally the cost versus the safety optimization.
So this presentation, we want to summarize that effective support design is a systematic and a data-driven approach, and which combines empirical, analytical, and the numerical tools. And we should not rely on only empirical methods of designing the support.
Very fast. Time has already.
Yes, sir. So we should consider numerical analysis on top of it, and the support design needs to be re-evaluated every year. Like we are also in, we have our GCMP audits that happen annually and which are done by SIMFR and all. And that's it. I think we have already discussed on the dynamic ground support designs, which needs to be of major focus. So thank you everyone.
Thank you.
The bottom line that we want to say is, whenever we drive a car, we say that it is always the driver, not the car. And even when we are even doing the design or collecting data for geotechnical evaluation, it is the person who collects the data that should be given the highest priority, and they should be trained very well, so that whatever data is collected for the further designs has sanctity and is very well preserved and very well documented. Thank you.
Any questions?
Thank you for very good presentation. It is complete methodology for implementation of what we have read in first session into application for ground rock supporting for underground mines. Very good presentation. Thank you.
Thank you, sir.
Yes, please, sir. No, sir. Means those are the methods for which these queue systems, means all the parameters are being used, but we are only doing sub-level stoping. Cut and fill we used to do long back at RD mines, but now it is not in process. Maximum level is almost 1 kilometer for RA, and rest of the mines are almost in the range of 600 to 700 meters.
Are you facing any incidences of maybe rock burst or something, or incidents of?
Sir, as of now, rock burst events has not yet occurred at one of our mines, means majority of our mines. But we find some of the areas where rock noises are prevalent, where we have quartz dissemination in the ground. So there are some cracking sounds, but that is not continuously for all development areas.
Yes, this is what we need to be ready in the future, because now the mines are at about 1 kilometer depth, so it is likely to be at 1.5 kilometer. So in the next 100 to 200 meters, maybe this will increase. So we have to think of in the design part that how to implement those dynamic supports.
And the third question that I have is about your pull test. Okay, everywhere they are doing pull test. What is the interval at which you are doing the pull test? And are you coming back to the same place after maybe a month or so, and again doing some more tests there to ensure if you're really that resin is of good quality or not? Because there are a lot of incidences where the same resin has failed after maybe after a month or so because of drippage of water and inclusion of chlorine in the resin.
Sir, we follow the same 10% of the pull-out test from the whole lot, 9% of non-destructive and 1% destructive. Some of the areas we do come back and check, but that is on a campaign basis. Now, that is, we do not have a percentage of how many of the percentages we do. That is on over and above that percentage. We come back some area where we are reopening a drive. We want to check whether the bolts are stable or not. Yes, we come back and check. And apart from that, where we have cable bolts installed, we have also started the practice of doing pull tests of cable bolts.
We have got plated cable bolts also in our mines, so those are also pull tested to see what is the capacity.
Thank you, sir.
Thank you.
Thank you all.
Next paper presentation is by Dr. Ajay Kumar Nethani, who is HOD Engineering Geology Department, National Institute of Rock Mechanics. He will be presenting on rock mass classification and support design using queue system.
So good afternoon one and all, respected chairman and co-chair. Actually this is the title of my paper is the rock mass classification and support system using queue. But this already covered by the Professor Dev. I was not knowing that he is covering this thing, and he has covered almost all the classification except I system, which is emerging in the civil field actually. And the RMR or the Q or the GSI, all are having the different applications. And the Q slope also very good, already covered, and the SMR also. So I would like to, I will not repeat whatever Professor Dev has said, but some points and some this thing, my previous presenters also have some doubts, I think. There are more doubts actually on the Q. And what I am telling that we are the vegetarian or non-vegetarian. In between vegetarian and non-vegetarian, vegetarian is also there. So when we are following one system, kindly focus on that one. Go in very deep. After the completion of the 3 decades in this field, rock mechanics and rock engineering, I am just like feeling a student only. So deep it is. If I will ask to my previous presenter whether anywhere it is written in the Q that go for the wire mesh as a support system, I think it is nowhere it is written. When it was first introduced in 1974, that was there because that time SFRS was not there. So like that only Swellex bolt, because they have presented that the rock bolt, 3 type of the rock bolts, Swellex bolts, whether it is come under that category. So what my request, because the target was given to me from the IIT Kharagpur and from the Jaipur, that whether this classification Q system can be used for the metallic hard rock mines. So of course, this thing already covered by the Professor Dev, that how this classification actually empirical, name is very small, but if you go through that one, the long contribution for evaluation of the, when we are making a thesis, we are also making a new equation so that my PhD can be cleared. The aim is not to contribute for the society. The aim is to pass my PhD so that I will make a new equation, and that will be the first use and last use of that equation. But you will go with that one, the empirical equations proposed by the Vanue is no more. I think all of us know that one. And the GSI is the very important. 2 papers are presented on the GSI. And whenever we talk about the modeling, the GSI, because the rock mass parameter will get from the GSI only. Of course, about hook is also no more. And only the person and the organization in the world, which is there, this is the NGI, Norwegian Geotechnical Institute, who are 24/7. And the Barton, last week only Barton visited India, New Delhi. They are round the clock, they are working on the Q system. And the Q slope is not a very old, less than 10-year-old. That is the new baby, where we have to develop more and more examples. The question is, from the beginning, it was asked to the Professor Dev also, whether we have, the one parameter is missing in the Q, it is not required actually, joint orientation. It is not required at all. And the kinematic analysis is the part of the investigation. It is not a separate sort of this thing. The kinematic, whenever we are talking about the investigation, at the every 5 meter interval, we have to collect the data, means every 5 meter, the kinematic analysis has to be conducted. So that you should not differentiate, that it is not at par with the empirical equations or the numerical modeling should be always for the validation. Once you are getting this thing, that from my, whatever is proposed using the RM or the Q, if you go for the validation, and suppose for the mining factor of safety 1.6 is required, your part is over. So quickly I'll go because time is very less. So this already covered lot of the changes in the made in the RMR only. In India also, Professor Ghosh and our former director, Dr. Venkat Chorlu, this history already Professor Dev told you that how this classification actually evolved, Q system. And now we have a lot of the example from the all the rock masses, as well as from the lot of the example they have collected from the India also. And the philosophy actually, why I'm telling, because the Norwegian Geotechnical Institute, and that because that organization, we have a collaboration for the training and other research point of the view also. So this RRS, again in the morning it was touched by the Professor Dev, this RRS is the substitute of the lattice girder or the steel rib. And it's still, this is, again, this is not a new sort of the system purpose. But still the lot of the working is going on, and still this empirical equation is not developed, and they are working on the observational method only. And whenever we talk about the observation, underground excavation is going to this is the methodology known as the NMT, Norwegian method of tunneling. Another is the NATM. So NATM is nothing but a observational methodology. So this I am not going to cover in detail. Morning it is covered, this how RQD, how this thing from the core we are characterizing the rock mass, what are the joint set. Only this part Professor Dev has not covered, so I will cover these things, sir. When it is a portal, this we have to multiply by 2, and the intersection we have to multiply by, on your right it is an intersection, and on your left it is a portal. So simply this thing, because when we multiply, automatically the value of the Q will go down. This all details were covered in the morning session, that how this is a very important parameter. This is the strength parameter of the out of the 6 parameter. Again, it is on the right, the photographs are shown, but this thing regarding that how the filling and the fresh rock you can differentiate, and this is the JW, how you can get this thing on your photo. If you see that how the ingress of the water, how this water can be treated, and this how you value actually, how the value can be assigned in the detail. It is freely available in the morning. I think many the slides and Professor Dev's slides are very much similar, because it is freely available in the NGI, in the normal website, this document. So this is actually the problem the people are facing in this parameter. Again, JW is not a big issue that can be, this parameter again you can take, JW parameter can be taken from our Vanue classification, RMR classification. If you go, beautifully it is given regarding the groundwater condition. So for the Q value, when this JW is required, kindly refer that one, and same value you can refer for the calculation of the Q. So this is actually this 4 category in the morning. Again in detail it is discussed. Only the problem, actually swelling, you know the swelling condition where we are going to get a swell, where we are having the stress condition, high stress condition, we know that one. And the another condition is we have the intersection of by the shear zones. Then only one condition is the competent rock. So whether the competent rock, whether it is low stress, 2.5, normal stress, in civil project actually, we fix our underground cavity in the medium stress condition, because that choice we are having, which in the mining sector we are not having. So we are looking for the one, means medium stress condition, and morning again it is discussed how to know the stress condition. Suppose this sort of the big structure mining area we are doing, at least one hydrofrac test should be conducted up to your desired depth. Suppose your desired depth is 2 kilometers, say. So you try to go for that one, the in situ fracture test. So you will get that what is there, because this again, this whatever we will get for the kinematic analysis, same thing should be validated through the hydrofrac test also. Otherwise, you have to repeat that exercise. So this kinematic analysis, because it is very important, this kinematic analysis of the joint. So you know that the strikes, perpendicular to the strikes are your very favorable condition, means no question of any failure, no question of any failure. So this is again discussed, only this here in this slide, what is important to the executing engineer and the mining engineer, you download this thing, because on your right, if you see, you should know the zone of the influence. How much area, suppose this tunnel is intersecting by the shear zone, then how much area has to be protected? So very clearly it is defined in this one. The detail are given here, and it is detailed are given in the drawings also. So that area of the influence, we cannot focus on that particular area. It is very simple. Suppose my intersection is there, that angle is given, and this width is known. So from here, that much of the width, and from here it is inclined that much of the depth, that will be my area of the influence. So that much of the area has to be supported with the same support system. So this is the example actually. Support this type of the where I can indicator will be there. Okay. Suppose we can see this thing half pipe area, no question of any support system, no question. And suppose we are getting this is the example of our Telangana area. You see very competent rock, but it's the high stress problem. And here again the slabbing problem. So again you see this cover in the Telangana, when we are making the tunnel, cover is very less. But that area, the southern peninsular area, is having the problem of the paleo stresses. The top layer is removed, but stresses are still preserved there. And whenever we are making a cavity, that will be in the form of this form. You can see here this. Sorry. You see, all the rock bolts are hanging, and the cover is height of the cover is less than 40 meters. But again, the stress problem will be there. So this is again the problem. In the high stress condition, suppose my rock is not very competent and the value is less than 1, Q value is less than 1, is strictly for the underground excavation, we are following Q only. More than 1,000 kilometer tunneling I have done, and more than 55 big size cavern, I will show you some examples, we have done using the Q system only. Right? So this is the very good way where we can use this thing. You see, this problem will be there. So you see the cavity, size of the cavity, you see on here, the size of the cavity, when we started the tunneling, the slope, some movement was there. Ribs were erected, but again some movement, then slowly it started falling, and again it has gone up to the top ground, and the size of the cavity was more than 25 meters, and the depth was 47 meters. So this type of the problem will be there. Anywhere we will get a problem, but yes, this problem can be again explained actually. When we are making any underground structure in the valley side, we should be very cautious actually, because the stresses will be in the different form. The valley side effect will always be there. So that parameter has to be seen into detail, and this is actually again to my new engineers, this one, we have one beautiful BIS code on the Q, and that one it is defined. Suppose my Q value is for the roof of the very nice that my previous speaker told. Now they are following the arched roof only. Q is based on arch only, no question of flat roof. So from basic to end we have to follow. So if it is an arch, your roof is arch, then side, how much the pressure will come, it is given in that code. And it is accepted by the NGI also. And it is, of course, it is Bhavani Singh. I think all of us know that great Professor Bhavani Singh, late Professor Bhavani Singh. So this Q value as per the Q, how suppose Q is more than 10, then the factor has to be Q factor for the wall has to be multiplied by 5. If it is from 0.1 to 10, by 2.5. It is less than 1, the same value for the Q. Means whatever my support for the roof will be there, it cannot be for the wall. Wall will be much, much less as per the Q value. So the roof automatically, what the progress means, again it will affect your stand of time also. So without giving support, you can take your, in our civil, we talk it as the pull. Means next blast you can take. You can extract your mineral without compromising with your safety. So this is the typical actually how to treat the shear zone. Shear zone, how we have to treat the shear zone means
treatment of the shear zone means first we should know the value of the Q of that shear zone. So this empirical equation is given. So if one can go with this thing, then exactly we'll come to know. And again, it depends on the angle of this shear zone. At what angle this shear zone is intersecting my excavation. That is with relation to that one, then exactly you will come to know this thing. And in the morning, actually, it is discussed by Professor Dev that one of the beauty of this Q system is that we'll come to know that is the P roof, how much pressure on the roof and how much pressure on the wall is coming. And again, these correction factors, F prime and F double prime is also there. But F double prime is generally we are not taking into the consideration, but F prime and F and F prime, these factors are taken into the consideration, and these are the factor is very important. This is with respect to the height. F and F prime is with respect to the my convergence. So deformation. So these two parameters, again this F and F prime proposed by the Indians only, Professor Bhavani Singh and Dr. Goyal. And this is accepted by NGI, and they have incorporated this thing. Yes, these two factors can be taken into the consideration. Only I'll cautious you, when you use this class, this is what is the difference actually? Here in the second classification in the morning, this equation was shown by the Professor Dev. In next is the JN has come into the picture. But when the joint set number less than 3, and actually when this joint set number will be changed, it will be more, then it will have a negative effect on that one. That's why we are giving the importance to this thing only, this equation only, this for the wall and for the roof. So this F factor we can get it, because it is simple, it is very simple. How this thing, it is simple, next it will come. This is the F factor we can get. Only what is required, my H is required. H is the cover above this thing. If you will get it, then exact P roof you will get it. So that is the first beauty of the Q system, that how much pressure is coming. And ultimately, one code is there in the BIS where you can check you can have validation of your support system. You can check. Suppose you are putting the rock board, how much load rock board is taking, how you are putting the shotcrete, you are putting the grouting you are done, how much it is taking and how much pressure is coming. Again, it is a sector wise, as my previous speaker told. It should be not more than 5 meter. It cannot be more than 5 meter. How much pressure is coming, how much load it is taking. If your factor of safety is more than 1.6, no question of the worry. You can go ahead. So this is the factor for the F prime actually. So I will not go in detail, but this is given actually for the first one is for the non-squeezing, and rest of the things are the squeezing. But the rest of the things for the squeezing, out of 5, it is pertaining to your support, whether it is very stiff or whether it is extremely flexible. Accordingly, that factor also, F prime also, that value also can be given. So this is the H is taken, then you will come to know that my ground condition is squeezing and non-squeezing. If my ground conditions are non-squeezing, why you are worrying? Why you will go for Solex board? Why you will go for the cable board? Why you go for the additional the welded wire mesh? My request all of you, if you people are not using SFRS, change that one. Don't use normal shotcrete. Because we cannot say we are following Q and we are putting the normal shotcrete, and for the sake we are putting the welded wire mesh. No use. Whatever. Again the question may be, the cost will increase. No question, you make this thing. Because now I told you, validation also can be done. Suppose your 200 mm thickness of the normal shotcrete is going, it will be 100 mm only. It will be 100 mm only. And it is very clearly written in BIS code. I have no idea about the mining, this thing, whether it is written or not written in our DGMS code. Nowhere we should use the normal shortcut. In civil, it is totally avoided. Total avoided. Shortcut means, if it is not written also, if it is shortcut means it is the SFRS only. So this is the, I think in morning it is, sir has discussed regarding that one also, that maximum unsupported span, how we can decide, it can be. Now, you see, now we have to, from at least something we have to get from my lecture, that roof, it should be separate, wall, it should be separate. Because wall, suppose my Q value is 10, then of course unsupported span will be, length will be more. And because it is related with the Q and ESR. ESR is your safety, because mining, most importance of the mining is safety. ESR is safety only. You take it as what is ESR? Excavation support issue, whatever is given, it is given to the safety. Now, if you see that table, I will not go in detail. If you go through that, that table, access tunnel is giving the more weightage than the main tunnel. Then in the morning, professors have asked why this 10 centimeter only. Now this is a question. Access tunnel is important or the main tunnel is important? Access tunnel is important because the movement will be more in the access tunnel. When you complete your tunnel, you will not go there and you will use it. So ESR is your safety only. Blindly you take it. Blindly you take it. No question this thing. Very hard work this. Norwegian Geotechnical Institute, you please do this thing. And we had done a lot of training program, 3 training programs for the Indian Railway people. Then when they planned a tunneling, major tunneling in the Himalayan terrain. That time we have conducted the training partially in India regarding Q only. We told you have to go with the Q only. The Q partially in Indian, partially in the NGI. So this is the again, as I told you, this is the ESR. So already covered, I will not go with this thing. The excavation method, you people are aware about this thing. And the support methodology, lot of this thing, you people are knowing this thing. Only the history, it is there. Because we should not forget our history. We have a photo of our grandfather. Then we have a grand. We'd like to have it. Like that only. Because lot of this thing, these people have started with the wooden support to this thing RRS. Today we are talking about RRS. That is nothing but that is the development of the philosophy of the support system. So this is as started, already explained lot of this thing. I will show you the example that how we have, where we have used the RRS and how we have used the RRS. And in the beginning also, lot of the problem will be there because nobody will accept in the government sector. New technology accepting for the agency is very difficult. Then they will refer to the one IIT, to the another IIT, to the next NIT. Then from 3-4 areas they will get a yes, you can go ahead with this thing. Then only they will execute the work. This all is already covered. And the support capacity, as I told you, this is the very important. And the engineering geologists or they are not the normal geologists, they are the engineering geologists and the mining engineer. They can do this thing. As the Excel program we can develop that for the software. As sir told this thing for all this, the Hook and Brown failure criteria, the RS software, RS data is there. One software is there. Yeah, Manoj Burman, Dr. Manoj Burman is the nodal person in the India for the rock science software Canada. You can approach that person, only few values are required. Triaxial values are required for you people. Triaxial values are required and then automatically nothing is required. For this thing, for validation of the support system, try to develop your Excel program, which is given, because we have developed, which is given in the IS code. So this mesh reinforcement, of course, it is being done. We are also doing, but it is not a part of the support. Whenever as I told in the South India also, we are facing the problem, the high stresses. And high stresses means in the small size of the boulders are there. Because if you go in a detail, of the queue system, and it is written that suppose my first quotients, this is the RQD upon JN, if the value is more than 10, no question of putting the SFRS, only spot rock bolting. But if it is value is less than 10, then the extensive use of the SFRS. And RRS is based on the, if you see that chart, when the value is decreasing below 0.1, what is written? Energy absorption. It is my own, steel is not absorbing energy. Which is the steel embedded in the concrete, SFRS, that is absorbing the energy. So that is very important. This thing is already given to you. On the right, you see the photograph. I will show you where we have used. This is detailed discussed by the Professor Dev Saab in the morning. This is again, actually, the system is there. Whenever you have to, you go for
Dr.
this
Nathani,
thing.
sir.
Sir, please. Okay, sir. 2-3 minutes, sir. I'll complete. So this is the given in the photo, this the book itself. Only some understanding is required. Anytime we can interact. On the WhatsApp also we can interact. On the Facebook also we can interact. But system is there. How to install for this thing. So these are the example actually where we have done in the tunneling. And on your this thing left, this is the Prasanthi Nilayam tunnel, and this is for the big size cavern in the Telangana state. The height of this cavern is 95 meter actually. So we want to protect the crown. So when we will go benching, during the benching down, we cannot touch the crown. So for the extra safety point of the view, that support we have given for that one. And this pre-grouting again, that my engineers, my engineering geologists, mining engineer, they should try to understand this thing, that the grouting, what is the importance of the grouting, where it is required. I think this presentation is going to be shared. I have written in this thing detail that suppose the volume of the water is more than 5 liter per minute per 10 meter, then we have to go for the grouting. So some guidelines you can use it, and pre-grouting, post-grouting, where it is required, all these things are required. Again, this unstable block, but what I am telling, as my previous speaker, he is having so much of the caution about this thing. This is a different exercise. This is a different exercise, and this already, if you go in the detail, not more than 1% of the area of your whole area, you will get an additional rock bolt. Because when this J, RQD upon J, and this parameter is taken into the consideration already. So this is the additional. Because in this thing under cavern, the fall will be either it will fall or it will slide. And if you go in the detail, and if you read the old books of the Hook and Brown, these calculations are different, and side calculations are different. The side failure will be different, means the support will be different. So from the top, it may fall. By gravity, it may slide. So these are some sort of this thing we have to see. These are the different type of the support where how we are doing, sir. Area of the application, all of us know, very good. Modulus of the deformation, as sir told, from the GSI, best this thing, modulus of deformation, because maximum our models, they are using the Hook and Brown failure criteria parameters only. And Hook Saab was sitting in the Canada, and maximum development is from that area only, US and the Canada. So maximum parameters are, but again from this also modulus of the deformation. So this, sir, I will take 2 minutes. I will not take more than this thing, sir. So these are actually why I am telling, when we have started the storage of the crude oil in India, that time lot of the worry in the India that how we can make it and which type of this thing and that thing. So this is the example of the first crude oil cavern. Visakhapatnam, it is constructed, very complicated structure, sir. Parallel cavities like in mining we are having. Then we have the top, on the top of the cavity also, we have a tunnels like this thing. And this cavern was constructed using the Q only. So we are there for during the construction. Like that only was the second underground cavern and third underground cavern. So far, for the strategic crude oil point of the view, only we have at the 3 locations, 2 at the Karnataka, 1 at the Andhra Pradesh. So this sort of this thing, again, this is the example of the lift irrigation scheme. Not only this thing, but the open excavation also. We took it as a shaft. And using the Q value, we have constructed the big size cavity. And I think you people have heard about this name, Kaleshwaram Lift Irrigation Scheme. The world's largest lift irrigation scheme. We have done 500 kilometer tunneling and 38 number of the underground big size cavern, including 25 meter wide, 80 meter deep, 1 kilometer long, using this methodology only. So this is the, you see this is the example of the one cavern, size of the cavity. If you see, this is the big size of the cavity. Nowhere we have used the cable anchor, only the rock board, shotcrete or the grouting. So this is the another example. This is the second largest lift irrigation scheme in the world, in the Telangana state, the Palamuru Rangareddy lift irrigation scheme. If you see, we are lifting the water actually from this lower level to the, it will go up to this level. In between this thing, again we have a 5 location big size cavity. Now in this project, we have made the world's largest underground cavity, 95 meter deep, 31 meter wide, 750 meter long. 2 parallel cavity, and like that we have at a 5 location using Q system, because if we'll be there, our very simple, we don't want to make this thing, as my colleague told, resin capsule, we will never allow anybody to use resin capsule. Resin, no question, only cement slurry. So like that only, what I am telling, maybe that work is done by my contractor, it is presented by my, the client, but we have to have a control. Something which are not good for my society, we should not allow. So like that only, because if we can make it, now you see, sir, this is on your left, this is the height of this thing, on your dimension, on, it is written here, for this one cavity. That cavity is another, this cavity is 92 meter, 28 to 33 meter, this is. Now you see how beautifully it is cut, using the drill and blast method only. Systematic benching from the top to bottom, systematic support system. This is the world's largest shaft, sir. This is the another shaft. Again, they are the deepest shaft, more than 25 meter dia, and around 150 meter deep. We have made using this technology only, where underground construction was not feasible. In this case, we have converted underground into the shaft structure. And this state only, Telangana, we have made 56 meter dia, 74 meter deep shaft, which is the largest shaft so far in the world, using Q, Norwegian tunneling method. So this is again, sir, this work is going on for Polavaram. If you see on the bottom, this is interesting actually. This is the 12 number of the tunnel. The client came with a different proposal that will go with this thing, and they invited us for taking our opinion, Dev sir. I told Rock is very confident, why you are going with this methodology, we will make with this methodology. Now 12, again this is the first project in the world where 12 number of the parallel tunnels. Now you can see the rock ledges in between this, what's the size and in between this thing. And this cuts, this, yours are Q slope and SMR we have followed for cutting this thing. And of course, I will see, because top of the hill is somewhat here, 750 meter hill we have cut using the SMR and the Q slope. And these tunnels we have excavated, 12 number of the parallel tunnel we have excavated using this thing. Again, this sensor rectification of the tunnels are being done, where we are replacing this steel rib and the lattice girder with the RRS, or the Norwegian method of the tunneling. So this project took for the clearance, because this is the Prashanti Nilaya, means in the Andhra. They send it to the IIT Madras, sir, our report, then to IIT Tirupati, because the RRS again is not very popular. But this was the first project in India where RRS was used. And we have successfully, sir, this project is rectified. So this is all the road tunnels, sir. Actually, again, if you see, as in the for the last 1 week, we are discussing with the IIT Kharagpur that mainly this mining is with the RMR. Actually, in the Himalaya also, like the agency like NHPC, they are following the RMR only. And this all NHI or NHI tunnels, in their tender document, all tunnels they have made it compulsory the RMR, rock mass rating classification banner scheme. But we have changed it completely, no question of this thing. We'll go with the, so now almost, sir, 50 number of twin tunnels we have completed in 2 years, sir, for the NHI. And what is the beauty of this thing, sir? You see, these are the example we, the well is very low cover also. This is the beauty where this the example where the deep cut they have proposed for the excavation, and we proposed this thing after the tender was commissioned. So we proposed that no, it is a deep cut. We will convert into the tunnel. We'll go with our own methodology. So with the Norwegian method of tunneling, this tunnel, they called it as the tunnel number 3. Only the problem where we have faced, sir, we know that we have to go for the open to sky. We know that one. We are aware about that one, that it will be open to sky. But we have taken the precaution.
Sir, be faster.
Sir, then if you see we have followed, this is this area. We have followed the sequential excavation. No question of any disturbance, no question on this. This project was completed. I think this is last. This is the projects are actually for the Singareni. Singareni collieries, they are the design consultant is CSIRO, Australia. So that time in 2018, they have two requirement regarding, one was Q and another was the kinematic, because they told that the data should be given in the kinematic for analysis form only. So we have conducted. Thank you, sir. So this training program we have conducted, 5 days training program for that one. I think it is over. Thank you, sir.
Thank you, Dr. Nathane, for your so valuable presentation with focusing on its application parts in various parts of India. Thank you.
Thank you, sir.
Next technical paper is by Dr. Manoj Namdev Bagde, Chief Scientist, CSIR, Central Institute of Mining and Fuel Research.
So thank you very much, and thank you, Chair. Good afternoon, everyone. So I think it's already, we are approaching 5 o'clock. So how much time, sir, I shall take? Okay. So already it was a good experience and good learning, early morning, and then colleague from NIRM, Dev sir. So actually my presentation is also made like that. I haven't gone much basic details. Directly I will come to the applications points. So this is one of the case study from thick and wide ore body from manganese mine. Little bit having a complex geology and water body presence. So we tried to derive some designing parameters and support system using few empirical approaches. So objective and scope. So we tried to make a prediction of makeup water in one of the area of the mine, that is south extremity. So it is having a water bearing zone. So and then how we can go with the mining, future mining scope in this area. So we derived the shape stopping parameters and support system design considering water bearing zone above. Then friable ore body, I will be discussing that in brief, and having a weak hanging wall and footwall rock masses. So we use various approaches like rock mass rating of Vanue, then Barton's cube, Portwin's graph, and others. I think we talked
other rock mass classification, but no one touched about footprints, so I will try to give some time on that. And another is the lobster's approach. That is also developed for metal mining, but no one covered that also. So that on two approaches I will try to discuss. So then how we can plan sequence of extension considering all those parameters. And ultimately our aim is to ensure safe stoping environment in this south extremity area with high safety considerations. So always our target is, ultimate aim is stability. So this is the ore body, and this is a plunge of ore body due to fault. Here you can see, oh sorry, how to go back? Okay. So here you can see, here footwall become hanging wall and hanging wall footwall because of plunge of the ore body. So plunging anticlinal fold was there, so all these geological structures, vis-a-vis reverse or something like that. And because of this originally running ore body around 45 degrees, it become around 25 to 30 degree only, and it got flattened. So average thickness was 17.5 meter, but due to flatness, it was on the plan 60 to 90 meter wide and thick, and dipping 20 to 30 degree. We can say around average 25 degree. And strike length was 120 meter, and ore reserve was 3.2 million tons of very good quality. So it was very important to extract this ore. So this is somewhat a pictorial presentation of dolomitic cast identified in this area. You can see here some studies were carried out, hydrogeological studies, and some pumping well, and this well was made, and pumping was taken place, and then we tried to find out dolomitic cast, here D1 and here D2 and dolomitic C. This is the ore body around 137 to 180 meter. This is 137 to 180 meter because of some hilly area, so covering hilly region around 30 meter, depth was around 180 kilometer at the lowest level. So next, so from the hydrogeological study, what were the findings? So during mine development, under in situ conditions, the mine inflow will be insufficient. That was one of the major findings. So during blasting and mining operation, the fracture zone, fault zone, and solution channel zone might be activated or might get activated to encounter the predicted flow per day to the tune of 343 cubic meter per day. Another is 1087 cubic meter per day, and and another is 7233 cubic meter per day respectively. So in case considering worst condition, all are activated simultaneously, the peak flow will be in the tune of 8,663 with 4,235 cubic meter per day as a stabilized flow. These are the findings of hydrogeological studies. So thus it is expected that mine management to have arrangement for pumping up 10,000 cubic meter per day. That was one of the suggestions come out from this study. So I will come to rock mass condition directly. I will not talk about basic RMR and all. Already covered, Q is covered, RMR is covered. So you can see here how you can see filled rock balls. Here suspended rock balls, and here, so how friable ore body is. So filled zone and suspended rock balls in friable ore body. So we have determined RMR range in the range of 19 to 29, and that was very poor rock mass. Here you can see, this is a hang wall, and pinkness you can see hang wall exposure, and again RMR determined by 25 to 35, and rock mass again very poor. So from the RMR calculations, or after determining RMR, using the charts, so average stand-up time was 10 hours, when span was considered 2.5 meters. So my job was made easier, because earlier speakers already talked about in length, so I don't need to talk about all those things. Here you can see footwall, so shear rock mass near footwall exposure, and you can see how chalks erected just behind the felt zone in footwall. Here crust, mica sheet, flaky, layered, and RMR range was 1929. I mean overall you can say that the poor rock mass conditions existing. So these were the rock properties tested in the laboratory, hang wall and footwall rock. You can see granitized schist, quartzitic schist, dolomitic schist, and quartz schist were present. And compressive strength were ranging from around 22 megapascal to around 57 megapascal. And if you can take average, so it was coming around 35. Accordingly, Young's modulus 6 megapascal to 10 megapascal. And accordingly, other parameters like cohesion and internal friction angle. So these all properties were used in RMR and other numerical modeling approaches. So this is the main slide I will talk about. So room and pillar design. We have designed considering all these parameters, complex structures, water bodies presence, and all those things. So I put in one table. This can see different approaches, empirical, and then rock mechanics, analytical approaches. So we have used number of approaches, and then I have given results over here. So like Lobster's approach, this talks about, it takes into consideration all RMR, Binoisic RMR, Barton's Q, Taylor's approach, and he tries to combine together. And he has proposed one of the approach developed in South African mines, and that is mostly for bauxite and mostly for flat dipping ore bodies or something like that, like bauxite. So here pillar strength, and again this approach is very good because it talks about pillar strength estimation also, and as well as it talks about the support system designing. So we have very good monograms. Just use the monograms, charts, tables, and it's very easy. But then again your conditions should be suitable, like dipping is low or something like that. So I should have added more slides about lobsters, but I haven't done it because of, again, constraint of time. So from this, we have determined pillar strength, and then pillar load, and safety factor is what 0.64, and usage, this is usage is, in situ strength we determine from different parameters. So it was around 22 megapascal. So sewerage approach also we use, again, used for coal mines, but again we tried to use for metal mines because the seam was dipping and surface was shallow type. So from this you can get a safety factor around 1. We use a tributary area method. Again, tributary area method is like a 3-dimensional approach. So generally we use in coal mines, but again we tried here. So pillar load was 7.74 megapascal, and we considered here pillar size is 50 into 6 into 2.5 meter. So vertical test only, taking gamma eta something like that. So pillar load was coming 5 megapascal, and when we take, pillar strength, lobsters or sewerage, so safety factor was coming 1, just at 1 using lobsters approach, and sewerage it was 1.4. And then vertical stress was 0.027 H is taken, H is 185 meter. So why we are using all these approaches? It adds to your confidence. Once you have in your hand all parameters, it will give more confidence to you, and you can accordingly choose the parameters and design your final parameters. So when you take a total stress, so pillar load was 12 megapascal here. So here in total stress we try to add horizontal stress also, which is equal to vertical stress in our conditions, and we try to add water stress also because of water, like head of 160 meters. So in that case, the safety factor was coming very down. So again, if water is coming into picture, so naturally this safety factor will go down, and failure will be, obviously will be there. So like we have seen earlier, some figures where we put chalk immediately to the footwall or something like that. Shape pillar size, so from the coal mine regulations we have already charted. We tried here, that also. So that lobster it was coming 25 meter, and it matches with the coal mine regulations also, like 19.5 meters solid, and safety factor was coming 1.5. So we have used again Oberdoel, Hook and Brown, and here pillar load was using tributary area method, so it was coming safety factor 1.8, here 1.8 for 6 meter deep, 6 meter deep and 5 meter post pillar. So finally, from using all those things, 6 meter deep, pillar size is, I think, was sufficient enough, and 5 meter was post pillar. That was seems good. So what next after doing all those things? So we have now parameters from all these approaches, but again support requirements. only talks about you can take it from RMR, QR, potential stability graph method, or even Lobster's approach. So here from RMR range was this much. So was poor class, span was 2.5 meters. So what it talks about support system? 4.5 meter long systematic bolt at 1 to 1.5 meter. And cable bolt was 13.5 meter plus circuit plus steel sets. Q 0.04, extremely poor, span is 3 meter. And when it comes to support, 1.5 meter long bolt at the spacing of 1.2 meter and 8 meter long cable bolt plus circuit of 15 centimeters. So potential stability graph. This is particularly used for open stopping methods. So, but when we are using it for man entry method, you can give always adjustment factor. Nothing wrong in that. Though even it is for non-man entry methods. So hydraulic radius was 5. So what is hydraulic radius? They take into consideration hydraulic radius means surface area to perimeter. But it talks about surface area and shape also. Shape and size both takes into consideration. And this EN is modified Q number. So stope length was 30 meter suppose. L is 30 meter, width is 70.5 meter, and height is 30 meter of stope. So stable zone. So when HR greater than 6 falls in caving zone, hence stope width at 20 meter. So greater than 6, whenever a hydraulic radius goes more than 6, it will go into failure zone. So better is keep to stope width at 20 meter, something like that. So span comes at 22 into 22. So support comes at 1.5 meter long, at 1.6 meter recommended, and 12 meter long cable bolt at 1.6 meter spacing. So what is the potential stability graph method? This is somewhat one graph is there. I will not go again much detail. So here I have given different conditions. So here you can see stable zone, and once it hydraulic radius goes more than roughly you can say 6 or 5 is in stable zone. So we can go up to the stope width up to 20 meter. So now we have all these parameters. So how to corroborate or how to do validation or verify our results. So another tool is numerical modeling. So we are using two-phase, two-dimensional using phase program, approx science. And here we can see this is a sand field material. This is a sand. So we have given a sand properties. This is a 6 meter deep pillar. So stope 1 extracted and backfilled, and stope 2 extracted. And then we try to study this, this distribution. This is a horizontal stress developed in deep pillar, this pillar, and this is in extracted and backfill. So it's standing on its own. So backfill we generally simulate. We consider that it's standing on its own weight. So horizontal stress developed in deep pillar is minimal and thus found stable. So backfill column found to stand on its own since stress developed are minimal. This is again vertical stress developed in deep pillar are at higher side in case of low sand field material properties and still found to be stable. Here. Still it is stable. So backfill column found to stand on its own since stresses developed are minimal. So finally, using all those parameters we have in hand, now I have more confidence how we can go ahead with the design parameters in complex conditions. So recommended safe stopping parameters and support, room and pillar, mining with post pillar. So working height and width is 2.5 meter. Existing is 3 meters, so we reduce to 2.5 meter considering the conditions here. And stope length and height we have restricted to 30 meter. Stope width, it should not go behind 20 meters, so maybe 17.5 to 20 meter. When HRX is 6, working is unstable and failure inevitable. That already we discussed from the potential stability graph. So rib pillar width is 6 meter, post pillar width is 5 meter, and wall pillar 5 meter, 3 meter. You can split if you want. That judicially, robbing or something like that they say. So support system finally, 12 meter long cable bolt at 1.6 meter along with roof bolts in between. That will be 1.5 meter long in between. So and on an average spacing will be some 0.8 meter to eliminate scare sets. So props, chalk, scare set as and when required to support unstable zone if any, and other parameters as per prevailing existing practices. So room and pillar with post pillar is just nothing but the variant of the what they are using, horizontal cut and fill mining. So they can go with this existing parameter, and they can use their existing practice of working or something like that. So for this wide and thick ore body, we try to do another modeling using phase 2. This is a stope 1, stope 2, stope 3, and stope 4. We tried different combinations. So finally, stope 1, these are the all stages we can see. So when P1 is extracted and backfilled completely, when this is completely extracted and backfilled, so P2 should be, by this time 75% in P2, means this should be extracted 75%. This one 50%, means extracted and backfilled, and this is 25% in P4. Like that, this extraction and backfilling process will go. So that your this rib pillar or post pillars are stable. Here, not much developed, you can see. So this was the sequence of extraction suggested. I will not go. I have discussed already. And final remarks: the wide and thick ore body in south extremity of this mine, associated with complex geology structure and presence of water aquifers, was daunting challenge for mining. So the ore was of high grade at 40 to 50% manganese, and estimated ore reserve was at 2.5 million tons. So based on the detailed rock mechanics studies, application of numerous empirical approaches like RMR, QU, Potwin, and Lapsos and others, and numerical approach, the Rumian pillar with post pillar mining was planned, and various parameters were suggested for stoping and support designing. Application of various empirical approaches along with numerical modeling adds to the confidence level and helps in designing optimum as well as suitable support and stoping parameters. Proper instrumentation and monitoring for startup behavior and support efficacy is needed in such conditions. But what I can say, already this panel was successfully extracted, but I am not aware whether any instrumentation data was developed or not. That's a very sad part of the story. Thank you very much. So these are the cause acknowledgements. Thank you.
Thank you, sir.
All right, sir. Thank you. Thank you very much.
Thank you.
Next paper presentation is by Shri Ghanshyam Das Gupta, Executive Director and Unit Head, Khetri Copper Complex, Messrs Hindustan Copper Limited.
A very good afternoon to all the delegates who have come all across the country. I stand before the esteemed professionals of this industry. I didn't want to let this go opportunity. That's why I'm here to be a part of my team's paper presentation. As we are also co-hosting this workshop, Satyanarayan sir said that one paper should be there from your side also. He said basically 3 papers from all 3 units, and then your unit has to do the PPT. Then my team was ready with that. Then I said that I should be also part of this team. So I just became a part of my team which was already preparing this. And basically we are the professionals who do the application part in the mines. In fact, we cannot match the way Professor Deb Saab has briefed us and explained all these methods and systems. And then after that, the others, eminent speakers who were very good at this subject. Of course, we are here with similar paper presentation where we emphasize on why this support design is required, and then how to go in a scientific way. As our DDG sir in the morning said, with time we have moved from science to art, and we are more interested in result part rather than the process part. And then this workshop happens, and then we take this opportunity to say that yes, we should come back to our requirements, that we should be in the process, involved in the process also. So this workshop will definitely take us way forward to that process where we all get involved in understand this and then move forward with the time, like how we actually need to support, design our support system, and what type of support system. This all papers, the conclusions of this workshop will help us. So I thank this, I take this opportunity to thank the DG, Director General Ujjwal Tha sir, DDG Sri Mandekar sir, and our regional directors Ravindra sir and Satyanarayan sir and his team, who have helped us to organize this, be a part of this organizing workshop, and also be a part of the technical paper. Thank you very much. Now to move forward, I just will explain, what we have to offer in the case study. Basically, we have two mines, Kolhan copper mines and Khetri copper mines. There we have, we used to design our support system based on the RMR system. Then slowly we have incorporated the GSI system also, and we are associated with IIT Kharagpur, where Professor Dev Saab guides us to design these support systems. So the GSI chart has been also been used to a larger extent to come out of a support design. I will just explain that. These are the some of the basic definitions of the rock mass classification. I think at the end of the workshop I need not go into all those things, but still I think most of us here can correlate with what has been designed here, why we require this support design, and then why we, how we have evolved over the years. And then further, people like Professor Dev Saab, Satyanarayan sir, and then our DDG sir and all, they keep us on the toes to keep things more relevant to the mines and practical applicability of the mines. That's why we keep researching and improving on that. So this presentation will be highlighting the diverse scientific approach utilized by KCC mines in collaboration with esteemed scientist organizations for determining rock mass classification and designing support, subsequent ground support systems. This is the brief about the rock mass rating system of classifier, which was developed by Beneswicki based on the following 5 parameters. Yeah. Yeah. जस्ट थोड़ा सा टच करके निकलेंगे सर, है ना. So इसमें जो rock mass rating, basically have 5 parameters. These are the 2 parameters, and then the other 3 parameters are put down here. And in GSI system, we don't take care of this first part, that is uniaxial compressive strength. We have the other part on that. These are few pictures where actually the geological formations are described. There are joints in the rock mass, then the discontinuities in the rock mass. From this chart onwards, my friend Binayak Sahu will just proceed.
Thank you, sir. Actually, in the first session, Dev sir has explained very well all the 3 systems, that is RMR system, Q system and GSI system. So I am not going to the detail into that, I am skipping this. Actually in RMR there are, as we all know, there are 5 parameters, and there is a scale for every parameter, and on the side we have to determine the rating for each parameter, and we have to add that to get the RMR. So this has been the practice at both Khetri and Kolyan mines since 2010-11. So, as we got associated with IIT Kharagpur, so he insisted to go with the GSI system also, because it is also an internationally accepted system. So the first questions came, sir, we are in the RMR system till date, where there are 5 parameters, and we get a value after doing the exercise, and after getting all the 5 parameters, we get the RMR value. But in GSI, that is one parameter is missing, that is strength of the rock mass. Rest of the 4 somehow integrated in the system also, because in the left part that it is showing the structures, that is 2 of the parameters of the RMR system, and on the x-axis that is showing the conditions of the surface, that is another 2, that is weatherability and the groundwater conditions. So then we got to know that if we go by this system, and if we calculate the GSI, and if we calculate the RMR at the same locations, the difference will be only in the range of 5% only. But the advantages is that if we are following the RMR system, we have to rigorously go for the laboratory test to get that UCS, compressive strength, because we have to take the core, we have to send it to that lab. But if we apply this GSI system, we don't need such type of laboratory analysis. Instantly, any geologist or a mining engineer or anyone accustomed to the mining sites, he can directly compare the surface in front of his or her to the surface, and he can determine a value from the graph. But sir, there come another questions. But sir, it is just a guess only, because my comparison may be different from someone else's comparison. Even if 2 geologists I will send for the same place, they will give 2 different values. But the thing is, 2 things are important here. The best person to determine this is the geologist, because rock is the first friend of the geologist. They understand the rock structures, features very well than rest of the mining engineers or others. So, we were advised to put the geologist in this job. That is the first thing. Second thing is the training, because to avoid the gap between several persons in determining the scale. So we conducted several training sessions of our geologists and mining engineers, how to use this GSI scale to determine the GSI value of a particular place. So after continuously doing it, even our whole geologist team of Khetri Copper Complex, they are now confident and they know how to use this. And in the next slide, I will explain what additional things that we have added, site-specific things to make it a SOP, so that a complete database we can maintain. This is the actually RMR case, because to determine the RMR, all this data we had collected. Based on the laboratory analysis and field test, the RMR that were derived for, this is the case study of Kolyan, it was 69 for ore body, 60 for hanging wall rocks, and 61 for footwall type rocks. And this is the Bavinsky formula for determine the support. We have put the RMR, support safety factor, density, and the span of the width, and the support load is calculated based on this. So the support design which was proposed by our earlier scientist, we had associated CMRA for this, now SIMFAR. So they had recommended a support length of, rock bolt length of 1.8 meter, 22 dia, at a spacing of 1.25 for a width of 5 meter. And for a width of 4 meter, we can go for a 1.5 spacing. So another case study for Khetri copper mine. Recently, we are also doing it now also. As we learned about the GSI more deeply, so we started taking GSI's values at a very close frequent interval. Even for the entire level, we did the GSI mapping because it was very easy to complete a level within a very limited span of time, because we don't need for a laboratory test. Only we have to think, we have to compare the GSI chart with the surface. Only thing a training, and this is required. So these are the minimum maximum of GSI's values from different levels of Khetri mine. So this is a raw sheet of GSI, because suppose any mine, any executives of mine, they are not using GSI. They want to start practicing this GSI. So they can frame a certain sort of SOP to use this. Because as in the earlier section, devs have told, this GSI value is a integral part of the numerical modeling as a input. Apart from that, if we do the GSI mapping for a mines for an entire level, then we can also have a fair idea how our rock type is varying from place to place and from level to level also. So we in the GSI sheet itself, we added whether it is footwall, hanging wall, crosscut, decline, draw points or others. At which level he is taking the GSI plan, GSI reading, and to be very specific, what is the latitude and departure, northing and easting of that point from where the GSI is taken, and the persons who are taking. We are also noting the names of the geologists who are taking the readings. So if along with the GSI chart, and of course there is a serial number and there is along with the date. So along with the GSI chart, if we will be able to maintain this data, so we can get a very good database for the mine for the GSI mapping of the whole mine. So these are the few examples of different places where we have applied this GSI. Again, this is the NGI chart. I will not explain it. It is already explained. And for Banwas block, we have the equivalent stope dimension that. So for this, the recommended support is 2.4, 22 dia at a spacing of 1.2. That with resin capsule we are following in Banwas block. So this, as for this, our recommendations. So this is the benefits of GSI actually. Actually all the three systems we are already learned in the first session. RMR, GSI and Q. All the three may not be complete by their own with benefits and demerits in all the systems, limitations in all the systems. But all three should be encouraged to be practiced. But GSI system relies on visual field observation structure, surface conditions, making it practical, accessible method for on-site use by working engineers and geologists. This is the advantage of this GSI system. And GSI is applicable to a wide range of rock qualities, for very poor to very good, providing a single consistent index. So this is another benefit of this GSI system. Both RMR, rock mass rating, geological system are scientific basis, because GSI is not replacing, as devs have told, GSI is not replacing RMR. It is adding to the entire system of classification of rock system. So it must be encouraged. However, geological strength index provides a quick and reliable mode of observation of on-ground rock characteristics, enabling quick and dynamic decision making in support estimation across varying rock conditions throughout the mine, and must be encouraged for adoption of in our Indian metal mine conditions. Thank you all. Thank you.
Thank you. Very good presentations.
Thank you.
बहुत बढ़िया फील्ड स्टडी बहुत बढ़िया था.
वो जो टोटली ऐसा बताओ ना कि फॉर रिकॉर्ड्स के लिए रेफर बैक करो तो फिर वही चीज
जी सर one thing I missed sir, so I will just so when we started doing this we sent our geologist, myself, we all went to the mines started recording this value. So then we are just comparing it, putting the values. This is the GSI. We are thinking we are determining the RMR only because in our heads RMR was there deep inside, because that we have studied. GSI was not practiced till 2010-11 I think, after that. So for a check, for every place that we mark the GSI, we took a photograph of that place, and we are just attaching the sheet with that photograph, and we are sending it to the scientific devs also. Sir, ये हमने किया, आप देख लीजिए whether our assessment is right or wrong. So so that will develop confidence in us that we are on the right track. Sir, thank you, sir.
Good. Thank you.
Yes, sir. No, sir. Actually, earlier, sir, only RMR, only the design, support design was based on the RMR value only. So,
no, exactly how you are, where you are using GSI actually, what is the use of GSI?
There are two uses, sir. In the first session, devs have told, for a numerical modeling, it is the input.
No, you
So
see.
that is the one thing.
For, for numerical modeling, MB is also required. You have mentioned in your presentation that if you go with the GSI, not with the RMR, then you can avoid the UCS. But without MB, GSI, how this GSI
No,
can
no, sir.
use as the
I did
modeling?
not tell we will avoid UCS. Just I will repeat what I told. Till we are not accustomed with the GSI, we are not practicing GSI, we are aware of the RMR system. So RMR system, we have all went through the Paul committee report. There are 5 parameters, and the top one is the UCS. That is the strength in megapascal. That is the thing. So it has got a rating also. So from the scale, we determine the UCS, then we put a rating, and that rating adding to rest of the 4 ratings, we get the RMR value.
But what I am telling, this thing, when we talk, one GSI is simply one of the rock mass classification. If you want to use in the design, without other parameter, this parameter is having no value.
No,
GSI is having no value.
This is one of the parameters. This is not this.
And again, for each time, because you see, when the tunnel we are mapping and we are going for the RMR, every time no need to send the sample for the laboratory testing. We have a Smith hammer, we have a geological hammer. And geological hammer also we can, and UCS in the, this is a range, not a value.
Yes, sir.
For the UCS in the RMR, this is a wide range. And exactly if you use this east wing geological hammer or the any point load test, you will get a UCS value. So that is not a issue. But what I am telling, because this, we should be very cautious when we are telling that GSI. One part is normally geologists are using for the classification. So that chapter is ended. Suppose we will say that it is for the design, that without triaxial testing data, this GSI is having no value.
No, no,
That's
sir. Triaxial other tests are there. Oh, sir, I think Dev sir will reply better.
After they see what they are doing is, see they are giving GSI, recording GSI and giving us, okay, to IIT Kharagpur. And yes.
Sir.
The MB what you are talking about, so we'll be estimating. Yeah. So
Sir,
their
sir,
job is.
Our motto is GSI system. For some of the mines, it may have been a new concept. So when we'll think GSI, then how we should move forward. So that is the thing. Thank you. Sir.
I thank the chairperson, Shri Vinod Rajak sir, Director DGMS, and co-chairperson, Shri Arnava Ghosh, General Manager Mining, and kindly take your seats, please. As we near the conclusion of this workshop, may I invite Director Mining Ajmer Region 1, Dr. I. Satyanarayana, DGMS, for panel discussion and recommendations of workshop. This panel will be chaired by Professor Debashish Deb sir from IIT Kharagpur and co-chaired by Dr. M.N. Bagde and Shri A.K. Nethani sir. I request panel to please come on the stage and take their seats. I now hand over the dais to Dr. I. Satyanarayan sir.
First of all, on behalf of DGMS, IIT Kharagpur and SCL, I thank you all the speakers and all the delegates for active participation in this workshop. There are a lot of recommendations were deliberated, and most of the recommendations are regarding the use of RMR, GSI and Q system and numerical modeling. Now we display the draft recommendations here. You can observe what are the observations that are made and summary of the points. Here we are displaying, and you can make any corrections or suggestions in the draft recommendations. So there is a procedure also, how to calculate the support, how to design the support, how to design the slope. There are step-by-step procedure. There are appendixes in this one. Three appendixes are there for different purposes. For underground, for open cast, and for total overall rating. You can use there are already references are given in the recommendations, and almost all the tables are given in the this recommendation part. If you have any doubt, you can ask panel and clarify it. So just scroll it. So first recommendation is, this is the first is a brief. We have deliberated different companies, IITs, as I said, 4 pillars of the mining. That is mining and 4 pillars of mining industry. First one is the DGMS, regulatory agency. Second one, institutions, academic institutions. Third one is the scientific institutions like NRM and SIMFAR. And fourth is the mining companies. So 4 pillars of mining industry are here, and we discussed a length. So out of these discussions, there are first one is the rock mass rating is best suited for coal measure rocks, tunnels and shallow depth civil engineering excavations. It is already given, reference is also given there. It is widely used to estimate the stand-up time of excavations and to determine tunnel support requirements. While RMR has application in tunneling, mining and slope studies, it is more appropriate for sedimentary rock masses and is generally less reliable for metamorphic and igneous rock masses typically encountered in metal mining. Okay, this is the first recommendation. My first recommendation is where we generally use the rock mass rating that we told here. Second one is the modified basic RMR for application in hard rock mass was recommended by Cummings. This system incorporated additional parameters such as blast damage, in situ stresses, extraction ratio, and major geological structures, support design charts for drifts, and their intersections based on MBR are also provided. What I am telling you is that all the observations, based on these observations, we will recommend it. Okay. Third one is the Q system evaluated rock mass quality using 6 key parameters. Already we told it. Next, fourth point. Come to fourth point. The geological strength index developed by Wook and Brown in 1997 quantifies rock mass conditions using 2 parameters, structures and surface conditions. GSI is now widely used in mines, tunnels, caverns and slopes. Importantly, it forms the basis for estimating rock mass properties under Wook and Brown failure criteria and is integral to most numerical modeling software used in rock engineering. So in India, metal mines are advancing to deeper levels, often behind 1000 meters through odd and competent metamorphic and igneous rock formations. These formations contain multiple discontinuous giants, slip planes, faults, and pollutions and are subjected to high in situ stresses. Therefore, Q and GSI are more appropriate than RMR for stability evaluation in such environment. Stability analysis in mines begin with estimating rock mass quality, followed by support design using analytical or numerical modeling or established charts and tables. International experience demonstrates that Q and GSI systems are widely used for rock tunneling and deep mining. The Norwegian Geotechnical Institute has developed standard guidelines for support design using the Q system, which can also be adapted to GSI system. These guidelines are recognized by the International Society of Rock Mechanics, which frequently conducts training courses to promote their global adoption. In India, Q and GSI systems are increasingly being adopted for rock mass classification system in tunneling projects involving giant earth, discontinuous or squeezing ground under varying stress conditions. Metal mining operations should adopt these methods more widely for improving the stability of underground workings. The Q slope method developed by Barton enables determination of slope bench rock mass quality and estimation of stable bench slope angles. These parameters can then be used to derive overall slope angles. The Wook-Brown failure criteria, one of the most widely used rock mass failure models, incorporates a GSI as a critical input parameter. Numerical modeling software uses a GSI adjusted rock mass properties, including strength and deformation models, to obtain realistic results. This accurate estimation of GSI is essential for numerical analysis and support design. Here, all the along the observations, there are some scientists, name of some scientists are given in the references. Okay, you can see the papers also, there are papers from where the quote was taken. Next, these are the observations what we learned today in this workshop. Finally, we are coming to the recommendations. First recommendation is the GSI and Q values shall be calculated by practicing geologists and mining engineers at multiple locations and levels based on the complexity of geology and geotechnical domain within underground mines. This is the frequency of the collection of the samples that should be decided by the complexity of the geological and geotechnical domains. Structured training shall be provided to these personnel for correct application of these systems. As in the last presentation also, it was told that the training is very, very important to identify the number of giants, persistence and aperture of the giants. It is very much important. Second one is it is time for the Indian metal mining sector to adopt QO and JSI as standard systems for rock mass classification and support design. RMR shall gradually be replaced by QR GSI. As in the morning, Dev sir as well, GSI is nothing but RMR or RMR minus 5, depending on the ratio. So, more or lessly RMR or GSI is equal, and in most of the numerical modeling we are using the GSI. So, it can be replaced by QR GSI, particularly in RMR, and shall be incorporated in technical scientific study reports. So, totally nowadays the numerical modeling techniques are, the softwares are written on Hook and Brown failure criteria. So, for that one the input parameter is the GSI. So, in numerical modeling mostly GSI is being used. A step-by-step support design procedure using the Q system is provided in Appendix A, and application of GSI in bold design and numerical modeling is outlined in Appendix B. There are appendices, 4 appendixes. You can see the step-by-step procedure, and we circulate these draft recommendations. You can comment. We have already formed a WhatsApp group, and in the WhatsApp group also, if there is any changes or any recommendations that is valuable, we can incorporate later on. Okay. These are the draft recommendations we are presenting here now. The NGI support design chart shall be used for determining support requirements in drives, drifts, corkscars, and other underground excavations. Installed support systems may initially be benchmarked against the NGI recommendations. So, the Q system, initially we benchmark the Q system, then we, if while making the drivages, we suppose we encounter any discrepancies, we encounter any complex geology, then we can scientifically investigate it, and suppose there is a additional support, then we go for the additional support. Like that, first we benchmarking, we are using the Q system. Then we evaluate our drivages and support system. So, next fourth point is in slope stability analysis. Overall slope stability shall be assessed using rock mass properties such as cohesion, friction angle, adjusted through GSI values, measured at different slope locations depending on the complexity of the geology and geotechnical domain. So, generally, as I told earlier also, most of the scientific studies that what we reviewed, they are using the intact rock properties. The old scientific studies I am telling, now everyone has got the knowledge about the conversion of the intact properties to rock mass properties. Sir has given in the morning an Excel sheet. So, from that one, we can convert into rock mass properties, then those properties we use in the numerical modeling. So, a brief overview, Q slope method shall be used to estimate rock mass quality and bench slope angles to validate the slope stability analysis. A brief overview is provided in Appendix C. Scientific organizations, academic institutions, and mining companies shall adopt Q or GSI based approaches for adjusting rock mass properties to replicate field conditions in numerical models, for bringing uniformity in stability analysis, and generate data to develop support or slope design charts for site specific conditions. So, as I told earlier, we are using the other country Q system and other things. We need to, if you follow uniform standards, uniform guidelines, then we can generate data, and through regression statistical analysis, we can develop some formulas to our own indigenous conditions. Periodical and real-time support performance monitoring like load displacement, pillar stresses, and roof displacement is crucial for understanding rock mass behavior and validating numerical model outcomes. So, numerical model is this is a estimation. Estimation, there we need a validation of the models. So, for validation of the model, we need the monitoring. So, through monitoring results, we can evaluate our model, whether our model is performing in the way we decided, or is there any deviation. We can do back analysis also. So, by doing back analysis, we can estimate the properties also. So, this is very important for real-time monitoring of the slopes or stopes or this support system. Next, It shall be carried out at various locations near the active stopes, junctions, geological disturbance, where should be the monitoring shall be carried out. So it shall be carried out at various locations near the active stopes, junctions, geological disturbed areas, and a trigger action response plan shall be developed based on numerical and monitoring data. Seventh point is slope bench movement shall be monitored regularly or in real time to generate heat maps. Heat maps of displacements and validate the slope stability analysis. Zones showing major displacement shall be identified and TARP shall be developed based on numerical and monitoring data. Sixth point is for underground and seventh point is for open pit mining. Eighth, mine management shall establish a dedicated geotechnical cell comprising trained geologists and mining engineers with expertise in rock mechanics, ground control, and supporter slope design. This team shall be regularly kept updated in the application of GSI, Q, and Q slope method, stability analysis of slopes and monitoring to develop robust mine or supporter slope design. These are the 8 recommendations. Now I request all the delegates for their inputs, for their views, so that we can, if you want to change anything, if you want to add on this one, otherwise we go for the appendices. All of you agree with these recommendations? Okay. Sir? Anybody wants to speak? Anybody wants to add? Anybody have any objection on any recommendation? Okay. Thanks a lot. So these are the different appendixes, how to evaluate this estimate Q values at different locations, and everywhere it is basically the appendixes are prepared by the Dev sir, and we have discussed a lot for about 2 to 3 days, and even references we included in that one. All the tables so that the mine management can easily use these methods. So everywhere there are tables. Some tables we have given in the appendix D, so that they can refer the tables for this appendix. So this is about underground support design. This is application of GSI in bolt design and numerical analysis. GSI chart is there. Determination of bolt load, ASR, and this formula actually is given for RMR because RMR is more or equal to GSI, that is replaced by GSI. So these are the different formulas. Next, coming to the appendix C for slope modeling, Q slope and slope modeling. Appendix T is basically tables what we use in these 3 different procedures. We can use these tables. So this is the ready-made material. You are not going to refer any other book also. All the tables and formulas are given in this appendices. Directly you can go for it and you can use it. Thank you. Thank you, one and all. So I, again, on behalf of DGMS, IIT Kharagpur and SCL, thank you all the delegates from educational institutions, from scientific organizations like NRM, SIMFAR, and from mining industry. Thanks a lot for your active participation in this workshop. Sir, yes. Mic change.
Yeah, the number 8, I would like to emphasize that the mine management shall establish a dedicated geotechnical cell. If it can be done, it will be excellent. Otherwise, at least you have to identify some people, some geologist and mining engineer who will be given this task, because they should be dedicated to this, this work. This way, I think this can be implemented very judiciously. Otherwise, if they are doing some other work and this is a part-time thing, then it will be very half-hearted effort will be there. So that's why I want to just highlight all the mining company officials that this must be emphasized, that there are 1 or 2% who are dedicatedly working in this area. Means their job, main job will be this data control engineer or ground control engineer. What? Thank you.
Okay, thank you. Thank you.
Appeared it might be very good for this technical purpose and this very sophisticated tool. But for small mines and for unorganized mines, how can we make it convenient for them to implement?
They can make a group of mines collectively. They can make a for particular per area per district. They can make a technical cell, sir. Geotechnical cell for a group of mines.
Particularly small underground mines and unorganized mines, they are not having expertise. They cannot understand the technical details, how to reach there. That is, we have to think. More simply, if it is more simplified version, more easy to do approach, particularly that you have to, I think.
They can, otherwise they can take the help from the organized sector, sir. From the organized mines, they can take the help. They can take the help from the geologist of the organized mines. We have VTC, sir. We have now in unorganized sector, sir. Just like Sri Cement and Ultratech, they have VTCs. They are providing training to the unorganized mines, sir. Like that, the organized sector can extend their support to the unorganized mines.
That mechanism should also be, I think, when it should be mentioned.
Included, okay, sir.
That will be better.
Okay. Sir, actually, as this thing civil, the people are doing, small contractor, they are hiring the services from the other organizations, expertise. So like that also this mining small companies, they can hire the expertise of the engineering geologist or the mining engineer for the mapping.
No, for there are many small stone mines, because slope stability is also there, no?
But for small, again sir, for small mining, work will be small only. Say,
yes.
1 and 2 days, they can take the help.
Yes, that mechanism should
they
be
can
there.
take the help because it is not, because this is the one parameter. Suppose for example, GSI is wrong, then whole concept has gone.
No, I am talking not about concept. It is a very good one.
They will go for the outsourcing.
The implementation
will be the
for
best
small
choice.
mines and unorganized mines. There are few mines in underground, they do not have any mechanism for even haulage system also, manual underground mining. Still there are existing. So for this also we have to think, so that some mechanism should be established. No?
Okay, sir. This one looking at 9th point, we shall add, sir. The small, we include the as a 9th point, sir. recommendation. We add it like this. Sauji, write down. Huh? Ninth point. What sir? Ninth point. Ninth point, last. Last recommendation में. This is observations, recommendation. Last. Down. In unorganized sector, small mine owners can take help from the may take help from the nearby organized sector, nearby mines in organized sector of organized sector for or Sir, scientific institutions or educational institutions? Sir. Add करेंगे sir? Or any other?
Or any other expert from?
Or other? Any experts? Other? Or any other expert organization, or
in independent they can approach the individual also. Individual के पास जा सकता है.
Any other experts? ठीक है.
नहीं ठीक है. Expert पे other experts.
any other experts having expertise in rock mechanics and ground control.
Any other experts in this area?
In the field, in the concerned field.
Yeah. In the
Or any other experts in the concerned field. Okay, sir? Okay. आप कुछ बोलना? Okay. Thank you. Thank you, sir.
Thank you, sir. Thank you all. And now it's time to express our gratitude by presenting a token of appreciation for the presenters and principal authors of technical sessions. For this, I request Director General DGMS, our Chief Guest, Shri Ujjwal Taha sir, to kindly present mementos to paper presenters and principal authors. I request sir to kindly come to this stage. For technical session 1, I invite Dr. Islavat Srinivasa Rao to kindly come to stage and collect your memento. Please give a huge applaud for the speakers. They prepared really well for their papers. Next, I invite Shri Ayan Giri, Head Technical Services, AGM, Messrs Hindustan Zinc Limited, to kindly come to collect your memento. I invite Binayak Banerjee, HOD Geotech, Ram Zinc, Hindustan Zinc Limited, to kindly come and collect your memento. Next, I invite Dr. Ajay Kumar Nethani, HOD Engineering Geology Department, National Institute of Rock Mechanics, to kindly come and collect memento. Please give a huge applaud for the speakers. Next, I invite Dr. Manoj Namdev Bagde, Chief Scientist, CSIR, Central Institute of Mining and Fuel Research, to kindly come and receive your memento. Now I invite Shri Ghanshyam Das Gupta, Executive Director and Unit Head, KCC, Hindustan Copper Limited, to kindly come and receive your memento, and Mr. Binayak Sahu, AGM, Mines, K3 Copper Complex. He was a co-presenter with Sir. I now invite principal authors who could not present the papers, but we really are grateful to them for their contribution to the souvenir. Dr. Rakesh Kumar, IIT Kharagpur. I request him to kindly come to stage and collect your memento. His paper is on assessment of stability of room and pillar stops and design of supports based on GSI and Q systems. Next, I invite Shri Binayak Banerjee, Messrs Hindustan Zinc Limited, to kindly come and receive. Acha, he has received. Sorry. Next, I invite Shri Sanskar Mahore, NIT Rourkela, if he is there, and I suppose he is also not there, and Dr. Yugal Kishore from NIT Rourkela may please collect memento on his behalf. He has contributed a paper, an investigation on variation in stand-up time with the depth of an underground hard rock mine, considering RMR as key factor. Now I invite Shri Amal Roy from Hatti Gold Mines Limited to kindly come and collect your memento. He has contributed his paper on rock mass classification and support design in Hatti Gold Mine. Now I invite Dr. Ashok Jaiswal from IIT BHU to kindly come and receive your memento. He is also not there. Anybody from IIT BHU? Any delegate? Okay. We further move to mementos for chairpersons and co-chairpersons for technical sessions. For technical session 1, I invite chairperson Shri K. Ravinder Sir, Director Ajmer Region, to kindly come and receive your memento. I request Deputy Director General Sir Shri R.T. Mandekar to kindly present the mementos. They all are presenting mementos. This is a great honor for all of them, sir. Next, I invite co-chairperson Shri Ram Murari, IBU CEO, Messrs. Hindustan Zinc Limited, to kindly come and receive your memento. For technical session 2, I invite Chairperson Shri Vinod Rajak Sir, Director DGMS Northwest Zone Udaipur, to kindly receive your memento. Next, I invite Co-Chairperson Shri Arunava Ghosh, General Manager Mining, Hatti Gold Mines Limited, to kindly come to stage and receive your memento. Mementos will be presented to DGMS officials for their everlasting cooperation and guidance. I invite first Director Mining DGMS, Shri Umesh Madhukar Rao Savarkar, to kindly come and receive your memento. Next, I invite Shri Praful Ranjan Thakur Sir to kindly receive your memento. Next, I invite Director Mines DGMS Shri Tom Matthew to kindly receive your memento. Next, I invite Director Mining Shri Sanjay Kumar Gimedi to kindly come and receive your memento. I invite Shri Nagendra Ram Shri Ram, Deputy Director Mining DGMS, to kindly come and receive your memento. Next, I invite Shri Vishal Goyal, Deputy Director Mining DGMS, to kindly come and receive your memento. Next, I invite Shri Tejawat Naresh, Deputy Director Mining, DGMS, to kindly come and receive your memento. I invite Shri Tangalapalli Hari Prasad, Deputy Director Mining, DGMS, to kindly receive your memento. Please give applause to all the directors and deputy directors. Next, I invite Shri Upender Rapolu to kindly come and receive your memento. He is Deputy Director Mining, DGMS. Next, I invite Shri Rajneesh Kumar Seegar, Deputy Director Mining, DGMS, to kindly come and receive your memento. Thanks, sir. I request our dignitaries to kindly take your seat. Now I would like to invite Shri Ghanshyam Das Gupta, sir, Executive Director and Unit Head Khetri Copper Complex, Hindustan Copper Limited, for vote of thanks.
Well, we are at the end of this national workshop. This workshop would be incomplete without two things. One is vote of thanks, for which I am standing here. The other thing which we, slightly missed out, and Satyanarayana sir has rightly marked us out, that our anchor, Madam Dr. Deepika Khurana, who is our Chief Medical Officer for Khetri Mines, Khetri Hospital. I invite our Director Operations, Sri Sanjay Kumar Sinha ji, to come on stage and hand over the memento to our doctor. She has done a wonderful job. She has left her medical field for 2 days and come here. Thank you very much, madam. Thank you very much. Thank you, sir. Honorable Chief Guest, Sri Ujjwal Thaji, Director General, DGMS Dhanbad. Esteemed Guest of Honor, Sri R.T. Mandekar ji, Deputy Director General, Northwest Zone, DGMS Udaipur. Sri Sanjay Kumar Singh ji, our beloved Chairman and Managing Director, Hindustan Copper Limited. Sri Sanjay Kumar Sinha ji, Director Operations and Additional Charge of Director Mining and Nominated Owner. Sri Satyanarayana ji, DGMS Ajmer. Sri Ravindra sir ji, DGMS Ajmer region. Distinguished officers of DGMS from various zones and regions. Eminent academicians, Professor Debashish Deb and his team. from IIT Kharagpur, our scientific institutes, NIRM, SIMFER, mining fraternity from across Rajasthan and the country, officers of SCL, KCC and other units of Hindustan Copper Limited, ladies and gentlemen, a very good evening to all. It's my privilege to propose the vote of thanks at the conclusion of this meaningful, knowledge-rich, full-day national workshop. This platform brought together the regulatory leaderships of DGMS, academic excellence from IIT Kharagpur, scientific institutes like NIRM, SIMFER, and the rich experience of mining professionals from various organizations. I extend my deepest gratitude to all of you for making this event truly purposeful. The first half of the workshop, entirely led by Professor Debashish Deb sir and his team, was indeed outstanding. The detailed deliberations on rock mechanics classifications with special emphasis on tools like GSI index, RMR, Q system, and their practical implications on support design have enriched every participant. The ability to blend scientific understanding with real-time mining challenges has set the perfect tone for the day. We also benefited immensely from the subsequent sessions delivered by various distinguished speakers who touched upon practical issues of understanding underground stability, support optimization, and modern approaches being adopted in metal mines across India. As a mining engineer with more than 3 decades of experience and working across various organizations, I personally resonate with the importance of today's subject, as mines of Khedri Copper Complex, Khedri Mines and Kulihan Mines have long been practicing continuous and improving upon scientific design support systems. Workshops like this inspire us further to align with global best practices and strengthen the stability and safety of our mine. My heartfelt thanks to DGMS officials, especially DG sir, DDG sir, DMS Satyanarayan sir and Ravindra sir, whose guidance and presence today have elevated the seriousness and depth of this workshop. I express my gratitude to our Honorable CMD sir for his constant encouragement and vision, and to our Director Operations Sri Sanjeev Kumar Sinha sir for guiding us not only in operations but also motivating us to adopt better mining practices and get involved in this type of workshops, seminars. I also thank all dignitaries, speakers, panelists, our expert guests from IIT Kharagpur, scientific institutes, and participants who have traveled from different units and companies. A sincere appreciation is also due to the organizing team from SCL, KCC, DGMS Ajmer, and Hotal Clarks Amer for their excellent arrangement throughout the day. Finally, I express my gratitude to all delegates whose active involvement ensured that today's workshop becomes a milestone in the journey of improving rock stability and safe mining in our country. Thank you once again. I wish you a very pleasant evening ahead. Jai Hind, Jai Suraksha. Thank you.
To conclude this eminent workshop, let us now all rise and pay respect to nation by heartily singing our national anthem.
Janagana mana adhinayak jaya he Bharat bhagya vidhata Punjab Sindh Gujarat Maratha Dravida Utkala Vanga Vindhya Himachala Yamuna Ganga Uchchala Jaladhi Taranga तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जन गण।
With this, we conclude today's workshop. Thank you all for your active participation and valuable contributions. May the knowledge shared here today guide us towards safer and stronger mining practices in the future. Now all are invited to proceed for high tea, but before that I think a group photograph is desired. Right, sir? So, yes, sir, we will first have a group photograph.